Let's solve Unit 1 Discrete Structures and Optimization questions. Let G of V, E be an undirected graph with L edges. Then the sum of degree of all vertices is equal to. We know there is a theorem called handshaking theorem. So let's take a graph G. Let this be an undirected graph with m number of edges. So V is a set of vertices and capital E is a set of edges. The count of edges is given by m. The sum of degree of all vertices will be equal to twice the number of edges, that is mentioned as 2 into m. Here the representation of the count of edges is L. So how many edges will it be equal to? It will be equal to 2 into L count of edges. Option number 1, 2L will be the right answer. So what is a degree of a vertex? The degree of a vertex in an undirected graph is the number of edges incident with it, except that a loop at a vertex contributes twice to the degree of that vertex. Let's take two vertices V1 and V2. Now there is an edge between these two vertices. Number of edges incident with a vertex means how many edges are involving V1. That will be the number of edges incident with it. If it is a directed graph, there is something called in degree and out degree. How many are going from a particular vertex, how many edges are coming towards a particular vertex, that constitutes in degree and out degree. So here it is undirected graph. So whatever edges involve a particular vertex, that will be the number of edges incident with that particular vertex. So we'll just see examples now. Let's take the following graph. Just count the number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then what should be the sum of degree of all vertices? It should be 2 into the number of edges count 9, which is equal to 18. Now we will manually check the degree of every vertex and then sum them up together to check whether we are getting 18. So what is the degree of A? 1, 2 edges are incident to it. So the degree of A is 2. What about degree of B? 1, 2, 3, 4 edges are there, so they have given 4. What about degree of C? 1, 2, 3, 4. So C is also having 4. What about D? Only 1. So we have the count of 1. What about E? 1, 2, 3. So E has 3. What about F? 1, 2, 3, 4. So F is also given 4. What about G? There is no edge connected to G, so G has a degree of 0. Now we have to count the degree of all vertices. A it is 2, B it is 4, C it is 4, D it is 1, E it is 3, F it is 4, G it is 0. Just count 2 plus 4, 6 plus 4, 10, 10 plus 1, 11, 11 plus 3, it's 14, 14 plus 4 is 18. So this is how they are calculating it using 2 into L. Now let's take another graph with loop. How many number of edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10th edge and this is 11th edge. The count of edges is actually 11 here. What about the sum of degree of all vertices? It should give 22. Let's check whether we are getting 22. Just remember, the loop at a vertex contributes twice to the degree of the vertex. So now we will calculate for A. Degree of A is 1, 2, 3, 4. Degree of B is given as 6. 1, 2, 3, 4, and we have to count the loop as twice to the degree. So this loop is taken to be 2. Already we have 4. 2 plus 4 will give you 6. So count the loop as 2. The remaining edges will be 4 and all together you will have B is equal to 6 as degree. What about C? 1. What about D? 1, 2, 3, 4, 5. What about E? 1, 2, 3, 4, 5, 6. So E is also having 6. Just count A plus B plus C plus D plus E. 10, 11, 16 plus 6 is 22. So this is how we'll be working out. Even when they give some graph and ask you to find the number of degree of vertices or the sum of degree of all vertices, I think now you will be able to compute it. That's why I included a graph without loop and with loop. While counting edges, this loop is just one edge. But when you count for the degree, you have to remember it contributes twice to the degree of the vertex. Next question, 40 software professionals were interviewed for a job. 25 knew Python, 20 knew Java and 7 knew neither language. How many knew both the languages? Out of 40 software professionals, they have told 7 don't know any of the languages. You have to exclude these 7 people. So the number of software professionals who knew at least one language can be computed by subtracting 7 from 40. 40 minus 7 will give you 33. Now from this 33, we know 25 knew Python, 20 knew Java, and we have to find how many of them know both the languages. So let's see it in the form of Venn diagram. Python is what we have mentioned as P, so the count is 25. This is actually with respect to the complete P. Similarly, if we take J, it is completely 20, the Java language. And 7 people are not involved in both Python and Java. Now the question is, how many people know both the languages? It means you have to find the intersection point of Python and Java as per this Venn diagram. Since we are using intersection operation denotion here, we know P union J is equal to 33. This 33 is a count where a particular professional can know just Python, can know just Java, or they can know both Python and Java. That possibility is given by this union operation. We have the principle of inclusion-exclusion formula here. A union B is equal to A plus B minus A intersection B. Here instead of A we are going with Python and instead of B we are going with Java. So why have they presented this particular symbol? It means you have to take the count and not the set completely. Now let's apply this here. P union J is equal to P plus J minus P intersection J. What is the cardinality of P? It is 25. What about the cardinality of J? It is 20. Now let's take this to be X. So this is minus X. And what about P union J? We know there are 33 professionals who know at least one of the languages. So this is equal to 33. So 25 plus 20 will give 45 minus X. X is equal to 45 minus 33. X is equal to 12. So the number of people who knew both Python and Java will be equal to 12. From this you can understand P intersection J is 12. So how many of them know only Python? It is 25 minus 12 which is equal to 13. How many of them know only Java? It is 20 minus 12 which is equal to 8. So this particular part that I have shaded will be contributing to 8 and this will be contributing to 13. Only when you add 13 and this 12 you will end up with 25, and only when you add 8 and this 12 you will end up with 20. If you are getting confused with this diagram, you can just forget about this and go with the formula alone. Since we don't have any of the options with 12, this question is a drop question as per the official answer key, and so we are not marking any of the options here. The correct answer will be 12. Next question, let P be it is hot day and Q be the temperature is 48 degree Celsius. Write in simple sentences the meaning of negation of P and negation of Q. If P is going to be it is hot day, what is negation of P? It will be it is not a hot day. If Q is going to be the temperature is 48 degrees Celsius, what is not Q? The temperature is not 48 degrees Celsius. We have to search for these two statements now. It is hot day is just P. Temperature is 48 degrees is just Q. We know this conjunction symbol is for and disjunction symbol is for or. So they have given or. Or means this symbol. But they are asking for negation of P and negation of Q. So one is not the answer. What about 2? It is cold day. When you say it is not a hot day, Definitely it is a cold day, so it may apply. What about the second one? Temperature is 48 degrees is still Q. So this is like negation of P and Q are involved, and since R is there, we are using R symbol here. This is also not equating to the question expression, we are ruling out. What about the third one? It is neither a hot day nor the temperature is 48 degrees Celsius. When will you use neither nor? When we say neither nor, it is like not a particular expression and not another particular expression. So negation is involved in both the places. At the same time, they are connected by and expression. Now just substitute neither a hot day is negation of P nor temperature is 48 degrees Celsius is negation of Q, and since they have used neither nor, we are giving and symbol here. So this is actually equal to the expression that is given in the question. Option number 3 will be the right answer. What about it is not a hot day? You are just going to negate P alone. So this is also not equal to the question. Next question. Let L of x comma y be the statement x loves y, where the domain for both x and y consists of all people in the world. Use quantifiers to express joy is loved by everyone. Here they have mentioned about x and y consists of all people, and here they have mentioned something as everyone. Both the terms are actually same. When we say it's all people, it includes everyone, everybody, all the people in the world. Anything can be synonymous to it. Joy is loved by everyone. When you put it in other way, you can say everyone loves joy. So both the statements are equal. Now we'll translate the expressions in the options. We know this symbol is denoting for all, or we can say even everyone. And of course we know this is there exist, or we can say it is someone. Now the first symbol is this one. So we have to start with everyone. How do we translate this actually? We say L of x comma y. So x is the first person, y is the second person, and loves will be the word. If they say L of x comma joy, it is x loves joy. What is x actually? It is all the people in the world. So we are using the word everyone instead of all people. So we can say everyone loves joy. So this is x and this is joy. This is exactly matching the statement that we have seen here. So everyone loves joy will be the right answer here. Option number 1 will be equating to joy is loved by everyone. So sometimes the statement is given in other way, but you have to interpret the direct meaning and then find the right option. Now we will also translate the other expressions. We have used for all y. So this is also everyone here. But here joy is sitting first and y is sitting next, which means joy loves everyone. But the question is, joy is actually loved by everybody. It means everyone is loving joy. So this is not matching with the question statement. What about the third one? We are involving y as well as x. This is actually existential quantifier and this is universal quantifier. When we use existential quantifier, it goes to someone instead of everyone. So when you have these symbols, this will denote someone. When you have this symbol or this symbol, it will denote everyone. Now we have x comma y. X loves y. So here it is everyone and y is given in the form of existential quantifier. So y is taken to be someone. So how will we translate the statement? There is someone whom everyone loves, or we can bluntly translate as everyone loves someone. Anyhow you can take it, and that is not equating to the question statement. So 3 is also ruled out. Now what about the fourth one? They have given negation of joy comma x. So joy is there, x is there, loves is there. When they say negation, it means joy does not love. And what about existential quantifier here? Instead of everyone, we have to substitute someone here. Joy does not love someone. This is the exact statement. In a proper way, we can say there is someone whom joy does not love. But here they have told joy is loved by everyone. So we are ruling out 4. So this is how you have to interpret all the options. Next question, translate this expression in English. Consider domain as a real number for both the variables. What are the variables here? X and Y. What is universal quantifier X? It is for all values of X or for every value of X, we can say. What about existential quantifier of Y? There exists a value Y, or for some value Y we can say. Using that, now we will try to translate every English statement to a particular mathematical expression, and we'll check which expression is equating to the question expression. For all real numbers X, so we know we have to use for all X. There exists a real number Y. We have to use existential quantifier such that X is less than Y. Now the expression should be X is less than Y. We have got this expression. Just check with the question expression. It is perfectly matching. So we can mark option 1 to be the right answer. Now we will also translate the other statements. For every real number Y. So this time it is for Y. This is for option 1. This is for option 2. There exists a real number X. So this is existential quantifier X. X is less than Y. Is this matching to the question expression? No. So we are ruling out this. What about the third one? For some real number X. So this is also existential quantifier. There exists a real number Y. This is also existential quantifier. X is less than Y. So this is also not the answer. What about the fourth one? For each and every real number X and Y, which says X and Y. For each and every is what we use for universal quantifier. X is less than Y is as usual represented as this way. So this is also not the right answer. So whenever you get such questions, make sure the other options are not right. Next question, out of the following steps in the proper sequence for simplifying a Boolean function using a K-map, they have asked for the steps. We'll take an example of 3 variables A, B and C. So how do we actually draw a 3 variable map? We'll just take a map like this. Then we will divide this as 1 variable and 2 variable. 1, 2, 3, 4. Draw the K-map for the given Boolean function. This will be the first step. Any option that starts other than D can be ruled out. After drawing the map, what we will do is we will start filling the values. This is 0, 0, 0, 1, 1, 1, 1, 0. So we have 0 and 1 here. This is 0, this is 1, this is 3, this is 2, this is 4, 5, 7 and 6. What are we actually doing here? We are transferring the truth table values to the K-map. So this will be the second step. B followed by D. We have only in one option, so rule out even 3. What is the next step we have to do? Based on a particular Boolean function, we have to check which places have 1. Based on that one, we have to group those ones together. Identify and group the largest possible cluster of ones is the next step, which is A. What about the final one? Write the simplified Boolean expression from the grouped clusters. This will be the last step. So if you group this way or this way, whichever value you find not changing, that value will be presented in the simplified expression. Option number 1, BDAC will be the right answer. It will be the proper sequence for simplifying a Boolean expression using K-map. Next question, a coin is tossed successively 3 times. Find the probability, event, sample space of getting exactly 1 head or 2 heads where n is the number of occurrence. When we toss a coin, what are the possibilities that we have? We can either have a head or a tail. The sample space of the experiment is the set of possible outcomes. What about event? An event is a subset of the sample space. When you take the sample space for one toss, it is just head and tail. But when you take sample space for 2 toss, for first head you may have head and tail for the second toss. For the first tail you may have head and tail in the second toss. All the 4 possibilities will be taken as sample space. But here they have given it is successively tossed for 3 times. So you have to consider 3 toss together. If S is a finite non-empty sample space of equally likely outcomes and E is an event that is a subset of S, then the probability of that particular event is given by N of E divided by N of S. So N is given as the number of occurrence. So N of E divided by N of S is what we term it as probability of the event. So what is the event mentioned here? The event here is we are getting exactly one head or two heads. So let's find the sample space first. We have toss 1, toss 2 and toss 3. So first we are taking head from the toss 1. So forget toss 1 now, get into toss 2. Here also you are getting head. In toss 3, what are the possible outcomes? Whenever you go for a toss, you either get a head or a tail. So toss 3 will have head for the first time and tail for the second time, or tail for the first time or head for the second time. There are two possibilities. So we are mentioning these two possibilities for head in toss 2, and if you take the tail in toss 2, you have two possibilities, head and tail. So for head you are having two possibilities, for tail you are having two possibilities between toss 2 and toss 3. For which toss we are computing toss 2 and toss 3? For the head part of toss 1 we are computing this. So when we have head in toss 1, there are four possibilities that are available in toss 2 and toss 3. If you are used to the truth table formats of three variables, you can compare this to 0 and 1. Now for the tail part of toss 1, we have the same four combinations. So let's take head first, then head and tail combination. Then for the tail we have head and tail combination. So for head we have 2, for tail we have 2. Now all these are applicable for the tail part. Now the sample space is 1, 2, 3, 4, 5, 6, 7, 8. So N of S is equal to 8 here. What about the event? Get exactly one head or two heads. So where do we have two heads? 1, 2, 3. We have 3 two heads, and they have also told about one head. So this is 4, this is 5 and this is 6. So there are 3 two heads and 3 one head. Overall the number of occurrences of event will be equal to 6. They have asked the probability, the event and the sample space. N of S is equal to 8, but here N of E is equal to 6. So we can take only this one and not this option. Now we have to find the probability. Probability is equal to N of E divided by N of S. So 6 divided by 8. When you cancel them, you can bring it to 3 divided by 4. So P of E is equal to 3 by 4. This is also right. We can rule out D. Option number 2, B and C only will be the right answer. So they have given the event occurrence and the sample space count in two options, and they have given the probability values in two options. So when they have asked the probability and event and sample space together, you can never have this combination of A, B, C and D. Rule out option 1. Once you find N of E is equal to 6, you can rule out A also. Similarly, they have asked for three values P, E and S. But when you take the fourth option, both are talking only about the probability. So just by reading the question, 1 and 4 can be ruled out. When you find N of E is not equal to 4, you can rule out even option 3. Next question. Consider the following relations on set 1, 2, 3, 4. Which of the following relations are reflexive? A relation R on a set A is called reflexive if A belongs to R for every element A that belongs to A. So applying this to the set that is given in the question, if this is going to be A, this can be taken as 1, 1, this can be taken as 2, 2, this can be taken as 3, 3 and this can be taken as 4, 4. So you have to find all these 4 in the given options. If you have them, we can conclude the relation is reflexive. Let's check for A. We have 1, 1, we have 2, 2, we have 4, 4. But 3, 3 is not there. So this relation is not reflexive. What about B? We have 1, 1 alone, 2, 2, 3, 3 and 4, 4 are not present. So we will rule out even B. When you rule out A and B, 2 options will go. What about C? We have 1, 1, we have 2, 2, we have 3, 3, we have 4, 4. All the elements are present, so C is included. What about 4? 1, 1, 2, 2, 3, 3, 4, 4. All the 4 elements are not present, so D is also ruled out. When we rule out D, this option will also go away. What about E? We have 1, 1, 2, 2, 3, 3 and 4, 4. So E is also included. Option number 4, C and E only will be the right answer. Only these 2 relations satisfy the reflexive property. Next question. Consider the following if P and Q are 2 statements. When we see the options A and B, what do we remember? We remember De Morgan's law. So in De Morgan's law, what we will do is we will apply the negation inside. So when we apply the negation inside, this becomes negation of P. Negation with conjunction becomes disjunction and negation of Q. Similarly, when negation is applied to disjunction, it becomes conjunction. These 2 laws are given exactly here. The first law, negation of P and Q is equal to negation of P or negation of Q is perfectly right. Similarly, negation of P or Q is equal to negation of P and negation of Q is also right. A and B are definitely in the answer. We can rule out 2 and 3 now. What about C? P and negation of P is equal to true. Let's take a value called 0. The negation of 0 will be 1. Will and give you 1? No. So from that itself we can mark C is wrong. Negation law states P and negation of P is equal to false. P or negation of P is equal to true. So if you take and here, the answer should be false. In order to make this true, you have to use disjunction operator. So in any way, we can rule out option 4 also. Now we will check for D. We have negation of P implies Q. When we have P implies Q, we can have negation of P or Q. When it is negation of P implies Q, we have to go with negation P or Q. This part you are applying with negation. Once you apply negation, negation into negation will make this as P. Negation of disjunction will make this as conjunction, and this will be negation of Q. This is the answer we are presenting here, and this is what is even present in the RHS. So D is perfectly true. Now what about E? P or Q is equal to not P or not Q. Let's take P is equal to 0 and Q is equal to 0. P or Q will give you 0. Now what about negation of P? It is 1. Negation of Q, it is equal to 1. What is 1 or 1? It is going to give 1. Are they equal? No. So this is wrong. From this we can mark option number 1, A, B and D only as the right answer. So if you are sure about the laws, just apply the laws. If you are not sure about the laws, just apply some value and then find it out. Next question, match list 1 with list 2. There are some queries in list 1 and the probability of those queries are given in list 2. So let's take the first one. A bag contains 6 white and 4 red balls. 2 balls are drawn at random. What is the chance they will be the same color? When you pick those 2 balls, it should be either from white or from red. Now what is the sample space here? We have 6 white balls and 4 red balls. Altogether there are 10 balls. So from these 10 balls we have to pick 2 balls. The event is 2 balls are drawn at random and they are of same color. So you will have 2 options here. One is those balls can be of white color. The other one is those balls can be of red color. Regarding sample space, out of 10 balls you have to pick 2 balls. So 10C2 is given. Regarding the event, we have to pick 2 from white, which is represented by 6C2, or we have to pick 2 from red. This will be 4C2. So it is given by 6C2 plus 4C2. This OR is actually denoted by plus. When you involve AND, it becomes multiplication. When you involve OR, it is just plus. So what is NCR? N factorial divided by R factorial and N minus R factorial. You have to apply this formula everywhere. So this is 10 factorial means 10 into 9 into 8 factorial divided by 2 factorial into 10 minus 2 is 8 factorial again. So 8 and 8 will get cancelled. 90 divided by 2 will give you 45. So n of s is equal to 45. What about n of e? We have 6c2. So this is 6 factorial divided by 2 factorial and 4 factorial plus this is 4 factorial divided by 2 factorial and 2 factorial again because 4 minus 2 is also 2. So how can you express 6 factorial? 6 into 5 into 4 factorial divided by this is 2 into 1 and this is 4 factorial as it is, we can cancel, plus 4 into 3 into 2 factorial divided by 2 into 1 and this is 2 factorial as it is, we can cancel. Now if we cancel this, this will be 3 and this will be 2. 3 into 5 will give you 15 plus 2 into 3 will give you 6. So it is 21. How will you find the probability of the event here? It is n of e divided by n of s, which is equal to 21 divided by 45. 7 3s are 21 and 15 3s are 45. 7 by 15 will be the probability for A. A will be mapping to 4. A 4 is available in 2 options. We will rule out the other 2. Next we will get on to B. In a pack of 52 cards, one card is drawn at random. What is the probability that it is either a king or a queen? There are actually 52 cards. We will call one as ace actually. Then we have 2, 3, 4, 5, 6, 7, 8, 9, 10. For 11 it will be J, for 12 it will be Q and for 13 it will be K. Jack, Queen and King. There will be 13 cards like this and there will be 4 suits. In the sense 4 symbols will be there. So you will have heart symbol, you will have spade symbol, you will have club symbol and you will have diamond symbol. So for every symbol there will be 13 cards. So 13 plus 13 plus 13 plus 13. Altogether you will get 52 cards. Now they are saying you have to take only one card in random and that card can be a king card or a queen card. So let's take the sample space to be 52 cards. N of s is equal to 52 here. What about the event? The picked card can be a king or the picked card can be a queen. That's why we are using or here. So this is like event 1 plus event 2. Event 1 for king and event 2 for queen. How many kings are there actually? See, in heart you will have a king, in spade you will have a king, in clubs you will have a king and in diamond you will have a king. So there are 4 king possibilities out of those 52 cards. Similarly, when you take queen, there are 4 possibilities. So when you take n of event 1, it is 4 for one king from each symbol. And when you take n of e2, it is 4 for one q from each symbol. So what is the probability of the event? It is n of e1 plus n of e2 divided by n of s. What is e1's value? It is 4 plus 4 divided by 52. We will have 8 by 52. You will get 2 by 13. So 2 by 13 will be the answer for B. In the option there is something called 2 by 3. Actually it's a typo. It is actually 2 by 13. In this case we can mark B to 3. So both the options are having B3 along with A4. Since it's just a printing mistake, they have not dropped this question actually. It is wrong, but even then it is a printing mistake. So we will take this to be 2 by 13. Now let's go to C. A bag contains 6 red, 4 white and 8 blue balls. If 3 balls are drawn at random, find the probability of 1 red and 2 white balls. So let's take the sample space as 6 red, 4 white and 8 blue balls. Altogether how many balls are there? 6 plus 4 is 10, 10 plus 8 is 18 balls are there. Now the event is to pick 3 balls at random and they have given one should be red and the other 2 should be white. So 1 red and 2 white. They have not given like something or something. It is something and something. So in this case, we will not use plus like A and B. We have to use multiplication is what I am trying to tell you. So when they say 2 balls are drawn at random, you have an option to select from white and from red. So that's why A had plus here or operation. Regarding B, they asked either for a king or a queen. So again we used plus. But here the case is they want red along with 2 white. What about N of S? Out of 18 balls you have to pick 3 balls at random. So 18C3 is given. What about E? There are 6 red balls actually. So for red you have to pick 1 from 6. For white you have to pick 2 from 4. So this is what is given as 6C1, 4C2. Why are we multiplying here? It should have 1 red ball and 2 white balls. Now we have to find the value. What about 18C3? N of S is equal to 18 into 17 into 16 into 15 factorial divided by, this is 3 factorial and this is 18 minus 3 which is equal to 15 factorial. We are cancelling these two. Again we have 18 into 17 into 16 divided by 3 factorial can be expanded as 3 into 2. This can be cancelled for 3 times here. 6 3s are 18. We will have the sample space as it is. Now let's get into N of E. 6C1 will give 6 into 5 factorial divided by 1 factorial into 5 factorial into 4 factorial divided by 2 factorial. 4 minus 2 is 2 factorial. For 4 factorial we got a value of 6 I suppose. So this can be written as 4 into 3 into 2 factorial. So you can cancel these two. So we have 6 into 4 3s are 12. 12 divided by 2 will give 6 again. So this is 6 into 6 which is equal to 36. Now we have to go for probability which is equal to N of E divided by N of S which is equal to 36 divided by N of S is 3 into 17 into 16. So this will be 12 and again we have 4 3s are 12, 4 4s are 16. So this is 3 divided by 17 4s are 68. 3 by 68 is the answer. It is available in 1. So C can be mapped to 1. C1 is available in option 4. So we can rule out even option 3. Now we will go for D. A bag contains 6 red, 4 white and 8 blue balls, the same count. If 3 balls are drawn at random, find the probability of 2 blue and 1 red ball. So we will go with the same N of S. So there are totally 18 balls and so we know the N of S value will be 3 into 17 into 16 finally. We are not multiplying this, we just keep it as it is. What is the event here? 3 balls are drawn, 2 are blue and 1 is red. What about N of E? This time we have 8 blue balls. So out of 8 you have to pick 2 in case of blue and in case of red you have to pick 1 ball from 6. So it is 6C1. 6C1 is actually 6 only. So we have the values. Let's go for 8C2. 8 into 7 into 6 factorial divided by 2 factorial into 6 factorial, 8 minus 2. So 6 and 6 will get cancelled into 6 into 5 factorial. We have 1 factorial into 5 factorial. So these two will get cancelled. What about 2? This will be 4. 4 into 7 into 6 will be there as it is. Now let's calculate probability of the event. It is N of E divided by N of S which is equal to N of E is 4 into 7 into 6 divided by we have 3 into 17 into 16. This is 1 4s and this is 4 4s. This is 3 1s and this is 3 2s. So 7 into 2 will give 14. divided by 17 into 4 will give 68. You can also reduce this to 7 by 34. This is also possible because this will be 2 ones are 2 and 2 twos are 4. So 17 into 2 will give 34 and this 7 alone will be there. But here they have just given as 14 by 68. When you reduce 14 by 68, you will ultimately get 7 by 34. If you get either of the answer, you can mark option 2. So D will be mapping to 2. So this is also right here. Option 4 will be the right answer. Next question. A graph G with number of vertices greater and equal than 3, that is greater than or equal to 3, is a Hamiltonian graph if the degree of each vertex is greater than and equal to. So here there is a theorem called Dirac's theorem. If G is a simple graph with n vertices with n greater than or equal to 3, so here the number of vertices is what they have mentioned in the statement, such that the degree of each vertex in G is at least n by 2. Then we can say G has a Hamiltonian circuit. What do you mean by at least? At least means minimum this much should be there. So it can be equated to greater than or equal to, which is perfectly matching here. What about at most then? We can say it is less than or equal to a particular value. That's why we'll say at most 1 means not more than 1. At least 1 means 1 or more than 1. If it is saying at least n by 2, it is greater than or equal to n by 2. So n by 2 is nothing but half of the number of vertices. Option number 3 will be the right answer. Equal to means it is just n. Double number of vertices means 2 into n. 4 times the number of vertices is 4 into n. Half the number of vertices is what we can say n into 1 by 2, which is equal to n by 2. A simple path in graph that passes through every vertex exactly once is called as Hamiltonian path. A simple circuit in a graph that passes through every vertex exactly once is Hamiltonian circuit. If you take the path, we are starting from x0 and ending with xn. So we can take an example of x1, x2, x3 and x4. If you have a path from x1 to x2, x2 to x3 and x3 to x4, you can call it as Hamiltonian path. Every vertex should be visited exactly once. What about the circuit then? If you have a path from x0 to xn and again if you go back to x0, then that becomes a Hamiltonian circuit. So if you take x1, x2, x3, x4, so x1, x2 is there, x2, x3 is there, x3, x4 is there. From x4, if I am back to x1, the starting vertex. So here they are starting from x0, going till xn, again getting back to x0. So this is the start vertex. So if you are getting back to it, this is called a Hamiltonian circuit. Make sure that we are visiting every vertex exactly once. But we are getting back to the initial vertex or the source vertex once again. So this is Hamiltonian circuit. With this we are completing Unit 1 solutions. Let's solve Unit 2 Computer System Architecture questions. A multiprocessor system with 16 processors is used to execute a parallelizable task. If the serial portion of the task takes 200 clock cycles and the parallel portion takes 800 clock cycles, when all 16 processors are used, how many total clock cycles are required to complete the task? When they say the task is parallelizable, it means all the processors will be fully utilized there. When they say about serial portion of the task, it means only one processor will be in use at that time. So in order to calculate the total clock cycles, you have to combine the serial portion time and the parallel portion time. So let's take the 16 processor on the whole. If you take the serial portion, it will be executed only by one processor. So let's take that to be the first processor. When the serial portion involves only single processor, what is the time that is given in the question? It is 200 clock cycles. So we have the serial time is equal to 200 clock cycles. What about the parallel portion? When you take the parallel portion, all the 16 processors will be involved and the total time that is given for the parallel portion will be 800 clock cycles. When we say the parallel portion is executed by 16 processors at a time, it takes 800 clock cycle time. What about the parallel time then? You have to take the total number of clock cycles of the parallel portion divided by the number of processors. This will give you the parallel time. Imagine all the 16 processors are going to execute at time 0. So when it comes to time 50, all the processors will complete the execution. So how many clock cycles are involved here? Only 50 clock cycles are involved here. So since one processor takes 50 clock cycles, 16 processors will take 16 into 50, which is equal to 800 clock cycles. So this is how we are calculating the 50 clock cycle. Actually, it is per processor clock cycle we can say. Only when you involve all the 16 processors together, you will have 800. When you take only one processor into account, it is 50 clock cycle. So that's why I said when all the processors from 1 to 16 are going to start from 1 or 0, something like that, when the time is going to be 50 clock cycle, the task will be over. And this part will be taken as the parallel portion of the task. Now we know serial time is 200 clock cycle and parallel time is 50 clock cycle. Now let's get into the question. How many total clock cycles are required to complete the task? The total clock cycles will be equal to the serial time plus parallel time per processor. That's what I told here. What is the serial time? It is 200 clock cycles. What is the parallel time per processor? It is 50 clock cycles. So on the whole, we'll have 250 clock cycles to complete the whole task. Option number 1, 250 will be the right answer. Next question. A CPU has a 5-stage pipeline with the following stages: fetch, decode, execute, memory and write back. Each stage takes 1 clock cycle to complete. Assume there are no pipeline stalls and the pipeline is initially empty. How many clock cycles are required to complete the execution of 10 instructions? This is with respect to one instruction, we can say fetch, decode, execute, memory and write back. We have a formula to do this, but before seeing the formula, let's understand the scenario and try to compute the clock cycles that are required to complete 10 instruction execution. After that, we will just substitute in the formula and check whether we have worked it in the right way. Let's take the 10 instructions together. What about the first instruction? How many stages it has to go? It has to go for fetch, decode, execute, memory and write back. So the first instruction is going for 5 stage here. They have given every stage takes only 1 clock cycle. So every cell here can be taken as 1 clock cycle. Now the second instruction will start from this point. The third instruction will start from this point. The fourth one, the fifth one, the sixth one, the seventh one, the eighth one, the ninth one and the 10th one. When instruction 2 is in fetch, instruction 1 is in decode. When instruction 3 is in write, instruction 4 is in memory. There is no overlap occurring. Every stage is occurring individually here. Now we have to find the total clock cycle. If this is going to be 1 clock cycle, we have to count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14 clock cycles are required to complete the execution of 10 instructions. How many clock cycles do we need to complete one instruction? We need 5 clock cycles. 1 for fetch, 1 for decode, 1 for execute, 1 for memory and 1 for write back. Now we have a formula for this. A K-segment pipeline with a clock cycle time Tp is used to execute n task. To complete n task using a K-segment pipeline, it requires K plus n minus 1 clock cycles. So here the first task is K into Tp and n minus 1 task is n minus 1 into Tp. So why have they not mentioned Tp is given as 1 clock cycle. It is the clock cycle time they have mentioned. So it is 1 clock cycle. Anything into 1 is going to give you 1 only. How many stage pipeline it is? 5 stage pipeline. This is what they have given as K segment. It means it's a K stage pipeline we can say. So K is equal to 5. What about the number of instructions? That is what we have mentioned as n task, where n is equal to 10. So clock cycles is equal to K plus n minus 1. What is K? It is 5. What is n minus 1? It is 10 minus 1. 5 plus 10 minus 1 is 9. 5 plus 9 is equal to 14. Did we get 14 here? Yes. Option number 2, 14 will be the right answer. This is how in the reference book they would have explained you, and from there they would have given the formula k plus n minus 1 into Tp. Next question. A vector processor with 16 lanes can perform an operation on 1024 elements with each operation taking 5 clock cycles. How many cycles are needed to complete the operation? Now let's understand what is a lane. A lane is the name of the unit that is used to describe the width of an execution unit. So just imagine the car lane or the transport lane that we used to see in the roads. So there will be different lanes like this. It will have some kind of width. That describes the width of an execution unit in this context. These are the 16 lanes. So 16 lanes will perform on 1024 elements. You have to split 1024 by 16. So when you divide 1024 by 16, you will get 64. So 64 here, 64 here, 64 here. Similarly, this is how it will be divided. So 64 into 16 will give 1024 elements. So 64 elements will be processed in one lane. How it will be processed? It will be processed from V0 to V63. It means when you take the first row, the 0th row, they have told one operation will take 5 clock cycles. This is the first operation we can say. This will take 5 clock cycles. So for this operation, how many lanes are involved? 16 lanes are involved. When V of 0 is taken, it is executed in 16 lanes together. This one row is actually called as one cycle. Then how many rows do you need to make it for 1024 elements? If you execute 0, at a time we are covering 16 lanes. When you execute the first row, you will cover another 16. So how many times if you multiply 16, you will ultimately get 1024. You have to multiply 64. It means there are 64 rows involved here. So number of cycles, otherwise it is called as operations. This is equal to 1024 divided by the number of lanes, which is equal to 64. Option number 1 will be the right answer. So you can take this as there are 16 lanes which are columns. There are 64 cycles which are rows. Altogether you will have 1024 elements as mentioned in the question. Many confusions are evolving, like whether this is number of operations or number of clock cycles. The CPU clock cycle is the fundamental timing mechanism. The CPU cycle refers to the entire process of executing an instruction. So here we can equate this to one row is one instruction, and this happens in 16 lanes simultaneously. This may span several clock cycles. So here this one instruction can be equated to one operation, and this one row is executing in 5 clock cycles as per the question detail. So here cycle is nothing but the process of executing an instruction, the operation they have asked. So this question is clearly asking for the number of cycles, number of operations. That's why I mentioned here as V of 0 row is one cycle. So how many cycles are there? 0 to 63. Totally there are 64 cycles involved. So that's why I splitted this as every lane is executing 64 operations. When you multiply 64 into 16, all the 1024 elements would have been taken for consideration. So if the question is, how many clock cycles are needed to complete the operation? How many cycles are there actually? 64 cycles are there. How much does one cycle take or one operation take? One takes 5 clock cycle, means 64 cycles will take 64 into 5 clock cycles. So overall we will have 64 into 5, which is equal to 320 clock cycles. If they ask about clock cycle, the computation will go this way. If they ask about cycles, the computation should end by here. Next question. Arrange the given steps required for a direct memory access DMA transfer in the correct order. In DMA, the interface transfers data into and out of the memory unit through the memory bus. In this mode, the I/O module and main memory exchange data directly without processor involvement. When the processor wishes to read or write a block of data, it issues a command to the DMA module. The processor gives this I/O operation to the DMA module. So let's take the processor is giving it to DMA module. The DMA module transfers the entire block of data one word at a time directly to or from memory. When the transfer is complete, the DMA module sends an interrupt signal to the processor stating that it has been completed. Thus, the processor is involved only at the beginning and at the end of the transfer. So, in the beginning, it is only initiating the process. At the end, it is getting the control back from DMA module. This first step, when the processor wishes to read or write a block of data, it issues a command to the DMA module. This can be taken as the initiation step, which is in A. The processor gives this I/O operation to the DMA module is what we can see in C. Processor grants DMA control over the system bus. So here it is initiating the request and then it is granting the control over the system bus. The DMA module transfers the data one word at a time directly to or from memory is what statement B is about. Transfer data directly between peripheral and memory. When the transfer is complete, DMA module sends an interrupt signal to the processor is what DMA controller completes data transfer and signals completion. This is D. So A, C, B, D. Option number 2 will be the right answer. Next question. Find the correct sequence of the storage device in ascending order based on their access time. I have two diagrams for this. One is taken from the operating system reference book and another one is taken from computer system architecture reference book. If we see both these diagrams, we can understand that the storage capacity is small in the top level and it is getting larger when we go down the level. Similarly, the access time is fast in the top level. When we get down, it is becoming slow. Since the question is about access time, we will arrange it from fast to slow. The first level is actually registers. In both the diagrams, it is registers. So we can mark A here. Let this be A. What about the next level? It is cache memory. There is no option. Then we have main memory. Main memory is in option D. So we are marking D here. So optical disk is E and magnetic tape is C. What about this diagram? We have magnetic disk here. So it is B. We have CD-ROM, CD, read-write, then DVD, DVD, RAM, everything. All these Blu-ray disc, everything belongs to the optical disk part. So optical disk option E can be marked here on behalf of all these names. What about magnetic tape? It is in option C. Now what is the order you get from fast to slow access time? It is A, D, B, E, C. They have asked us to arrange the storage device in ascending order. Ascending order means small to large. What is the small value? It is small access time to large access time. For registers, if you are going to access it in 1 second, for tape, you may take 10 seconds. So this is fast access time and this is slow access time. If you go by this order, which is first in ascending order, registers will stand first in ascending order. So ADBEC will be the correct order of this particular question. Access time is fast means it is done in a quick time. It means it takes less time to access. Access time is slow means it takes more time to access. So if this is going to be 1 second, this is going to be 10 seconds. And in between you may have 2, 4, 8. Overall, when you take the order, it is ADBEC. Look at the options. You don't have any of the options matching to this particular sequence. But you can find the reverse of the option here. ADBEC. Option 4 is in reverse. Actually, they have arranged it in terms of the speed, we can say. So here the access time starts from 1 and here it takes up to 10 seconds as per this option. Since the option is arranged in reverse order and no other option is getting matched to this particular sequence, they have dropped the question. There is no key provided for this question. So this is the answer of this question. Next question. Consider the given number 45 to the base y, where y is the base of the number. Some of the possible values of y are given below. There is a series going on in this channel, CS Connect series. In that there is a video called number base. It will give a good understanding about number based concepts and even about base conversions. There are videos, you can just check them. If you take a base of a number, what will be the possible values of that particular base? When you take the decimal system, base 10, what are the numbers that are included in decimal system? 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When you take binary, it is base 2. What are the numbers involved here? 0 and 1. When you take octal, it is of base 8. What are the numbers involved? 0 to 7. When you take hexadecimal, it is base 16. What are the numbers involved? It is 0 to 9 in decimal. Then we have 8 to F, which is nothing but the denotion of 10 to 15. So it is between 0 and 15. Whenever you take the base, it starts from 0 and ends to the number before the base. So now we have to check the numbers for base 5, base 6, base 7, base 8. So let's take the base r digits that range from 0 to r minus 1. So if it is base 10, we end up with 9. If it is base 8, we end up with 7. Let's take base 5. It means it should be from 0 to 4. When it is base 6, it will be from 0 to 5. When it is base 7, it is from 0 to 6. When it is base 8, it is from 0 to 7. When you are writing a number using this base format, whatever number is allowed here, that alone will be enclosed in the brackets and given the base. Say for example, if there is a number 87 to the base 8, this is wrong because 8 is not a valid number of base 8. It has value only till 7. When we say BZ is a hexadecimal number, it is not possible because the values are available only from A to F in letters. There is no value called Z. Similarly, when I say there is a number called 1, 2 with base 2, it is not possible because when you take base 2, you have possibilities of only getting 0 and 1. 2 cannot be the number of base 2. Number 4 is there. Is it a possible value in base 5? Yes, it is a possible value. 4 is there. 4 is there in 6. 4 is there in 7. 4 is there in 8. What about the next digit 5? 5 is not there in base 5. But 5 is there in base 6, base 7 and base 8. What are the possible values of y? If y is equal to 5, 45 does not exist. If we say 4, 5 to the base 6, 6 is included. 4, 5 to the base 7 is also available. 4, 5 to the base 8 is also available. All these three bases can be taken. Option number 2. B, C and D only will be the right answer. When there is a base 5 number, the digits will range only between 0 to 4 and definitely 5 is not there. Next question. Consider the following statement regarding special purpose registers. They have given 4 statements. Choose the correct answer from the options given below. So we have to choose the correct statement. The list of registers for the basic computer is taken from the reference book. Here we have program counter, then we have instruction register and we have accumulator here. So they have just given what kind of work it is going to do. The program counter holds the address of the next instruction to be read from memory after the current instruction is executed. So this is what they say, it holds the address of instruction. So the first statement, program counter keeps the track of next instruction executed is perfectly fine. Next, the instruction register holds the address of first instruction to be executed. The instruction register contains 8-bit opcode instruction being executed. It is not about the address of first instruction, so B is wrong. Anything that involves B can be ruled out. Next we have accumulator holds the output of ALU. The accumulator is used to hold temporarily operands and results of arithmetic logic unit operations. This statement says that C is true. What about the fourth statement? Program counter keeps the track of only first instruction of the program. It holds the address of the next instruction after the current instruction is executed. So it is not about tracking only the first instruction. It's about tracking the next instruction to be executed. When A is true, definitely D is false. So when you find D is also false, you can rule out option 2. Option number 1, A and C only will be the right answer. Next question. Consider the following statements regarding combinational and sequential circuits. So they have asked about the output of combinational circuits and output of sequential circuits. A combinational circuit is a connected arrangement of logic gates with a set of inputs and outputs. So this is the diagram. If there are n input variables, there will be m output variables. The outputs at any instant of time are dependent upon the inputs present at that time. Just based on the input, the output is being given here. And it's just an arrangement of logic gates. So as soon as you pass the input, you will get the output immediately. So let's see A. Output of combinational circuits depend on the only current input. That is what this statement is specifying. It is right. Output of combinational circuit depends on both current input and previous output. It has not mentioned anything about it. The previous output is nowhere taken as input here. So this point is definitely wrong. A is definitely true. So we will rule out 3 and 4 here. Now what is sequential circuit? A sequential circuit consists of combinational circuit to which memory elements are connected to form a feedback path. When there is a feedback path, it means you get output here. From this output, something is entering as an input here. So this is what they say. The previous output is also fed as an input here. If this is going to be the case, output of sequential circuit depends on both current input and previous output is right here, and this should be wrong. It's because this will be the current input and this will be the previous output that is getting connected back to the input path here. This is what they call as the feedback path. So here D is also right. We will rule out option 1. Option number 2, A and D only will be the right answer. Next question. Match list 1 with list 2. List 1 is about the counter. List 2 is about the uses or its working. We have n-bit ring counter, synchronous counter, asynchronous counter and decimal counter. From the term decimal counter, we know it is going to involve only the decimal digits 0 to 9. Decimal counter ranges from 0 to 9 and binary counter is about 0 and 1. Based on this idea, we can map D to 3. D3 is available in 3 options. So the second option can be ruled out here. Next we will see about ring counter. Ring counter is the simplest shift register counter that uses an n-bit shift register to obtain a counter with n states. How many bits are involved? Those many states are involved. You have to take this clue from the statement. N-bit ring counter will be mapping to counts exactly n states. A is mapping to 2. Still we have 2 options here. So we can rule out even option 4. What about synchronous counter? It connects all of its flip-flop clock inputs to the same common clock signal. When they say something as same common clock signal, you can equate it to universal clock. So synchronous counter will be mapping to option 1, uses universal clock. This is what they have mentioned as the common clock signal that is mentioned in the statement here. Then what about asynchronous counter? The main clock is applied to first flip-flop only. That's why we have the term asynchronous. So C will be mapping to 4. C4 and B1 is available in option 3. Option number 3 will be the right answer. We have also ruled out option 1. Next question, match list 1 with list 2. List 1 has the computing systems and list 2 has either the working or the output. Half adder, decoder, register, main memory. A combinational circuit that performs the arithmetic addition of 2 bits is called as half adder. We get a clue here, arithmetic addition of 2 bits. So 2-bit addition circuit is the answer of half adder. A will be mapping to 4. A4 is available in 2 options here. We will rule out the other 2. A decoder is a combinational circuit that converts binary information from the n-coded inputs to a maximum of 2 power n unique outputs. So when there are n inputs that are converted to 2 power n output, this is a decoder. What about the encoder? It is just the reverse. 2 power n inputs are applied to get n outputs. So decoder can be mapped to 1 has n input and 2 power n output. B will be mapping to 1. So we can rule out even option 2. What about register? A register is a group of flip-flops with each flip-flop capable of storing 1 bit of information. This can be equated to CPU storage unit. C will be mapping to 2. What about main memory? The main memory is available to the user for storing programs. The contents of main memory may alter. It means it may change when the data are manipulated and every time that the program is changed. They say it is used to store program at runtime. The contents of main memory keep changing is what they say at runtime. The contents may alter when the data is manipulated or when the program is getting changed. And so we can map main memory to used to store program at runtime. D will be mapping to 3. Option number 3 will be the right answer. With this we are completing Unit 2 solutions. Let's solve Unit 3 Programming Languages and Computer Graphics questions. We are given a program segment and we are asked to find the output of the above code. Let's get into the main program. They have actually initialized an array. The values are 1, 2, 3, 4, 5. They have initialized a pointer to the array. Whenever such initialization takes place, the pointer will be initialized to the first value of the array. So the pointer is present in index 0. This initialization means the pointer is initialized to the 0th index of the array. Now they are asking us to print 2 values. One is pointer plus plus. This is post increment operator, and the other statement is pointer plus 1. Now we will interpret both these statements. So let's take the first statement. It is pointer plus plus. Whenever there is pre-increment operator, something like plus plus p, the increment first happens and then the printing happens next. But when it is p plus plus, the value is accessed directly as p. So after accessing the p's value only, the increment part will be taking place. So in this case we have pointer plus plus. It means the value in the pointer will be printed first. So what is the value in the pointer? It is 1. So initially we have star p is equal to 1. After it prints 1, it then increments the pointer's value to the next index. The pointer moves to the next position and now the pointer's value will be 2. So this statement will print 1. What about the next printf statement? It is having pointer of p plus 1. Here this is p plus 1, not post increment or pre-increment. So here the p's value will be incremented. The p will be incremented by 1. It will be moving to the next index. So now pointer will have the value of 3. So now this pointer p plus 1's value will be 3. So the output is 3. So the first statement prints 1 and the second statement prints 3. So this output is given in the form of 1, 3. When you print this output, you will actually get 1, 3 without comma. but here they have introduced comma to say that they are different values. So if we take in that aspect, we can mark option 2 to be the right answer. This is just for readability purpose. I think they have introduced 1, 3. Other than that, if you take, the value will be 1 and 3, that will be printed continuously. So if you want to understand how this code works, I would recommend and I would suggest you to use an online C compiler, run the program. Wherever you get doubts, introduce some print statements, try to access every other value. This is how we have to learn programming related questions. Next question. Consider the following C code. What will be the output of the above code? We have to start from the main program and there is some function declaration. Int temp is equal to 0 is declared globally. It means it is not local to any other function. So this variable is initialized globally. Whenever we call the function, this particular variable will be incremented. It is globally initialized, so it is not local to any function. It is not local to the main function. It is not local to this function also. They check the value of y is 3 or not. If it is 3, they return the value of x. If it is not 3, they compute z. There is a recursive call to the same function and then the value of z is returned. So this is the function block they have given. Now let's get into the main function. So the first call will be function of 4, 81. From 4, 81, what you can understand? This is 4 and this is 81. It means x is equal to 4, y is equal to 81 and globally we have temp is equal to 0. So we have taken all the 3 values here. Now we have to get inside the function. We are declaring a z variable and we are incrementing the temp here. Temp plus plus is equal to temp is equal to temp plus 1. So already temp has 0 and now it is incrementing by 1 and the new value of temp will be 1 here. After incrementing temp, we have to check if y is equal to 3. Y is not equal to 3, so we are getting into the else block. Now we have to compute z is equal to function of x comma x is 4 and what is y by 3? It is 81 by 3. 81 divided by 3 will give you 27. So this statement is z is equal to function of 4 comma 27. Now the program is here. Immediately it goes for a recursion. So we are moving to the next call. So now when you have function of 4 comma 27, we will again get into the function now. So now the value of x is 4, y is equal to 27. What is the value of temp that has been updated? It is 1. We should not start with 0 because temp is given outside the function. So once it has incremented the value of temp, the new value of temp should be used here. So now we know temp is equal to 1 from the previous part. Now we will get inside the function once again. We have to increment temp here. Temp is equal to the previous value is 1 and we are just incrementing it by 1. We get 2. We are checking for y is equal to 3. It is not true. So we are moving to the else part again. Z is equal to function of x is 4. Y divided by 3 is 27 divided by 3. Again we are going for a function call. It is recursively calling. This time the value is 4 comma 9. So we are moving to the next function call. The program pauses here and it goes for the next call. Again we have to go for x is equal to 4. This time y's value is 9 and the temp value is 2. Again we are getting inside the function. We have temp is equal to 2 plus 1 which is equal to 3. We are checking for y is equal to 3. It is not true. So we are moving to the else part. This time we have z is equal to function of 4 comma 9 divided by 3. And so z is equal to function of 4 comma 3. This will immediately call the function of 4 comma 3. Now the value of x is equal to 4, y is equal to 3 and temp is equal to 3 from the previously updated value. Now again we have to get inside the function block. Temp is equal to 3 plus 1 which is equal to 4. Now we have to check if y is equal to 3. Yes, it is true. If it is true, what it has to return? It has to return x into x into x. What is the value of x? It is 4. 4 into 4 is 16. 16 into 4 is 64. This value will be returned for this particular function. When we paused it for function of 4 comma 3, now this will give a value of 64 to z. So we are moving this 64 to the function calls next statement. So from here we compute z is equal to 64. So this particular function call is done now. We have to move to the previous call. When you go for recursion, after computing the final function call, we just apply the values to the above parts. The similar thing only we are doing here. So we are applying 64 to the return statement here, z into z into z. So this will have a value of 262144. Now whose value is this? It is the value of the previous function. So this function's value will be 262144. So when z is equal to fun of 4 comma 9, the value will be z is equal to 262144. So we are moving this value here. Z is equal to 262144 and the next immediate statement will be return of z into z into z. So this will give a value of a very big number. Now in C there is a range for integers. Integers maximum limit is this value. But z into z into z is giving this much big value. So when you run a program with such a big value, what it will do is overflow in conversion from long int to int. So this is a long int and this is int. When it has to convert from long int to int, the value will change from this long int number to 0. This is what the program will do. So when you apply this value to z into z into z, the value will be 0. Why it is 0? It is because it is exceeding the range of int maximum limit. So they have declared it as int z. You cannot have the value of z to be greater than this particular limit. You have to understand that. Till 262144 it is fine. But when you are multiplying 262144 for 3 times, you end up with a very large number which comes to the category of long integer and not normal integer. So that's why this conversion from long int to int changes the value from this particular big number to 0. So now what is the function call of 4 comma 27 giving us? It is giving you 0. So this value 0 will be taken to the previous call 4 comma 27 statement where it is paused here. So this statement will be going to the next return statement now. So z is equal to 0 and 0 into 0 into 0 will also give you 0. So ultimately this particular function from where we started the program will have the value 0. It means fun 4 comma 81 will yield the value of 0. Now we will move on to the printf statement. They are asking us to print the temp value. So what is the final temp value that we saw here? Temp is equal to 4. So option 2, 4 will be the right answer. From here I could have marked the answer, but I wanted to explain how this program execution will end and then go for the next statement, because we started with the first statement, function call with x value is equal to 4 and y value is equal to 81. So only when I complete this function call, when you execute it in a program, it will come to the next statement. So I wanted to go in the same sequence. That's why I completed the entire call and then I came for the printf statement. That moment when you find 3 plus 1 is equal to 4 and when you find this condition to be true, you need not go for any calculation like this. Instead, you can stop here, mark the value of temp and move to the next question. This is how you have to do in examination point of view. But in case if some question paper is going to ask you what is the value of function call, for that purpose, for learning point of view, I have explained you how the execution will take place. Next question. Again we are given a code segment with a swap function and a main function. This time it is C++ code. Let's see swap function overall. So we are passing %x and %y. We are using a temp variable and we are just swapping the values of x and y. So a simple swap function is given. Let's get into the main function. Int a is equal to 5, b is equal to 10. The swap function is called 2 times and they are asking us to print the value of a and b. Actually, when they give space here, this should also have space in the options. But in the options they have put comma, but here they have given just space. This particular method of passing arguments is called pass by reference. Pass the memory address of the variable to the function rather than the value of the variable. So whenever you have some value for a variable, say we have a is equal to 5 here and b is equal to 10, it will be stored in a particular memory address. So this address I have taken it for an example to explain you what happens. So if you ask me if this is going to be an exact address, no, this address will run so long, but I have just picked up only few characters to tell you how this process happens. So when they say x is equal to %a or y is equal to %b, that is when they send it by reference, what happens is x will have the value of the address of a and y will have the value of the address of b. So when you want to check how this address is getting printed, use %p instead of %d in C. If you take in C language, if you use %p %a, this will print the memory address of a. How will you print the value of a? We will usually use printf %d a. This is how we will be printing the value of a. This is for the value and this is for the memory address. Now we are getting into swap of a comma b. So what does this swap to? Initially a is having 5, b is having 10, but x gets the value of address of a and y gets the value of address of b. What happens inside the swap function? We are swapping the values of x and y. So ultimately x will have the address of b and y will have the address of a. So when it comes out of this particular function call, the values of a and b will be swapped. That is, a will become 10 and b will become 5. That is what is given here. What happens when you go for second call of the same swap function? Now we know a has the value of 10 and b has the value of 5. So x is getting memory reference of 10 and y is getting the memory reference of 5. So this particular value is associated with this address and this value is associated with this address. So based on the value only the address will be taken. So 10 is having FB and 5 is having FA. Now we have to get inside the swap function. We are swapping the positions once again. So x will get the value of this memory address and y will get the value of this memory address again. So what is in FA? It is 5. What is in FB? It is 10. So after this swap, a will become 5 and b will become 10. That is what is given here. Now when you want to print a and b value, what is a's value now? It is 5 and what is b's value? It is 10. So 5 comma 10. Option number 1 will be the right answer. If you want to understand this program in a better way, instead of %x and %y, just use void swap int x int y and see how the execution happens. This change will never happen. You print a and b here also. Just give cout a and then b. So introduce as many as print statements in between the code to understand what happens in the execution. This is how you can learn. Even if you are not used to programming all these days, you have to get used to these programming kind of questions. So practice as many times in some online compilers so that you can get used to such problems. Next question. Consider the function in C code. So they have given a recursive function here. How many times star is going to be printed if the function is called with call 10 comma 10. So call A comma B is call 10 comma 10. From this you can infer the value of A and B. A will be 10 and B will be 10. So let's first understand what is in the code. So they have given if and else block inside a if block. So the first if block will test whether B is equal to 1 or not. If B is not equal to 1, inside the if block they check whether A is not equal to 1 or not. If it is not equal to 1, if block will be executed. If it is equal to 1, else block will be executed. Whenever B is not equal to 1 and A is not equal to 1, a star is printed. They are asking how many times this star will be printed. So we will get into the first call of 10 comma 10. From this we can get the value of A and B as 10. Now we know B is not equal to 1. B is equal to 10. So it enters the if. We know A is also not equal to 1. So it prints star once, and now there is a recursive call A by 2 comma B. What is 10 by 2? It is 5. What will be the next call here? It will be call of A by 2 means it is 5 comma what is B? It is 10. So call of 5 comma 10. So again we are taking A and B values here. A is equal to 5 and B is equal to 10. So both are not equal to 1. We are again printing a star here. Now we have to make a call A by 2 comma B. So what is A by 2 comma B? It is 2 comma 10. The B's value is not getting changed here. Only the A's value is getting changed because they have given A by 2. So now we will go with call of 2 comma 10. Here the value of A is equal to 2 and B is equal to 10 again. So one more time star is getting printed. Actually the correct term is asterisk. So this star is getting printed. A is equal to 2 by 2 comma B. So this time the call statement will be 1 comma 10. When you go for a call with 1 comma 10, we have B is not equal to 1. This is right. But is A not equal to 1? No. So this time we are moving to the else part. So in the else part, we are decrementing the value of B by 1. So B is equal to 10 minus 1, which is equal to 9. Now the value of B will be 9. What is the next call that is given? Call of 10 comma, the current value of B is 9. So this goes to call of 10 comma 9. Now again we are starting with A is equal to 10. Just see how it is getting repeated. When both are not 1, this asterisk is printed, and again we are going for A by 2 comma B call. So this is call of 5 comma 9. So in all these 4 places B was 10. Now B is 9 from here. So 5 comma 9, again asterisk will be printed. 5 by 2 is equal to 2. Again we have 2 comma 9, again asterisk will be printed. This time we have A is equal to 1. So when A becomes 1, this if block will not be executed, but it goes to else block. We are getting into the else block where B's value is decremented to 8. So from here you can understand one thing. So whenever B's value is decremented, A's set of call is repeating for a specific number of times. We have 10, 5, 2, 1. For every 10, 5, 2, 1, we have the same B value. And in this order, 10, 5, 2, 1 order, 3 times asterisk gets printed. And the 4th time, we don't have any printing. So for every B value, when B is equal to 10, it is printed 3 times. When B is equal to 9, it is getting printed 3 times. Now we will generalize this for other B values. So we will check whether B is equal to 1 or not. We will check whether A is equal to 1 or not. So this is outer if, this is inner if condition, and this is the respective else condition. Now B's value is equal to 8. So when B is equal to 8, we will have A is equal to 10, 5, 2, for which this particular symbol will get printed. Then for the 4th call, B will be decremented by one value. B is equal to 8 minus 1, which is equal to 7. Now what will be the next call? It will be 10 comma 7. So now the value of B is 7. Once again we will have A is equal to 10, A is equal to 5 and A is equal to 2, for which the particular symbol gets printed, and then we are decrementing it to 7 minus 1, which is equal to 6, the new value of B. So this is 10 comma 6. When we call 10 comma 6, B is equal to 6, again A will have all these three values and symbol will get printed again. We are decrementing the value by 1 when A turns 1. So now the call will be 10 comma 5. So this will happen for 5, this will happen for 4, this will happen for 3 and this will happen for 2. When B becomes 2 minus 1, which is equal to 1, the call will be 10 comma 1. Now just get into the if block here. Is B not equal to 1? No, B is equal to 1. Once B is equal to 1, the particular call is terminated. It means it comes out. So the program gets terminated when B is having the value of 1. So for every B, this particular symbol, asterisk symbol, is printed for 3 times. And the 4th time the B is getting decremented as I explained before. B had the values of 10, 9, 8, 7, 6, 5, 4, 3, 2. When it became 1, it came out of the call. So 1, 2, 3, 4, 5, 6, 7, 8, 9. B had 9 different values and every time 3 asterisks were printed. So 9 into 3 will give 27 times that particular symbol got printed. So let's check it manually. 3, 6, 9, 12, 15, 18, 21, 22, 23, 24, 25, 26, 27. Option number 4, 27 will be the right answer. If you ask me for exam point of view, you need not get into this part. When you find for every value of B, this symbol is getting printed for 3 times. Just by computing the value of B, you can conclude it is for 27 times. You definitely know until B becomes 1, this particular call will be going on again and again. When B is equal to 10, we know it is printed 3 times. When we found B is equal to 9, it is getting printed for 3 times. Till B is equal to 2, it will be printed for 3 times only. This you have to find it through these 8 calls. So if you compute this, it will be more than enough for you to understand what is happening inside the code segment. Once you find this is going to be the logic, without getting into this particular part, you can conclude the answer is option number 4. Next question. Consider the following code. We are once again into C code. Here they have given 2 functions, F1 and F2. We will get into the main function. We have 2 character strings. One is A, which is having the value 1. And the other one is B, which is having the value 2. So what is this star x star x? We'll just see what they are. The statement character asterisk A is equal to 1 creates a string literal. Generally, if you take character, it will have only one particular character here. When you have asterisk and a variable name, you can have multiple characters together. So what is a string? It is a set of characters. So here they have initialized 2 character strings. One is A and other is B. So this string is composed of 3 characters. Then what about this asterisk x? This particular symbol is a pointer to the string. So we know for integer and all we use P is equal to A like that. It means this is a pointer. But this character string already has an asterisk symbol here. So in order to mention it as a pointer to the string, you automatically introduce another asterisk here. So now they have given calls to the 2 functions. First we are calling F1 function and second time we are calling F2 function. In F1 function we are just passing the values of A and B. In function 2 we are passing the reference of A and B. So let's get into F1 of A and B. Now this is actually a string literal. It has not passed any kind of reference. Already we saw in one code statement, only when the reference is passed the values will get swapped. What is happening here is we are declaring T1, we are just swapping. T1 is equal to X, X is equal to Y is equal to T1. A simple swap operation is happening here. And once you come out of this function, the values will not be swapped. A's value will be retained as 1 and B's value will be retained as 2. There is no change. The function just changes local pointer variables and the changes are not reflected outside the function. Now what about the next function called with ampersand A and ampersand B? Here the strings are swapped. We are assigning T1 is equal to asterisk X is equal to asterisk Y is equal to T1. So here we are swapping it using the pointers. That is what it's mentioned as. It swaps strings by swapping pointers. Here's the difference and that's why the declaration goes like pointer to the string instead of a string literal directly. When character pointer for strings are used, change X and Y to point each other's data. This particular process is called as swapping the pointers. In a function, if we want to change a pointer, then we need to pass a pointer to the pointer. This is why we are using double asterisk symbol here. There are actually two methods to swap strings. One is using swapping pointers and the other is using swapping the data when you use character array. So this swapping pointer is what they have done in this particular F2 function. And this swapping data, I will leave it to your learning. There are lots of references even in your books and in the web. You can just go and have a look how swapping occurs in both the methods for a better understanding. Once we know the strings are swapped here. So what will be the value of A now? It will be 2. And what will be the value of B? It will be 1. The values of A and B are swapped in the F2 function. First we are printing F1 function. It should start with 1, 2. We will retain 1 and 3 now. From second function call, what did we get? We have swapped the string, so it is 2, 1 now. So 1, 2, 2, 1. Option number 1 exactly matches the output. Option number 3 is just repeating the same thing, but F2 will definitely swap the strings. So 3 is also wrong. So this option 1 will be the output of the above code. Only when you execute the code and see, you will definitely understand what is happening inside. As long as you see in the screen, everything will be so good, so comfortable. But when you get into the exam hall, this might not help everyone. Some may be very comfortable with such kind of learning, they will manage. But it does not suit everybody is what I wanted to say. Next question. Consider the following C program. We are given an array X 2, 4, 6, 8, 10. A is declared as integer, B is initialized as 0 and there is a pointer initialized as X plus 4. So let's take the array first. The values are 2, 4, 6, 8, 10. And now we have the index 0, 1, 2, 3, 4. When this statement is given, we know the pointer will be pointing to X of 0. That is the first address. But when it is X plus 4, it means it is pointing to the fourth index. The value of pointer Y will be 10. When it is asterisk Y is equal to X, it is referring the first index element. When it is asterisk Y is equal to X plus 4, it is referencing the fourth index element. What is the fourth index element? It is 10. So the value of the pointer will be 10. Now we are given a for loop here. A is equal to 0, A is less than 5. It means A can take the value of 0, 1, 2, 3, 4. Inside the for loop, we are given calculation for B. So this evaluation is what we are going to do it step by step now. B is equal to B plus, you have Y pointer minus A minus of pointer Y minus A. So when you calculate B, we will use the values from the other two columns. So let's first understand what is this part. Star Y and star Y minus 0 is same. So when this becomes star Y minus 1, it refers to the previous element. When it is y minus 2, it refers to the previous element. Again from here, when it moves backside, it goes to the previous element. So this is how the movement will be given for y minus 0, y minus 1, y minus 2, y minus 3 and y minus 4. This is when y minus the value is given here and the asterisk is placed outside. Then what about asterisk y minus a? What is asterisk y? It is 10. So this can be evaluated as 10 minus the value of a. We are just going to use it as 10 minus a because we know asterisk y is equal to 10 based on this particular initialization. Now we will get into the for loop. Let's take a is equal to 0. So we know this is 10 minus a. So 10 minus 0 is going to be 10. What about y minus 0? The value is 10 here. You should not look at the index, but you should look at the value only. This is for computing purpose. I am just telling you where it will come and sit. But you have to access only the elements present in the index. So we are starting with 10. So this particular expression will yield 10. Now b is equal to b plus. What is the value of b? B is actually initialized to 0. So 0 plus, let's take this to be column C2 and this is column C3. So this value should be taken from C2 and this value should be taken from C3. What is C2 column value? It is 10. So this 10 is placed here. What about C3 column value? It is 10 again. And we have subtraction here. So it is minus 10. 10 and 10 will get cancelled. B is equal to 0. So we have the value of B to be 0. We'll go for a is equal to 1. 10 minus 1 is equal to 9. What about y minus 1 here? We have to move to the previous element. It is 8. So I have just placed the index part here. So the respective element will be 8. So we are getting 8 here. B is equal to, already the value of B is 0 only, plus C2 column has 9, C3 column has 8. 9 minus 8 will give you 1. Now the value of B is 1. Let's increment a. 10 minus a's value is 2, which is equal to 8. Now y minus 2 will point to 6. B is equal to, the value of B is 1. So 1 plus C2 column it is 8. C3 column it is 6. So 1 plus 8 is 9. 9 minus 6 is 3. So B is equal to 3. Now a is incremented to 3. 10 minus a is 10 minus 3, which is equal to 7. Now y minus 3 will be 4. B is equal to 3 from the previous part plus 7 from C2 and 4 from C3. 10 minus 4 will give you 6. So B is equal to 6. What about a when it is incremented to 4? 10 minus 4 will give you 6. Y minus 4, this part will yield 2. B is equal to, already it is 6. Here also it is 6. It is minus 2. 6 plus 6, 12 minus 2 is 10. So the value of B is 10. When A becomes 5, it will get out of the loop. Now we have a print statement. It is asking for the value of B. What is the B value that we found at last? It is 10. Option number 4, 10 will be the right answer. This code segment might be very easy for you to see, but if you don't understand this part and this part, this computation may go wrong. Work this code segment in an online compiler. Try to fetch the values separately for this expression and this expression. First you try to print y minus 0, y minus 1, y minus 2, y minus 3, y minus 4. Understand how it accesses the array. Then go for this calculation inside the loop. After you understand column C2 value and column C3 value, then you get into the evaluation part of B. Next question. Which of the following is correct way to declare a functional pointer in C? What is the general syntax to declare a functional pointer? We will have a return type. Then we will have function pointer name along with the pointer symbol asterisk. Then we will have the parameters as type 1 and type 2. It's having 2 stars here, so 3 and 4 cannot be in the option. So which one should we consider, 1 or 2? The declaration of a function pointer variable has an asterisk just before the function variable name. Proper nesting requires a pair of parentheses around the two of them. It means the pointer symbol and the function name together should be enclosed in parentheses, which states that option 1 is wrong, but option 2 will be the right answer for this question. This is int, open parenthesis, close parenthesis, pointer symbol and the function pointer name that types as int comma int. It is actually matching with option number 2. Next question, what will be the output of the following C code? So we have 5 array values. This time we will take it vertically, 10, 20, 30, 40, 50. How this array will be arranged in the memory block? So let's take a sample address of 1000. We know every integer is of 4 bytes with respect to C programming language. So if this value 10 has a base address of 1000, then the next value will be 1000 plus 4, which is equal to 1004. The third value will have plus 4, 1008. The fourth value will be placed in plus 4, 1012. Then the fifth value plus 4, 1016. This is how the address will be there. So we know whenever a pointer is going to point something like ARR, this will be referring to ARR of 0, the 0th index. So this is 0th index, this is first index, this is second index, this is third index and this is fourth index. So ARR is an integer pointer which points the first element of the array. That is what I explained here. So now if we take this to be ARR, this will be ARR plus 1, this will be ARR plus 2, this will be ARR plus 3, this will be ARR plus 4. ARR plus 1 means if we move ARR by 1 position, it will point the second element. When we move it by 2 position, it will point the third element. When we move it by 3 positions, it will point the fourth element. When we move it by 4 positions, it will point to the fifth element. You have to understand this particular order. This is not different from what we have seen already. So let's go for the next line of code. Int pointer is equal to, they have given something like ampersand of ARR plus 1. Let's get into the print statement. We are actually asked to print 2 values. One is star of ARR plus 1 and another is star of P minus 1. So far we have seen only till here. What is ARR plus 1? It is this part. When we say asterisk of array plus 1 or array plus 2, we have to pick up the element. So what is the value present in ARR plus 1? It is 20. So whichever options has 20 in the first place can be retained. We can rule out 1 and 3. What about ampersand of ARR? This is actually an integer array pointer which points to the whole array. It means when I say ampersand of ARR, all these elements are referenced together as ampersand ARR. So this particular block is referred as ampersand ARR. This ampersand means it refers to a block of array elements. For this program, it refers to all the 5 elements together. So when we say it is ampersand of ARR plus 1, it means we are moving by 1 position where it will point to the next block of 5 elements. So let's take another 5 elements and their addresses. So 1016 plus 4 will give 20, 20 plus 4 24, 24 plus 4 28, 28 plus 4 32, 32 plus 4 is 36. So this set of 5 elements is ampersand ARR, means the next set of 5 elements will be ampersand ARR plus 1. If this is going to be without ampersand, just incrementing 1 position, you are able to traverse the elements. When this is with reference to a particular block, plus 1 will actually move block to block. If this is going to be block 0, plus 1 will be moving to block 1. If ARR is for a particular element, ARR plus 1 will move to the next element. Similarly, if ampersand ARR is for a particular block, ampersand ARR plus 1 will move to the next block. This is what is mentioned in the diagram here. This is integer star, which is in this format. Instead of this particular location part, we are mentioning it is the second block. So from here, pointer is referring to the first value of the second block. So why are we mentioning it into the first element? When I say pointer is equal to array, which element are we referring here? We are referring to the index 0 element. Similarly, for this block, which is the index 0 element, it is this one. So this is index 1, index 2, index 3 and index 4. Based on that, the pointer is placed here. Previous question we saw asterisk of y minus 0 is one element. Asterisk of y minus 1 is the previous element. Now just compare that learning here. Asterisk of p minus 1 will be previous element. So what will be the previous element to this particular memory location? The previous element will be the last element of the previous block. I will take this to be 60, 70, 80, 90 and 100. Let's take this as value. If these are going to be continuously arranged in the memory, because it has 1016, it has 1020. Just imagine a block like this. So let's take this way. So till here we know it's a block. Now the pointer is present here and it is continuously allocated because it is 1016 here and the memory is 1020 here. When I say it is star of p minus 1, it means you have to move one element before as we did in the previous problem. What is the previous element as per this continuous memory allocation? It is the element 50. So when you want to print p minus 1 here, it will print 50. Option number 2 will be the right answer. Option 4 is wrong again. So if you take this to be the pointer, the previous element you can take it as 40. So you might make a mistake there. That's why they have even included this option. So the pointer is actually referring to the 0th index of the first block. When it is continuously arranged, it will refer to the previous element, means it will go to block 0 and the 4th index element. So this will be the previous element. When you think it as continuous memory allocation, you will be able to understand how we get p minus 1. But in order to understand this ampersand ARR plus 1, you have to look it in this particular aspect. Next question, what is the output of the code given below? It's a C++ code and it has a base class and a derived class. So base class is having a constructor. What is a constructor? Any member function or any method in the name of the class will be constructor. So we have a constructor here and we have a destructor here. Anything with the symbol, tilde symbol we will say, that is a destructor. Similarly, in derived class, we have a constructor as well as destructor. Inside the main function, they are actually creating an object and they are deleting the object. Here, the base class pointer is pointing to a derived class object. So just get inside the constructor and the destructor. They have just given a print statement. This is base constructor, this is base destructor, this is derived constructor and derived destructor. So here they are asking for the output. It means they wanted to know when an object is created, what will be the order of execution, whether base is getting executed first or derived is getting executed first. Similarly, by means of deleting the object, they are asking which destructor is invoked first. So we have two aspects for the question. We have to know which constructor is invoked first and we have to know which destructor is invoked first. Let's see some statements. When the derived class object is made, the base class constructor is called first, which means this particular constructor is called first and automatically this will be called next. So the order of constructor will be base constructor statement and then derived constructor statement. This is the case of constructor. It's a good practice to make all destructors virtual. So they have made it as virtual here. Why have they asked us to make it as virtual? Non-virtual destructors might result in cases where the derived class destructor is not called. So if you take the fourth option, derived destructor is not called. But here they have mentioned the base destructor with the keyword virtual, which means in this case definitely derived destructor will be in the option. So from this point we can rule out option 4 from the answer list. So whenever non-virtual destructors are there, there is a possibility where the derived class destructor is not called. When it is called, what does it mean? You will have this statement printed here. Since the statement is not printed here, we are ruling out option 4. While creating an object, this will be the order. While deleting the object, how will the order of destruction be? The current class destructor is called. So we are actually creating a pointer to the derived class object. So now we are in derived class. So the current class here is derived class. So the current class destructor is called. Can we call the current class destructor? Yes, we can call, because the base class is declared with the virtual keyword. So what is the destructor statement? Derived destructor. So the first statement will be derived destructor. Data members are destroyed in the reverse order of construction. We are not getting into this part as per this code segment. The parent destructor is called. What is the parent destructor? It is the base destructor. So what is the statement here? Base destructor. So initially the constructor will be called when the object is created, and then when the object gets destroyed or deleted, the destructor will be called. So the output will have the constructor set of statement first. What is the constructor set of statement? First base constructor is called, then derived constructor is called. We should start with base constructor. Two options are starting with base constructor, so we will rule out even option 3. Base constructor and derived constructor are here. Base constructor and derived constructor are here. So constructor part is done. Now what about destructor? We have to go with the order of derived and base. So here it is derived destructor and base destructor, but here they have called base destructor first, which is wrong. So option 2 is also ruled out. Option 1 will be the right answer with the correct order. So these two are for constructors and these two are for destructors. So when an object is created, we call the constructor, and when it is deleted, the destructor part is called. When you don't have virtual here, derived destructor may not be called. That's why this makes it sure that derived destructor is definitely called. So these are little points that we have to learn while we are preparing for such questions. Next question. Which of the following C++ statements correctly declares an abstract class? So what is an abstract class? A class is abstract if it has at least one pure virtual function. Only one option is having the virtual keyword. So the other three can be ruled out. What about a pure virtual function? It is declared by assigning 0 in the declaration. This is what they mean by it. Option number 1 will be the right answer. Next question. Arrange the following steps of file handling in C in the correct order. The operations can be performed on a file in this way. First, we will go for opening a new file, or we have to open an existing file. So even for creation, you have to open a particular file. Once you open a file, you can always go for a check in the code part. You have to check whether the file can be opened. It is related to permission, or whether the file is existing or not. So whether it is in the case of existence or whether it is in the case of permission, we have to check whether the file can be opened. So when the file is not found or when the file cannot be opened, it returns null. This is actually a condition that you have to specify in the C code segment. If you don't check and specify them, this will result in an error. This is what they say, check for error. The first part is where you have to open a particular file, and the second part is you have to check for some kind of error. You have to check whether the file is existing. Even if it is going to exist, you have to check whether you have appropriate permissions to access it. So this is checking for error. After opening an existing file, you can read from the file, or if you are opening a particular file, you can write to the file. So reading and writing can happen simultaneously. You can update an existing file. You can do whatever you want. This can be taken as the next step. Once the work is over, you have to close the file. So open the file will be the first step. Only one option is starting with C. So open the file followed by check for error followed by read from or write to the file followed by closing the file. Option number 3 will be the right answer. 1, 2, 3, 4. This will be the order. Next question. Which of the following statements about pointers in C are true? Pointers can be used to access array elements. So far in all the output code segments we have been seeing the same thing only. So definitely A is true. So any option that excludes A can be ruled out at this stage itself. Now we have to check whether B is true or C is true. Let's take the next statement. Pointers can store the address of another pointer. Yes, they can store the address of another pointer and we call such pointers as double pointers or pointers to pointers. So definitely this statement is also true. Without even looking C and D, you can mark option number 2 as the right answer. So we know 1 is also wrong. Now we will understand why C and D are not true. Pointers are automatically dereferenced in expression. It's not difference, it is actually dereferenced. What is dereferencing a pointer? It means accessing the value stored at the memory address pointed to by the pointer. We actually dereference it using this particular symbol. When you mention a pointer, it actually denotes the address of the variable. Only when you use asterisk pointer, it will denote the value. This is actually dereferencing a pointer. In C and C++, pointers are not automatically dereferenced. You need to explicitly use the dereference operator to access the value stored at the memory address pointed to by the pointer. So we are using pointer to store the address of the variable. In order to access the value of the variable, you have to dereference it. We can mark C as false. What about D? Pointers cannot be used to access structure members. This is also false. To access members of a structure using pointers, we use the arrow operator. You could have seen such accessing code in structure related code segments in C. So definitely this is possible. So D is saying it cannot be used. Not so. It can definitely be used to access the members of a structure. Next question. Which of the following are true about constructors in C++? Constructors are member functions of a class that are automatically called when an object of the class is created. Actually, they are used to initialize objects. One class can have multiple constructors. So they may differ by the number of parameters or by the type of parameters, which says a constructor can be overloaded. So overloading is done through this point. A is true. A constructor does not have a return type. Yes, a constructor cannot have a return type. You cannot even mention void there. Void is actually nothing, but even that is a return type. You cannot even mention that one. It is because constructors are basically used to initialize the object. They are not used to return some value. So B is also correct. So whichever options includes A and B can be kept. The remaining options are ruled out. Now we have to check whether C is right or not to mark the answer. A constructor must be declared as a friend function. What are actually friend functions? They are non-member functions that are given special access to the private and protected members of a class. Usually, other than the member functions, you cannot access the particular class private and protected members. So friend functions can be given that privilege of accessing private and protected members of a class. They are declared using the friend keyword inside the class definition. So what about constructors? Constructors do not need to be declared as friend functions because generally constructors are going to be called only when the object of that particular class is going to be created. There is no mandate condition that they have to be declared as friend functions. So here the statement is must be declared, which makes it as a mandatory condition. It is not a must condition. So C is wrong. What about D? A constructor is called when an object is destroyed. You can close your eyes and mark this as wrong. When they say a particular object is going to be destroyed, destructor will come into existence and not constructor. Destructor is related to the destruction of an object and constructors are related to the creation of objects. So C is also not included. We can mark option number 4, A, B only as the right answer. Next question. Match list 1 with list 2, HTML, DHTML, XML, Java. If you would have practiced the previous year question, the cancelled June 2024 exam, I would have explained about HTML, DHTML and XML there. So HTML is actually used to create web pages. So we can map HTML to 2. Defines the structure of web pages. A2 is available in 2 options. The rest of the options can be ruled out. What about DHTML? The question in June 2024 was which languages given are markup languages, and DHTML was also one of the option. But I have told you there itself that DHTML is not a particular markup language. It is a term that is used to give dynamic behavior to the web page. So which statement justifies that? The first one. So B will be mapping to 1. Allow for dynamic and interactive web pages. It is because of the use of HTML, CSS and some scripting languages like JavaScript. So when you include CSS and scripting languages along with HTML, that will induce dynamic behavior or that can give some interaction to the web pages. So DHTML is a term and it's not a particular markup language. What about XML? So XML is used for data storage and transporting. When you want to transport data from one particular web document to another document, you can use XML. So C will be mapping to 4. B1, C4. So here itself we can find 2 is also out of the race. What about Java? Java can be mapped to 3. Object-oriented programming language for web applications. So this is also right. Option number 3 will be the right answer. With this, we are completing Unit 3 solutions. Let's solve Unit 4 Database Management System questions. Fifth normal form is concerned with. If you take all the 5 normal forms here, 1NF is about the atomic values. It means you have to eliminate multi-valued attributes or nested relations, we can say. Second normal form is eliminating partial dependency. Third normal form is eliminating transitive dependency. Fourth normal form is about eliminating multi-valued dependency. And fifth normal form is about eliminating the joint dependency, we can say. Option number 1, joint dependency will be the right answer. So instead of saying as eliminating multi-valued attributes, we can say the first normal form will have tables where every column or every attribute will have atomic values. And regarding the second normal form, when we say it's about eliminating partial dependency, it also means that all the attributes should be fully functionally dependent on the primary key. When you take 4NF and 5NF, you cannot say multi-value dependencies and joint dependencies are completely eliminated. The dependencies do exist with regard to candidate keys, as we saw in certain previous year question paper. Multi-value dependency is for fourth normal form. Functional dependency we can map it to second normal form because it is about being fully functional dependent on primary key. What about the second option, domain key? We have something called domain key normal form. A relation schema is said to be in domain key normal form if all constraints and dependencies that should hold on the valid relation states can be enforced simply by enforcing the domain constraints and key constraints on the relation. Just by enforcing these two constraints, we will be able to hold all kinds of constraints and dependencies on the valid relation is what it says. Next question. How does a relational database ensure data integrity? Most database applications have certain integrity constraints that must hold for data. A DBMS should provide capabilities for defining and enforcing these constraints or rules, we can say. The schema-based constraints include domain constraints, key constraints, constraints on nulls, entity integrity constraints, and referential integrity constraints. So there are these many constraints available on the schema. Let's read the options. By encrypting all data stored. Relational database focus is not on encryption. So we will rule out option 1 by enforcing rules defined in the schema. So these 2 points actually support that. Enforcing rules means we can say enforcing some kinds of constraints. Constraints or rules both are actually same only, and these rules are defined in the schema. So what kind of constraints are defined here? Domain constraints, key constraints, constraints on nulls, entity integrity constraints and referential integrity constraints. So keeping these 2 points in mind, we can mark option 2 as the right answer. What about option 3? By compressing data for efficient storage, we are not dealing with compression in relational database. The next option, by allowing unrestricted access to all users, this is also ruled out. Database integrity refers to the requirement that information be protected from improper modification. Modification of data includes creating, inserting, updating data, changing the status of data and deleting data. Integrity is lost if unauthorized changes are made to the data by either intentional or accidental acts. So integrity will be lost if unauthorized changes are made. But here they are saying by allowing unrestricted access to all users, it will ensure data integrity. This point is totally contradicting the statement here. That's why we are ruling out option 4. Next question, what is SQL primarily used for in the context of relational database? What is SQL? It is structured query language. Why do we actually use SQL? We use it to create database, we use it to create table, then we use it to alter columns, we use to insert data, update data, delete data and retrieve data. What are you actually doing with the data? You are actually working with the data. So there are operations like create, alter, insert, select, update, delete. These are the basic commands that we will be using in SQL. So I have just listed them. Now let's see the first option. To design user interfaces, no, SQL does not involve in user interface designing. To create and manipulate database, yes, this is right. We create database and tables and we manipulate database by working with the data. So option 2 will be the right answer. To display data on web pages, HTML is used to do this work, so it is not SQL. To format printed reports, this is actually done by something called the PostScript format, we can say, or the PDF is also something that will give you in the form of printed report only. It is also not a part of SQL here. And regarding user interfaces, it can be designed using any front-end related technologies. So we can clearly say that SQL is not involved in option 1, 3 and 4. Next question. Which of the following best describes the structure of a relational database? Whenever we talk about relational database, we talk about table. When we talk about table, we know rows and columns exist. From this we can say data organized into tables with rows and columns will be the structure of a relational database. Option number 1 will be the right answer. We'll just have a look on all the 4 options. So this is the format of rows and columns. So in short we can say the RDBMS structure. What about data organized into files and folders? You can take any file organizer or even Windows Explorer in Windows operating system. You will have folder arrangements. Inside the folder you will have folder with file arrangements as you see here. The third option is about data organized into a hierarchical tree structure. So there will be a parent and child kind of structure here. So the parent is named as root and there are level 1 and level 2 structures. So data organized in this format is hierarchical. This gives a tree structure to the data. What about the last one? Data organized into a network of interconnected nodes. Here this is similar to a graph we can say. Network of interconnected nodes is university has 2 kinds of departments. Department has some kind of dependencies between them. Similarly, every department can access the library. At the same time, these department can access the computer lab also. When it follows some kind of tree structure, we call it as hierarchical. But when it is in the form of graph, we can say it's a network of interconnected nodes. Next question, consider a schema R with attributes P, Q, R, S and the following functional dependencies, the FDs are given here. Then decomposition of R1, R2 and R3 is. If you can remember this question, it is already asked in June 2023 session. But instead of PQRS, the attributes were ABCD. We have to check two things here. One is the dependency preservation property and another one is lossless join property. The dependency preservation property ensures that each functional dependency is represented in some individual relation resulting after decomposition. Let's take R1. We have PQ. Is there any dependency with P and Q? Yes, we have P determines Q. What about R2? We have Q and R. Do we have any dependency here? Yes, we have Q determines R. What about R3? We have QS. Yes, determines Q is directly here, and regarding R determines S can also be added to R2 here because this is the remaining dependency available here. So from Q you will be able to determine R, from R you will be able to determine S is what R2 is specifying. This ensures that each functional dependency is represented in some individual relation. So R1 has one FD, R2 has two FDs and R3 has one FD. Overall, we have covered all the four FDs. So this is definitely dependency preserving. So whichever option is having dependency preserving can be kept and the other two options are ruled out here. Now we have to check whether it is a lossless join or not. What is actually lossless join? The decomposition of R is lossless when the join yield the same relation as in R. So let's check. When you combine R1, R2 and R3, what are the attributes that you can get? You can get P, Q, R, S. Are you getting the same relation that is in R? Yes. The union of attributes must be equal to the attribute of R. It is perfectly done. The intersection of attributes must not be null. So let's take the intersection of R1, R2 and R3. We have P, Q, QR and QS, which means we have Q. It is not null and the common attribute must be a key for at least one relation. Where it is a key, we can say it is a key in R2. This condition is also satisfied here. So we can mark it is a lossless join too. So we will rule out option 3 which says it's not lossless join. We go with option number 1. Dependency preserving and lossless join as the right answer. Next question. Consider a relation schema R U, V, W, X, Y, Z on which the following functional dependencies hold. They have given a set of functional dependencies here. The candidate keys of R are. The exact question came on June 2020 session. What is actually a candidate key? A set of attributes is a candidate key if and only if the set functionally determines every attribute of the relation. From the candidate key, you should be able to determine every attribute of the relation. So let's take the functional dependencies. U determines V, VW determines X, Y determines W, X determines U. We have to check which attributes are actually missing in the right hand side of the FDs. So what are the attributes that are not in RHS? So just check, do we have U? Yes, we have U here. Do we have V? We have V. Do we have W? We have W. Do we have X? We have X. We don't have Y and Z on RHS, which states that candidate key must have Y and Z attributes in it. So just check the options. Do we have Y, Z in option 1? No. Do we have Y, Z in option 2? No. Do we have Y, Z in option 3? We don't have it here. So this is also ruled out. What about the fourth one? We have Y, Z in all the keys here. So we can mark option 4 to be the right answer. But in June 2020 video, I have explained you find the closure of the candidate key. So even that we can do it here. Let's take the first one. uy, what does it determine? From uy you will be able to take u, from u we can determine v, from v we cannot do anything, from y we can determine w, from v and w we will be able to take x, then y is also there. Is there any way that you can determine z? No. So this is not a part of the solution. When you say uy cannot determine it, definitely this uy cannot also determine it. So what about the fourth one? We'll just try for all the three. U, y, z. If you take u, you can find v. Then with the help of y, we can find w. With the help of v and w, we can find x. Then y, z is there as it is. So the closure is found here. What about v, y, z? From y, we will be able to find w. So let's take y, z as it is. Then we have v here. V and w together can give x. From x we will be able to find u. So here also we are able to find. What about x, y, z? So from x we will be able to find u. From u we will be able to find v. Then we have x, y, z from the candidate key. So using y we can find w. So here also it can be found. We tried working with all the 4 options in that video. So I am just stopping with this part in this video. Next question. Which of the following relations cannot be decomposed into BCNF with a lossless join and dependency preserving decomposition? Basically they are asking which cannot be decomposed into BCNF. It means these relations are actually not in BCNF. Because of that, you have to decompose them. The first point is they are not in BCNF. The second point is if they are not in BCNF, you have to decompose the relation. When you decompose, those relations should be in BCNF. When you decompose one of the options here, it will not be in BCNF with the lossless join and dependency preserving decomposition. It means that BCNF form will either have a lossy join or it may not be dependency preserving. At least this or this will fail in the decomposed relation they are saying. Hope you understand the question. So this BCNF form should be checked for lossless join and dependency preserving. When you take 3 of the options, we will be able to decompose it, and every decomposed relation will have lossless join and dependency preserving property. Only one of the option will not be in this particular aspect. We have to find that one option. In order to work with this question, we have 3 steps basically. We have to first find the candidate keys from the given FDs. Then we have to check for BCNF violation. If it is not in BCNF, we have to go with decomposing the relation. Let's take the first relation. So we have to go for the candidate keys. We have to check which attribute is missing in RHS for candidate key. All the attributes are actually available in RHS. So there is no mandatory attribute that must be present in the candidate key. Now along with every other attribute we have to add and see. Let's check for WV now. So W can determine X, W can determine Y and Y can determine Z. So VW is a candidate key. Next we'll check for WX. WX will determine V. Then again from W we will be able to determine Y and Z. So WX can also be a candidate key. What about VX? So once we find there is no single attribute that can be taken from RHS, we are trying with the combination of 2 attributes. VX will give W. So from W we will be able to take Y and Z. So the candidate keys for this particular relation is VW, WX and VX. Now what is the condition for BCNF? BCNF states in FD the LHS should be a super key. Candidate key is called as the minimal super key. So we have to find whether all the LHS of FD are super keys. It's a candidate key, it's a candidate key, it's a candidate key. But W determines Y violates BCNF because W is not a super key. Now we will decompose the relations based on the FDs. So based on the FD, we will decompose it as R1. So we have VWX here, WXV here, VXW here. So we will group these three attributes together. What about the next relation? We have W determines Y. Keeping W as a candidate key, we will be able to determine Y. So we will make W and Y to be a separate relation. What about the next relation? We can have Y determines Z, where Y becomes the candidate key. So I am just decomposing the table based on the functional dependencies. So if we take VWX, just check the dependencies. VW determines X, then we have WX determines V, Vx determines W. We are able to take all the dependencies here. W determines Y is taken for R2, Y determines Z is taken for R3. So all the dependencies are preserved here. What about the join? We are able to fetch all the attributes when we perform a join on all the three relations together. So this is actually dependency preserving, and we have lossless join too. Cannot be decomposed is the question. So this can be decomposed. So it is not going to be the answer. Now let's take the second one. We have the functional dependencies VW determines W and X determines Y. Here from these two dependencies, we have to find which of the attribute is not in RHS. V is not there, X is not there. Definitely candidate key must have Vx attribute in it. So we can take the candidate key to be Vx, and along with that we have to find a combination here. With X we will be able to determine Y. So X and Y can be found out, and similarly V can also be determined directly. So in order to determine W, definitely you need W here. So let's find the minimal cover for this. When we find minimal cover, this dependency is actually removed because W is present in LHS as well as RHS. So we are removing this dependency, which will result in only one dependency, that is X determines Y. Now X determines Y is alone there in the minimal cover. We know the candidate key here is VXW. Based on this particular candidate key, we can say this dependency is violating the BCNF form. Now we have to decompose the relation definitely. So we will decompose it as VWX, that holds the candidate key part, and then X and Y separately because it is the one that is violating the BCNF form. While we are going to take the union, we will have all the four attributes. So definitely it is lossless join. What about dependency preserving? In the minimal cover, we have only one dependency here. So X determines Y is satisfied. Whatever dependency is there in minimal cover, that is alone more than enough for checking with dependency preservation property. This particular relation has become too simple to be solved, and so we can say this also satisfies both the properties, and of course both are in BCNF form. 2 is also decomposed into BCNF with lossless join and dependency preserving properties. Now let's get into the third one. We have VW determines X and X determines Vy. So when we try to find the minimal cover, we will have VWX, and since we have two attributes in the RHS, we have to split it as X determines V and X determines Y. This will be the minimal cover. So now we have to find the candidate key. Which particular attribute is missing in the RHS? W is missing in the RHS. So candidate key must have W here. So we have to check the combination of W now. So let's combine W with V and try to find whether we are able to get the closure. With V and W we will be able to get X. With X we will be able to get V and Y. So all the four attributes are derived here. So VW can be taken as a candidate key. We have WX. W is there, X is there. From X we will be able to find V and Y. the candidate keys can be WV and WX for this particular relation. Now we have to check which dependency is actually violating the BCNF. When you take the first dependency, we have VW, it's a part of candidate key, we don't have any issue. What about X determines By? This actually violates BCNF. So we have to go for decomposition of relation. We have to decompose it into R1, which will have XVY, because this is the relation that is violating the BCNF. When we take R2, we will have only X and W here. Since we are able to find V and Y from X, we are grouping them as a separate relation. So this is one candidate key. We are not considering this, but we are taking this candidate key so that becomes a separate relation. When we decompose this relation as R1 and R2, this relation will have X determines Vy dependency that belongs to the relation. So here it is fine. But do we have any dependency that involves X and W? No. There is no such FD that is occurring in the main relation. This particular dependency is lost. Since it is lost, we can say they are not decomposed into BCNF with the lossless join and dependency preserving decomposition. One is actually satisfied. The other relation does not have this dependency preserving attribute. So 3 is not dependency preserving is what they have concluded. Now let's check the fourth one. We have VW determines X, X determines Y, Y determines Z, and Z determines V. So which attribute is not in RHS? It is W. So candidate key must have W. So we'll start with W. We have to check the combination of other attributes. Let's start with V first. WV. So basically we'll have VW here. From VW we'll be able to get X. From X we'll be able to get Y. From Y we'll be able to get Z. So WV is a candidate key. Now we have to check W with the next attribute X. So we have WX here. From X we'll be able to get Y. From Y we'll be able to get Z. From Z we'll be able to get V. So we are getting all the attributes here. So WX is also a candidate key here. Then we have to check WY. So we have W here and Y. From Y we are able to get Z. From Z we are able to get V. From VW we are able to get X. So all the attributes are here. Next we have to try with WZ. So we can take W and Z here. From Z we are able to get V. From V and W we will be able to get X. From X we will be able to get Y. So we can place all these 4 in candidate keys, WY and WZ. So now check which particular functional dependency is going to violate the BCNF. While starting from the first, this will be violating the BCNF. We have to decompose this relation. The first relation we can have XY from this dependency. The second relation can have YZ. Then the third relation can have ZV, and the fourth relation can have the dependency VWX. Even when you take minimal cover, none of the dependencies will be lost. So based on that particular minimal cover only, we are finding all these 4 relations. Now when you try to check all the dependencies, this is X determines Y, Y determines Z, Z determines V, VW determines X. So all the dependencies are preserved, and when you join them together, are you able to get all the attributes? Yes. So this is also a lossless join. So this is also fine. There is an additional point. In case if there is a loss dependency while you are decomposing the relation, and if that dependency is not a part of minimal cover, it can be ignored. You have to find the minimal cover, and when you find one dependency that is not present in the minimal cover is not present when you decompose the relation, you need not worry about it. Make sure whatever dependencies are present in the minimal cover must be present when you decompose the relation and when you check for dependency preservation as well as lossless join property. As for this question, we can say the relation that is given in option 4 is in 2NF as well as in 3NF, but not in BCNF. We can mark option number 3 as the right answer because that is the only relation that cannot be decomposed into BCNF with a lossless join and dependency preserving decomposition. Next question. In a schema R, A, B, C, D, E, F, G, H, each field of R contains only atomic values. It is in first normal form. F is a set of functional dependencies, so that F closure is exactly the set of functional dependencies that holds R. The relation R is, they are asking us to find whether R is in 1NF, 2NF, 3NF and BCNF. Now we have to get the minimal cover. So in the minimal cover, what are the dependencies that we have to consider? CH determines G will definitely be there. What about A determines BC? This A determines BC can be taken as A determines B and A determines C. And this B determines C, F, H can be taken as B determines C, B determines F and B determines H. What about F here? F determines E and F determines G. Here A determines B can be taken in the minimal cover. What about A determines C? Through A, if you are able to find B, from B you can find C. So you need not use A again to find C. So this can be taken as redundant dependency. So we will rule out this. We will go with B determines C. After that, is anything there to find F? Only B is there. So we will go with B determines F. Is anything there to find H? Only B is there. So we go with B determines H. So we have crossed 3 dependencies in the question. What about E determines A? Yes, it can be included. F determines E is necessary in the minimal cover. What about F determines G? From A we will be able to find B. From B we can find C and H. From C and H we can find G. So when there is a possibility to determine G, we need not go with this F determines G dependency. So this is also redundant, we can remove. So we have removed 2 dependencies from the given list and we have arrived at the minimal cover. If we look at the option, from only atomic values, we know it is in first normal form. But for second normal form and third normal form, we should check for partial dependency and transitive dependency. So what is partial dependency? A prime attribute should derive a non-prime attribute, and for transitive dependency, non-prime attribute should derive non-prime attribute. Transitive dependency is concerned with 3NF and partial dependency is concerned with 2NF. When you find these 2 conditions to be true, we can say they are not present in 2NF and 3NF. So first, let's find the candidate keys. Whatever attribute is present in the key, that will be prime attributes. Whatever is not present in the key will become non-prime attributes. Only by finding the candidate key, we will be able to find the prime and non-prime attribute. Now let's go for the candidate key. Which particular attribute is actually missing in RHS? A is there, B is there, C is there, E, F, G, H is there. D is missing. So D must be present in candidate key. So along with D, we have to try every other attribute. Let's start with DA. I'll be able to find A. From A, I'll be able to find B. From B, I'll be able to find C. And D is already present. Then from B, I will be able to find F. Then from B, I will be able to find H. From F, I will be able to find E. And from C and H, I will be able to find G. So did we get all the attributes? Yes. What about D, B? We have B, we have D. So from B, I can find C. From B, I can find F. From B, I can find H. From C and H, I can find G. From F, I can find E. From E, I can find A. All the attributes are there. What about D, C? You don't have C separately in the left hand side, so leave it. So D, E we will check. We have D and E. From E, I can take A. Similarly, from A it is B, B it is C. From B it is F, from B it is H. Again from C and H we have G. So all the attributes are taken here. Then we have to try with df. We have D and we have F here. From F we will be able to take E. From E we can have A, then B, then C, then G and then H. So I have already explained you how we get F, H and then how we are finding G. So the same process is repeated again. Can we combine D and G? We don't have G in the left hand side. Can we combine D and H? We don't have H individually in left hand side. We are leaving out C, we are leaving out H and we are leaving out G here. So what are the candidate keys here? DA, DB, DE and DF. From this we have to take the prime attributes or the key attributes we can say. What are the attributes here? It is A, B, D, E, F. What are the non-prime attributes then? Whichever did not occur in prime attribute becomes the non-prime attribute. Now we have to check whether this particular relation is in second normal form, third normal form or BCNF. Whenever we check with normal forms, always start from the highest normal form. So it will be easy for us to eradicate. We are going to start with the BCNF now. In BCNF, LHS must be a super key. Let's take this to be BCNF. Let's take this to be third normal form and this one to be the second normal form. Is LHS a super key in the first dependency CH determines G? No. When you don't satisfy the first condition here, automatically this is not in BCNF. So option 4 is ruled out. You can check with the other dependencies too. It is just A, B, E and F. Candidate keys are not at all there. So we can just say all the dependencies are actually violating the BCNF part. Now we have to check for the third normal form. You can either go with transitive dependency condition or you can go with this third normal form condition. For every functional dependency, the left hand side should be a super key or the right hand side should be a prime attribute. So let's check whether the right hand side is a prime attribute here. The first dependency is again failing here. G is not a prime attribute. For this particular dependency, RHS is failing. What about the LHS? We said it is a super key. So CH is not a super key. So LHS is also failing. So it's like either or. Either LHS should be satisfied or RHS should be satisfied. Now let's get into the transitive dependency. Non-prime derives non-prime. CH are non-prime, G is non-prime. If we say non-prime derives non-prime, it means it holds transitive dependency. When there is transitive dependency, that particular relation is not in 3NF. Generally, just checking for transitive dependency, you can say it is not in 3NF. You have to check at least one dependency that falls under this condition. So, either check this way, it is not satisfying, or check this way, it is not satisfying. So, it is definitely not in 3NF. So, in 3NF is also marked wrong. Now, we have to check whether it is in 2NF. What about 2NF? There should not be any non-prime attribute that can be functionally determined by a proper subset of a candidate key. The LHS should not be a proper subset of candidate key. This is the other way we can put this statement. Now what is the proper subset of DB? We can say B is a proper subset of DB. Does B determine any non-prime attribute? Yes, B is determining H here. B is determining C here. So, non-prime attributes C and H are functionally determined by proper subset of candidate key. When they are determined by that, we can say 2NF is also ruled out here, similar to 3NF. DB determines C is fine or DB determines H is fine, but when it is B determines C or B determines H, it is not fine with second normal form. They say they should not, which means such a functional dependency should not be there. Now let's get into the partial dependency line. Prime attribute derives non-prime attribute. Let's take the prime attribute B. B is deriving C and B is deriving H. We have two dependencies here where prime are deriving non-prime. If this situation is occurring, it means there is partial dependency. It is not fully functionally dependent, and so 2NF is also failing here. So we can say 2NF is failing at this point. Option 2 is also ruled out. Now we can conclude that this particular relation is in first normal form but not in second normal form. Option number 1 will be the right answer. If you find these normal forms to be difficult, do not go with them. Always check with transitive dependency and partial dependency condition. Do remember, transitive dependency holds true means it is not in third normal form. If partial dependency is holding true, then it is not in second normal form. The statement in the question tells each field contains only atomic values, which says it is in first normal form. Next question. Consider the transactions T1, T2, T3 and the schedules S1, S2 given below. R is for read, W is for write. And what are the data items actually present here? It is X, Y and Z. So 3 data items, 2 operations, 3 transactions and 2 schedules are given. So what is a schedule? A schedule is a set of operations, we can say, that involves multiple transactions. A schedule is called conflict serializable if after swapping of non-conflicting operations, it can transform into a serial schedule. So they are asking which one of the following statements about the schedules is true. Whether S1 is conflict serializable, S2 is conflict serializable, both are conflict serializable or not. That is the question asked. So first we have to arrange the transactions of schedule S1 here. Whenever you have a mention of R1 and W1, it belongs to transaction T1. Whenever you have R2 and W2, it is referring to transaction 2. Whenever you have R3 and W3, it is referring to transaction 3. Actually, you have something called W1 of X here, but it is not mentioned in T1. So we have to infer that transaction 1 operations are given by the subscript 1. Transaction 2 operations are given by the subscript 2. Transaction 3 operations are given by the subscript 3. And whatever is inside the parenthesis is the data item. We are starting with R1 of X. What does R1 indicate? It belongs to transaction 1. What about the next operation? R3 of Y and R3 of X. So both these read operation belong to T3. So we have R3 of Y and R3 of X. What about the next set? R2 of Y and R2 of Z. So both these come under transaction 2. W3 of Y and W3 of Z. So both belong to transaction 3. Then we have R1 of Z. So we'll have R1 of Z in transaction 1. Then we have W1 of X and W1 of Z. So this is W1 of X and W1 of Z. So we have arranged all the operations in this order. This is how we should be starting with. Now how do you find whether a particular schedule is conflict serializable or not? We have to test it with some conditions, but basically we have to create a precedence graph for that. So how do we create a graph? We have to use nodes and edges. So what are the nodes here? Create a node labeled Ti for each participating transaction in the precedence graph. So what are the transactions that are involved here? T1, T2 and T3. We have to create node for them. So let's take this to be T1 node, T2 node and T3 node. So let's take the first case. For each case where Tj executes a read item on data item X, after Ti executes a write item on data item X. Here the write and read are occurring on the same data item is what we can infer from this capital X. Create an edge from Ti to Tj in the graph. So what is Ti associated with here? It is with the write operation, and they say Tj is read operation. Tj executes read after Ti executes write. So you have to first find write operation followed by some read operation. So here you have W of Y. Do you have R of Y somewhere? No. You have W of Z here. Is there any read operation on Z? Yes. So W3 of Z and R1 of Z are satisfying the condition that is present in 2. So here we will just use the data item Z. What is the TI operation here? We have to mention the write operation here. It is W3 of Z. What is the TJ operation? It is read. So this is going to be R1 of Z. So now we can take this to be T3 because it is mentioned as W3, and here we can take this as T1 because it is mentioned as R1. How should the edge be drawn? From Ti to Tj. What is Ti here? It is T3. So from T3 we are drawing an edge to T1. So T3 to T1 will be the first edge here. Now just check whether there are any writes followed by reads. No. So we'll go to the next condition here. For each case where Tj executes a write item, after Ti executes a read item. So first read should be there, then write should be there. So check after read of X, do you have any write of X in T2 or T3? No. Now let's get into R3 of Y. Are there any writes in the other two transactions? No. Now let's check R3 of X. Yes, we have a write operation in T1. So R3 of X and W1 of X is actually giving a read operation followed by write. R3 of X, then we have W1 of X. So from R3 what do you understand? It is belonging to transaction 3, and from W1 what do you understand? It is belonging to transaction 1. So again you have an edge from T3 to T1. If you want you can draw a second edge also. Now let's check the next read. R2 of Y, then W3 of Y is actually satisfying this third condition again. So here we can go for data item Y. Similarly we have R2 of Z satisfying W3 of Z again. So both the data items are involving the first read operation, namely R2 of Y and R2 of Z, followed by the write operation W3 of Y and W3 of Z. From here what can you infer? This belongs to T2 and this belongs to T3. So from where you should start the edge? From T2. So T2 to T3 will be the second edge. So T2 to T3. Now check whether there are any reads followed by write, this particular read and this particular write. So we can take Z data item. Here we have R2 of Z, which is a read operation, followed by the write operation in W1 of Z. Now what is the transaction number here? It is T2 and this is T1. Now how should the edge be drawn? From T2 to T1. So here we can draw it from T2 to T1. So read followed by write is done here. Now let's get into the final condition. For each case where Tj executes a write item, after Ti executes a write item, create an edge Ti to Tj. We have to check whether there is a write followed by a write. Here we have a write. Is it following any write operation on Y? No. Do we have write operation on Z? Yes. We have W3 of Z and W1 of Z. So for Z data item, we have the first write operation W3 of Z followed by the write operation W1 of Z. Now what is W3? It is T3. What is W1? It is T1. Again we are having T3 to T1. Actually here it is first time, here it is second time and here it is third time. So even if you want to mark it 3 times, well and good, you can mark it for 3 times. So are there any more writes after writes? No. Now let's go for the final statement. The schedule S is serializable if and only if the precedence graph has no cycles. So here we will start with T1. So from T1 you cannot go to T2 and T3. From T2 you can go to T3 and from T2 you can go to T1. What about T3? you can go to T1. Do you have any cycle formation here? No. When you conclude there are no cycles in the precedence graph, you can conclude that the schedule is conflict serializable. So from this we can conclude S1 is conflict serializable. So this is conflict serializable, we have found it. Now we have to start with S2. So start marking the operations R1 of X, R3 of Y, R2 of Y, R3 of X, R1 of Z, R2 of Z. Then we have W3 of Y, W1 of X, W2 of Z. Then we have W1 of Z. Now we have to check. We have to create node. So this is T1, this is T2 and this is T3. Is there any operation read after write? No. Then we have to check whether there is a write after read. Yes, there are many operations. The first write is on Y. So let's take the first data item Y. So this is read and this is write. So we have R2 of Y and here it is W3 of Y. Any other read followed by write? Yes, we have. So it is R1 of Z and we have W2 of Z. So this is read and this is write. This is with respect to Z. Then similarly we have R3 of X and W1 of X. This is on X data item. This is T2, this is T1 and this is T3. This is T3, this is T2 and this is T1. T2 to T3 there is an edge. T1 to T2 I have an edge. Then from T3 to T1 I have an edge. So without checking further, just check if there is a cycle. From T1 I am able to reach T2. From T2 I am able to reach T3. From T3 I am able to reach T1. There is a cycle which concludes S2 is not conflict serializable. Based on 3 sets of transactions, we found that S2 is not conflict serializable. From this, we can rule out 3, 4, 2 and go with option number 1. Option number 1, only S1 is conflict serializable will be the right answer. Even if you go for write and write, here you have T2 to T1. So again T2 to T1, you will be coming this way. This is for the write operation on Z. So W2 of Z to W1 of Z. And this is T2 to T1. There is again a cycle. From these 3 itself, we are able to find out there is definitely a cycle. So we are concluding S2 is not conflict serializable. So this is how we have to work with schedule related problems. Next question. Arrange the following phases of database design in the correct order. This is the diagram of main phases of database design. We have requirements collection and analysis. From there we get the data requirements. With the data requirements we go with the conceptual design. Here the conceptual schema is designed. This is a high level data model. From there we go with the logical design. This is called the data model mapping phase. The logical schema is done in the data model of a specific DBMS. From there we go with the physical design which gives the internal schema. So here requirement analysis is mapped to functional requirements and they undergo functional analysis. From there we get high level transaction specification which is directly connecting to physical design here. The logical design is connecting to application program design. From application program we are moving to transaction implementation which applies the internal schema and it goes to the application program. This is the overall flow. Anything above this point is DBMS independent. Anything below that point is DBMS specific we can say. So now they have given physical design here, conceptual design here, logical design here and requirement analysis here. Now they have asked you arrange the following phases in correct order. D, B, C, A. Option number 3 will be the right answer. With this we are completing Unit 4 solutions. Let's solve Unit 5 System, Software and Operating System questions. Which of the following statements are true about Process Control Block (PCB)? Each process is represented in the operating system by a process control block. You can also term it as task control block. I'll just show you the diagram from the reference book. So you have process state, process number, program counter, registers, memory limits and list of open files that are with respect to a single process. Now they are asking what are the true statements with regard to the PCB. So we will first see about few terms that are used in context of PCB, and based on that we will mark the answer. Every process will have a process state. The process can be new, the process can be ready to execute, the process can be already running, waiting, halted and so on. Similarly, there is a program counter. This indicates the address of the next instruction to be executed for this particular process. We have CPU registers. They include accumulators, index registers, stack pointers, general purpose registers and any condition code information. CPU scheduling information are also included here. It includes a process priority, pointers to scheduling queues and any other scheduling parameters. Similarly, we have memory management information. It includes the value of the base and limit registers, the page tables or the segment tables, depending on the memory system used by the OS. There is accounting information that includes the amount of CPU and real time used, time limits, account numbers, job or process numbers, and we have input output status information which includes the list of IO devices allocated to the process, a list of open files, etc. So all these things are present inside the process control block. Now we will check the statements. The PCB contains information about the process state such as whether it's running, waiting or terminated. This point makes it perfectly true. The PCB includes the program code and data segments of the process. We'll just hold this statement. We'll go to the next one. The PCB stores the process memory management information such as page tables and segment tables. This particular point states that C is true. The final statement. The PCB is used to track process scheduling information and CPU registers for process. So here we have something called CPU registers and CPU scheduling information. So pointers to scheduling queues and any other scheduling parameters will justify process scheduling information, and they have directly given CPU registers. So all this information will be maintained. So both the terms are true. D is also true. So now let me get into the B statement. It is completely restricted to what is happening within the process. So process control block is all about the process and not about the program for which the process is going to do all those things or the data. So neither the program code or the data segment is going to be involved here. Everything is about the process, the task that is being done. It is not about the code or the data that is involved in the process. We are not into some application to work with the code or the data. We are into the OS part. All it needs to maintain only these details. So in this aspect, we can mark B as wrong. Option number 3, ACD only will be the right answer. When you find B cannot be true, you can automatically rule out the other 3 options. Next question. Which of the following statements are true about privileged instructions? We'll just see where this particular scenario comes in operating system. There are dual modes of operation. One is called the user mode and the other is called the kernel mode. The dual mode provides us with the means for protecting the OS from errant users. Errant users means the users who do some error, or errant users from one another. Because of one user who makes an error, the other users should not be affected. So in order to protect the OS, there are actually 2 modes. This protection can be accomplished by designating some of the mission instructions that may cause harm as privileged instructions. So how is this being done? Whenever the operating system gains control of the system, it is in kernel mode. The hardware allows privileged instructions to be executed only in the kernel mode. So it is not available in the user mode. If an attempt is made to execute a privileged instruction in user mode, the hardware does not execute the instruction, but rather it treats it as illegal and traps it to the operating system. The instruction to switch to kernel mode is an example of privileged instruction. So when the control is getting switched to kernel mode, that particular instruction itself is a privileged instruction. Some other examples include IO control, timer management and interrupt management. When control is given to a user application, the mode is set to user mode. So when operating system takes control, it is in kernel mode. When that control is given to user application, the mode is set to user mode. We define all input-output instructions to be privileged instructions. Users cannot issue IO instructions directly. So how can they do that? They must do it through the operating system. So based on these details, we will try to mark the true statements. It can only be executed by the operating system kernel and not by user applications. Yes, A is perfectly true because only in the kernel mode you will be allowed to execute the privileged instructions. In that case, user applications cannot execute privileged instructions. Next statement. It is designed to perform operations that can directly affect the hardware or system state such as IO operations or changing memory management setting. This is also true. That's why that control is not given to the user mode. Instead, it is given in the kernel mode. Next statement. User applications can execute privileged instructions is wrong if they have to correct permissions set by the operating system. It is not allowed in the user mode. So that's why they have given a point. To prevent users from performing illegal input-output, they have defined all the input-output instructions to be privileged instructions. Moreover, users cannot issue those instructions directly. They must only do it through the OS. And also there is a point here telling that this kind of dual mode of operation is given just to protect the OS from users, those who are doing errors. So in that way, user applications cannot execute those instructions. So C is false. D. It usually executes in user mode to ensure the safety and security of the system. This is also totally wrong. When we say C is wrong, D can never be correct because they say the hardware will be allowing the privileged instruction to be executed only in kernel mode. If that is the case, then the statement that says it usually executes in user mode is totally wrong. Actually, the statement can be it usually executes in kernel mode to ensure the safety and security of the system. So user mode is wrong here. Only two statements are right. Option number 1, A and B only will be the right answer. Next question. Which of the following statements are true about mutual exclusion in concurrent programming? So concurrent programming is when multiple processes are going to work together. So we will take it in that angle. These are the statements about mutual exclusion. Since we have already seen many points in the previous year question papers, we will just work through these points in this video. First statement, mutual exclusion ensures that only one process can be in a critical section at any given time. This is perfectly true. Second statement, mutual exclusion are designed to prevent conflicts and ensure that only one process can access shared resources at a time. This is also true. So when they say the process is in a critical section, only that process can be accessing the shared resources, because when a resource is shared by multiple processes, one change or one update may not be reflected with another process. To avoid all those conflicts only, they are allowing only one process in the critical section. If A is true, then B is also true. What about C? Mutual exclusion can use various algorithms to ensure that processes do not enter the critical section simultaneously. This is also right. It's because they make sure only one process gets into the critical section at a particular time. If that statement, if A is going to be true, then definitely this point is also true. So there are only three options given in the answer. So from this we can mark option number 1, A, B and C only as the right answer. What is wrong with D? Mutual exclusion allows multiple processes to access the critical section simultaneously to improve performance. All the statements are getting contradicted when we use this statement. A is also talking about one process in critical section. B is talking about one process that is accessing the shared resource. C is talking about Not all processes enter it simultaneously. When we know A, B and C are true, obviously D cannot be true. So once you find that D is wrong, you can automatically rule out the other three options. Next question, match list 1 with list 2. Operating system concepts are given in list 1 and their characteristics are given in list 2. We'll pick up LRU. We know this is a page replacement algorithm, least recently used. So which one is perfectly matching? This evicts least recently used process. So B is mapping to 1. B1 is available in option number 2 alone. Just based on this, we can rule out the other three options. Next we will get into C-scan. We have scan, C-scan, look, C-look, FCFS and shortest seek time first. All these are disk scheduling algorithms. So based on that we can map C to 4, which is talking about circular disk access. So in scan and C-scan algorithm, it's about traversing from one end to the other end. So C is 4. What about paging and virtual memory? Whenever you get into the virtual memory concept, they will be saying it's about extending the capacity of the physical memory. Though you may find physical memory to be limited, with the concept of virtual memory, you are extending the physical memory capacity. So in that aspect, we can mark D to 2. So D is mapping to 2. Virtual memory extends physical memory. What about paging? In paging, there is a mapping between the logical address to the physical part of the memory. So A will be mapping to 3. Option number 2 will be the right answer. Next question, match list 1 with list 2. We are given algorithms in list 1 and characteristics in list 2. So we will start with list 2 here. First one, each process is assigned a priority. So which scheduling works as per priority? It is priority scheduling. D will be mapping to 1. D1 is available in 3 places. So we will rule out 4th one. What about the second statement? Ensures fair allocation of CPU time by assigning time slice. Whether it is time quantum, time slot or time slice, all these are the terms that is available in the round robin scheduling. So C will be mapping to 2. C2 is available only in option 3. So we can rule out the other 2. So in round robin, every process will be given a particular time slice for execution. If the time slice is over, they have to go and wait in the queue until they complete. They can execute only for a particular time quantum or time slice. This is the concept of round robin. What about the next statement? Processes are executed in the order they arrive. This is first come, first served. Whoever comes first, they will be served and they will be sent. So this is like executing the process in the order they have arrived. So A will be mapping to 3. A3. What about the last statement? Selects the process for execution with smallest next burst time. This is shortest job first. So whichever process is having smallest burst time, that process will be picked up for execution. So in that case, B will be mapping to 4. B4. Option number 3 will be the right answer. Next question. From here, the next 5 questions are going to be based on Banker's algorithm. Read the passage below and answer the questions. The Banker's algorithm is critical deadlock avoidance method in operating system designed to facilitate resource allocation without causing deadlock. When they say it's a critical deadlock avoidance method, it has to allocate resource without causing deadlock. So it is not about deadlock prevention, it is about deadlock avoidance. It operates by maintaining information about the maximum resources. Each process may require the current allocated resources and the available resources in the system. So far, these many resources are allocated and these many resources are remaining with the operating system. This is what each process will be requiring. The algorithm checks each resource request to determine if granting it would leave the system in a safe state, meaning that there is always a sequence in which all processes can complete their execution without getting stuck due to resource unavailability. This check is done by the algorithm. They make sure that whichever process needs some resources, they have to allocate it, provided even after allocating them, the system must be in a safe state. It means it should not enter into any deadlock. And also it has to make sure that all processes will complete their execution without getting stuck. Why are they going to get stuck? If resources are unavailable, some processes cannot complete their execution. So in that way, this algorithm should also take care of this particular aspect. Each process must specify its maximum demand for each resource type before it starts execution. How much ever it needs, the maximum demand must be specified by every process. When a process requests additional resources, the algorithm checks if granting the request will keep the system in a safe state. If so, the resources are allocated. Otherwise, the process must wait until its request can be safely fulfilled. So if it is available, it will be allocated. If not, the process has to wait till the request has been safely fulfilled. It means at any time the request gets fulfilled, the system has to be in a safe state. That is the meaning of safely fulfilled. Now let's start answering the questions. What information is used to determine if a resource request can be granted? So let's check all the 4 options. Available resources and current allocation of each process. CPU utilization of each process. Number of processes waiting for resources, arrival time of each process. Just by reading the option, we know 2 and 4 can never be the answer. We are not worried about the number of processes that are waiting for the resources. Each process may require the current allocated resources and the available resources in the system. So based on that only, the algorithm checks each resource request to determine if granting it would leave the system in a safe state. Which information is used to determine if a particular resource request can be granted? The number of available resources and the current allocation of those resources to process. Option number 1 will be the right answer. We can also rule out option number 3. Next question. What is the primary goal of the banker's algorithm? To allocate resources optimally, to prevent processes from requesting resources, to detect and recover from deadlocks, to maximize CPU utilization. We know 4 is definitely not there. What about detect and recover from deadlock? This is actually a deadlock avoidance method. It's not about detecting, or once if the deadlock is occurred, it is not about recovering. It is totally avoiding method. So every time it checks whether the system is going to be in a safe state. So keeping that in mind, we can rule out 3 also. So what is the primary goal now? Whether you are going to allocate resources optimally. What is optimally? We make sure that every process will get how many ever resource they want. At the same time, that should not put the system in unsafe state. It has nothing to do with preventing process. Even if the process is going to request when the resource is not available, this algorithm will make it wait. But never it will say don't ask and all. So in that aspect, we can even rule out option 2. Option number 1. To allocate resources optimally will be the right answer. This is the primary goal of the algorithm. This is designed to facilitate resource allocation without causing deadlock is what we can term as optimally. Next question. Which of the following is not a requirement for banker's algorithm to grant a resource request? So they are saying not a requirement. It means 3 of the options are requirements. The requested resources must be available. Yes, only if it is available, it can be granted. The system must be in a safe state after granting the request. This is also true. The request must not exceed the maximum resources the process can request. If you take, there are some 10 number of resources and the process is going to ask for 9, that is okay. But what about the process asking for 11? This can never be given. So that's what they say, the request must not exceed. So this is also right only. What about the 4th one? The process must be the only one requesting resources. This is actually wrong, because when they ask, it checks whether the system is in a safe state. If it is safe, the resource will be allocated. Otherwise, the process will be waiting for it. It never said only one process should be requesting, the other process should not. We can mark option 4 to be the right answer. Next question. What is the significance of the banker's algorithm in terms of resource management? Significance in the sense we can say what is the importance of. So first one, it ensures that all processes can finish their execution without deadlock. It's fine. It eliminates the need for processes to request resources. It does not eliminate that need. Actually, every process has the right to request for the resources in order to complete the task. So this is meaningless. It accelerates. It means it speeds up the execution of critical sections in process. No, it does not do anything regarding that. It minimizes the number of context switches between process. So this is also not relevant to the statement. So what is the significance here? It ensures that all processes can finish their execution without deadlock. So designed to facilitate resource allocation without causing deadlock. This statement is supporting the first option. Option number 1 will be the right answer. Next question. Which data structure does the banker's algorithm use to maintain the state of available, maximum resources and allocated resources? Priority queue, hash table, wait for graph and matrices and vectors. So we have a list of available resources, the maximum resources, the allocation part and the needed part. N is the number of processes and M is the number of resource type. So let's take available. This is a vector of length M. Vector in the sense you can just imagine it to be a one-dimensional array. A vector of length M, it means of size M, indicates the number of available resources of each type. So if you take A of 0, A of 1, it means this is equal to 5, then this type of resource is 5 in number, this type of resource is 10 in number. It's just giving you the number of available resources of each type. Every type is what the index we can take. So vector is similar to single dimensional array. So vector is a data structure that is used to maintain the available resources of each type. What about max? An n cross m matrix defines the maximum demand of each process. So n is the process demanding m the number of resource type. So if 1, 2, 3, this is going to be n and this is going to be m, 1, 2, 3. 1 may need all the 3, 3 may need only 2 and 3, this 2 may need only 1 and 2. So this is defined in the form of a matrix. So the maximum demand for each process, that is given by n cross m, is given here. So here we are using matrix data structure. This is also done. What about allocation? Again, this is n cross m matrix that defines the number of resources of each type currently allocated to each process. So this is about the maximum demand and this is about what is currently allocated. So this will also be in the form of n cross m matrix. What about the need? This is also a matrix indicating the remaining resource need of each process. So this is the remaining resource need that every process will need for its execution. Again, here also we have it in matrix form because n processes can have remaining need of m resources. In that aspect, this is also a matrix data structure. So what are the two data structures involved to maintain the state of available, maximum and allocated resources? So the first three are asked in the question. We are using matrix for maximum and allocation and we are using vector for available. Option number 4, matrices and vectors will be the right answer. So make sure you know which data structure is used where. So V is vector and M is matrix. So there is no use of having priority queue because here you have to maintain what processes need what resources. There are two dimensions or two parameters involved. So if the parameter is going to be single or if the dimension is going to be only the particular resource, their vector can be used. When the dimensions are going to be in the context of processes needing certain resources, there are two dimensions. So one is n and other one is m. So in that aspect, priority queue may not work, hash table may not work, and wait for graph may be useful in deadlock detection, but it is not going to help in banker's algorithm. This is also not going to be useful in maintaining the state of resources. So in that aspect, we can rule out 1, 2 and 3 and mark 4 as the answer. Except for this question, the other 4 questions can be answered using the paragraph. But for this question, even if you don't have any idea, you have to think about 2 things. Every process will need a resource. When you have 2 dimensions here, you should automatically think this as a 2D array. When you put 2D array into a particular data structure form, it becomes a matrix. When you consider only the number of resources, that can be taken as a 1-dimensional array where only the size of the array is enough. So in that case, we go with vector. So even if you don't have idea about the data structures, just think it in dimension form and try to take them. With this, we are completing Unit 5 solutions. Let's solve Unit 6 Software Engineering questions. In Software Configuration Management, what is the primary purpose of version control? What is actually version control? This combines procedures and tools to manage different versions of configuration objects that are created during the software process. Configuration management allows the user to specify alternate configurations of the software system through the selection of appropriate versions. Say for example, if I have some 3 versions of code and I want to revert back to some other old version, this version control will help me to move to whichever version I want. So that is the purpose of version control. We'll just go through the options. To control the changes made to software, to document user requirements, to estimate project cost and to design the software architecture. This has nothing to do with 3 and 4. And it is nothing about user requirements also. So it is to control the changes made to software. You can just apply this to code versioning itself. So you will have a set of code as version 1. Then you might have made some changes that becomes version 2. And you could have introduced some other features. So that would be version 3. So every time when you introduce some changes or when you make some other updates, that becomes a new version. I am telling you in the aspect of code alone. So if that code, if it has so many different versions, you have to just take code and replace any object that has been created during the software process. So that's why they have mentioned it as configuration objects. So to control the changes made to the software will be the primary purpose of version control. Option number 1 will be the right answer. Next question. If a software project has 2000 lines of code LOC, and the average productivity rate is 10 LOC per person hour, how many person hours are required to complete the project? So we will first understand what is actually this person hour. The work or the effort is actually mentioned in person hours unit. These many persons are required to work for these many hours in order to complete this particular task. The development effort in terms of person hours will be equal to size of the code divided by average productivity rate. That is, the LOC part is given in the numerator and the LOC per person hour is given in the denominator. The LOC is given as 2000 lines of code. So this is 2000 LOC divided by the average productivity rate is 10 LOC per person hour. So we can cancel 0 and 0 here. This is 200 and this LOC will get cancelled and this person hour will come to the numerator. So it takes 200 person hours to complete the project. Option number 3, 200 will be the right answer. This is going to be just 2000 divided by 10, but I am just explaining you with the units so that to tell you how person hours come for this particular question. Next question. Given a project that uses the COCOMO model with an estimated effort of 2000 person months and a productivity rate of 5 person month per KLOC. What is the estimated size of the project in KLOC? Now let's understand what is this person month. It is considered to be an appropriate unit for measuring effort because developers are typically assigned to a project for a certain number of months. So one person working for these many months or the number of persons working together for these many months. Now we have to find the estimated size of the project. This will be given by the estimated effort that has been given here divided by the productivity rate that is given here. Now we will just substitute the values. What is the estimated effort? It is 2000 person months divided by what is the productivity rate? It is 5 person months per KLOC. So you can cancel these two units. This KLOC will go to the numerator. This is 5 fours are, so totally you will have 400. 400 KLOC will be the right answer. Option number 2 will be the right answer. This is the estimated size of the project in KLOC. Next question. Given a project with an estimated effort of 1500 person hours and a team of 5 people, how many days will it take to complete the project if each person works 8 hours a day? Total work hours per day has to be found out first. Actually, if one person works for 8 hours, how many hours do 5 persons work? It is actually 5 into 8. Team size 5 into work hours of each person a day is 8 hours per day. So every day they have to work for 40 hours. Total work hours per day is equal to 40. Now they have asked the number of days to complete the project. Estimated effort of person hours divided by total work hours per day will give you the answer. What is the estimated effort? It is 1500. So 1500 person hours divided by what is the total work hours? Here it is 40 hours. So we can say person and hours together. So this is in terms of people and this is in terms of hours. So this can be taken as person hours per day. So here this two get cancelled. We will have 150 divided by 4. 4 threes are 12. We have 30. 4 sevens are 28. Then we have 2. We'll introduce a decimal point here. This is 4 fives are 20. We can have 37.5 days to complete the project. So this day will go to the numerator. So this is how we are bringing it to days unit here. 37.5 is available in option number 2. Option number 2 will be the right answer. Next question. Arrange the following phases of the agile process in the correct sequence. So what is actually agile software engineering? This represents a reasonable alternative to conventional software engineering for certain classes of software and certain types of software projects. Before agile process came into software engineering, we were using something called the waterfall model. So we have to go with requirement analysis, then we'll go for design phase, then we'll go for coding phase, then deployment, then maintenance. There will be a set of phases that will be followed in a particular order. But after this agile process came inside, based on the type of project or based on the type of software you are going to create, some changes were introduced in the life cycle of the software. They are asking for the general phases of the agile process. So it is not going to be too different from the traditional one. Any process will be starting with planning only. There are only two options starting with planning. So we will rule out the other two. It starts with E. After planning, definitely we will go for design. EA. After design, we will go for development. It is D. From this itself, we can rule out option number 4. After developing something, you need to test them. So once you test them, automatically you go for release of the particular product. So this will be the final step. EADCB. Option number 3 will be the right answer. Whether it is agile process or something, you know, a software development process will undergo all these phases. Generally, you have to know which phase will come first and which phase will come next. Even if you have that basic idea, you will be able to answer this question. Next question. Arrange the following steps of feature drive development process in the correct sequence. So they have given 5 options. I'll just give you the process in the sequence. So we are developing an overall model. This is A. The next step is to build a features list. So we have to build a list first, and only from that particular list we are going to plan by feature. So next step comes plan by feature, which is C. After planning, we are going to design by feature, that is going to be D. The next step is to build by feature, which is B. A, E, C, D, B. Option number 2 will be the right answer. So generally we have to develop an overall model first. After that we have to give a list of features. From that feature we have to pick one, plan for it, design it and then build it. So only with the help of features list you will be able to go with a particular feature. If you at least find these two phases correctly, you can answer this question. Next question. Which of the following are typical activities in the software process life cycle? So in software process life cycle, we have requirement analysis, then we have design, then we have development, then we have testing, then we have deployment, then maintenance. Now we have to pick only the activities that belong to software process cycle. Does every software process life cycle have requirement analysis? Yes. What about system design? Yes, design is also a part. What about code refactoring? It is not. What about deployment? Yes, it is there. And what about substructure? It is not there. So the typical activities will usually go for requirement analysis, then you go for design, then you go for development, testing, and then we go for deployment and maintenance. So we don't have code refactoring and substructure in this sequence. Option number 3, A, B and D only will be the right answer. Now we'll just see what are code factoring and substructure. Code factoring is the process of restructuring existing source code without changing its external behavior. The behavior of the code should not change, but you can make changes to the code. What about substructure? This is a view containing a selection of elements, thus providing the potential for simplified modeling within large models. So if you take this to be a view and some elements involved it, this is going to be a substructure. I'm just giving you a plain idea about what is substructure. Next question. Which of the following are agile process models? So we know waterfall is actually existing from long time, and we know spiral is also existing before agile. Similarly, incremental model is also existing from before. If you have idea about this, you can easily narrow this list to A, extreme programming, and C, Scrum. So I'll give you a list of process models under agile software engineering. We have extreme programming, we have adaptive software development, we have Scrum, we have dynamic systems development method, we have Crystal, we have feature drive development, lean software development, agile modeling and agile unified process. Now why have I actually highlighted few models is these models are available in latest editions. The rest of the models belong to some old editions. So the option that involves A and C will be option number 1. Option number 1 will be the right answer. So let's have a look about XP and Scrum now. Extreme programming's process cycle will be like this: planning, design, coding and testing. In coding we have something called refactoring, and if you take planning, it is done through user stories. Then design is done through CRC cards, and coding involves pair programming. Testing involves unit and acceptance testing. Then there comes the release after testing. So it's just a software increment, not the complete product. So every time it just goes on iterating and then giving an increment of the particular product. So this is extreme programming. What about Scrum? So they will be having a particular set of activities to be completed within a specific time. If you don't complete them, that will be taken to the next set of activities. Just for example, I am telling you, take week 1, you have to complete 10 activities. Week 2, you have to complete 7 activities. In case if you have 2 pending here, this 2 will be brought to this week. So it makes totally 9 activities that has to be completed. Similar process only will be happening. I am not explaining the exact technical scenario of Scrum. I am just telling you how this particular process model works. Next question. Match list 1 with list 2. Software design principles are given in list 1 and definitions are given in list 2. We have cohesion, coupling, abstraction and modularity in list 1. What are cohesion and coupling? Cohesion is an indication of relative functional strength of a module. Within a module, how far they are relatedly strong. What is coupling? It's an indication of the relative interdependence among modules. So when there are 2 or 3 modules, how they are interdependent on each other. So this is within a module and this is between modules. Now just find the appropriate definition. Degree to which one module relies on another module. So here 2 modules are involved. So we can map this to coupling. B to 1. It is available only in one option. What about cohesion then? Degree to which elements of a module belong together. It is just based on a single module. So we can map A to 3. A3 and B1. So other options can be ruled out. Option number 3 will be the right answer. Now let's check for abstraction and modularity. Dividing a software system into distinct modules is what we call as modularity. So they will say working with different modules. So we can map D to 2. D2 is here. What about abstraction? It is simplifying complex reality by modeling classes appropriate to the problem. Abstraction is giving something in general. It is not specific, we can say. It is more about the generalization. Instead of going into deep, we are just giving a generalized idea of something. So this is what they have meant as simplifying complex reality by modeling classes appropriate to the problem. It is not specific to the problem, but that is just appropriate to the problem. A generalization kind of view, we can say. There are many levels of abstraction in software engineering. We are not getting into that topic. So we can map C to 4. C4 is also there. Next question. Match list 1 with list 2. List 1 has the testing types and list 2 has descriptions. We have unit testing, integration testing, system testing and acceptance testing. Unit testing focuses on each component individually, ensuring that it functions properly as a unit. So here testing individual components of the software exactly matches the statement here. So A will be mapping to 1. It is directly given. A1 is available in all the options. What about integration testing? This addresses the issues associated with the dual problems of verification and program construction. So here testing the interaction between integrated components. So testing something individually is unit testing. When you test integrated components, it becomes integration testing. The meaning is actually directly given. So B is mapping to 2. A1, B2 is available in 2 of the options. The rest 2 can be ruled out. What about system testing? It verifies that all the elements mesh properly and overall system function or performance is achieved. What about acceptance testing? It is conducted by the customer in an effort to exercise all required features and functions. So here, what is system testing? Testing the complete system to ensure it meets requirements. So whether it is able to function correctly, whether the performance is perfect, everything can be tested in system testing. We can map C to 4. 1 is also ruled out. What about acceptance testing? It is done by the customer. What does actually customer test? The customer will test whether it is meeting all the business needs. So in that aspect, D will be mapping to 3. Option number 2 will be the right answer. With this, we are completing Unit 6 solutions. Let's solve Unit 7 Data Structures and Algorithms questions, which is a self-balancing binary search tree where the path from the root to the furthest leaf is no more than twice as long as the path from the root to nearest leaf. Just by looking at the option and the syllabus, you can find the answer is going to be red-black tree. So there are 2 parameters here, root to the nearest leaf and root to the furthest leaf. And they say the path is no more than twice. So it is less than or equal to 2 times of the path from the root to the nearest leaf. Self-balancing binary search trees always maintain height to a minimum. The balance factor is given by the difference of left subtree height and the right subtree height. Such trees perform rotations after execution of an insert or delete operation. So after we insert an element or delete an element, rotations will be performed in order to maintain that particular balance factor. The examples of self-balancing binary search trees are listed here. We have 2-3 tree, red-black tree, AA tree, avian tree, B tree, scapegoat tree, splay tree, tango tree, treep tree and weight balance trees. Some are taken from reference books, some are taken from web source. So I would like to concentrate on few trees here. The red-black tree is what we can say the path from the root to the farthest leaf is no more than twice as long as the path from the root to the nearest leaf. So this statement is exactly belonging to red-black tree. So we can mark option 3 as the right answer. AA trees are left-leaning red-black trees after a symmetric reformulation. It means they work with different rebalancing algorithm. This is about the AA tree, and we know about AVL tree. The height of the left and right subtrees of any node will differ by 1 at most, so not more than that. And for scapegoat trees, the rebalance occurs whenever the size of a child exceeds a certain ratio of its parents. This ratio is known as alpha. Next question. Arrange the following steps in the correct order to solve the knapsack problem using dynamic programming. So we have already seen about knapsack problem in one of the previous year question paper. We have two kinds of knapsack problem. So one is called the fractional knapsack problem and the other one is the 0-1 knapsack problem. So in fractional knapsack we will be able to add a fraction of the item, but in 0-1 knapsack we either include the item or exclude the item. So this 0-1 knapsack problem is actually solved using dynamic programming technique. So the dynamic programming solution is required for 0-1 knapsack problem. The fractional knapsack problem is solved using the greedy approach. Now they are asking the correct order to solve this problem in dynamic programming. So let's look at the options first. Define the base case where the capacity is 0 or no items are left to consider. Compute the maximum value that can be obtained using items up to the ith item and a knapsack capacity of 0. Identify subproblems and their dependencies based on item weights and values. Initialize a table to store results of subproblems. Iterate through each item and each possible capacity to fill the table. So from C, D and E you can understand one thing. Only after identifying the subproblems you will be able to store the results of subproblems. So definitely after C we will have D, and they have told iterate through each item and each possible capacity to fill the table. Which table are they talking about? They are talking about the table that is being initialized in option D. So definitely E will be following D. In this case, just find the options which have the order of C, D and E. Only one option is having this order of C, D, E. Now we have to check between A and B. Define the base case where the capacity is 0. Initially the capacity will be 0. So the initial condition is what we have to start with. So we will be starting with A. Compute the maximum value that can be obtained using items up to the ith item and a knapsack capacity of 0. When will we compute the maximum value? We will compute it after adding the items to the knapsack. So this particular line can be taken as the final step. Now just arrange in this order. Define the base case when the capacity is 0. Identify subproblems based on item weights and values. Now we are solving the subproblem and we are storing it in a table. We are iterating through each item and each possible capacity to fill the table. So once you fill the table and you find these are the items that are going to be accommodated in the knapsack, we are computing the maximum value that can be obtained using items up to the ith item. What is this? A knapsack capacity of 0 is, imagine if the maximum capacity of the knapsack is going to be 20. Once you keep adding items, say for example you are adding 5, then 20 minus 5 the capacity will be 15. Then you are adding something to 10. 15 minus 10 will be 5. Then you are adding something with 5. 5 minus 5 will give you 0. So until this capacity becomes 0, you will be computing it again and again. So this is what they say, compute the maximum value that can be obtained using items up to some ith item and the knapsack capacity should be 0. It means till that item you can accommodate, after that you cannot. So from where do you pick those items? Actually from this particular table. Where is the table initialized? It is initialized in D. For what it is initialized? It is initialized to store the results of the subproblems. Where are we identifying the subproblems? In C. This way also you can find the answer. Option number 3, A, C, D, E, B will be the right answer. Next question. Arrange the following recurrence relations in increasing order of their time capacity. So the relation is given. We have to compute the complexity. Only then we will be able to arrange it in ascending order. To solve this problem, we are taking the help of Master's theorem. F of n is given in this form, and based on that they have given some time complexities. N is equal to B par K, where K is a positive integer, A is greater than or equal to 1, B is an integer greater than 1, and C and D are real numbers, with C positive and D non-negative. So this is C into n power D they have given, and all these are in the form of n power only. So 1 can be taken as n power 0, which is equal to 1. Then this is n power 1, which is equal to n. Similarly, root of n can be taken as n power 1 by 2. So everything is in this form only. Based on this, we are going to take the time complexity. Let's start with A. We have T of n is equal to T of n by 2 plus 1. This is in the form of n by b. So from this we can take the value of A to be 1, B to be 2. It is n by b. So we are comparing it with A of T into n by b. So we are just considering this to be A value and this to be B value. So based on that we are taking A is equal to 1, B is equal to 2. Here the function is given as 1. 1 means we know n power 0 is equal to 1. So what is this n power D? So here D is equal to 0. Now we have to check B power D and A. So A is equal to 1. What is B power D? It is 2 power 0, which is equal to 1. So A is equal to B power D. We are going with the second condition. What is the complexity? It is big O of n power D log n. So now we know the value of D is 0. What is n power 0? It is 1. So 1 into log n will give you big O of log n. So n power D will be n power 0, which is equal to 1. A option is giving big O of log n. What about B? We have T of n is equal to 2t n by 2 plus n. Here we know A is equal to 2. We have to take it from here. B is equal to 2 again. We have n power 1 here. N power 1 is equal to n. So from this we can compute D is equal to 1. What about B power D? We have 2 power 1, which is equal to 2. Again we have A is equal to B power D. So here we have to go with big O of n power D's value is 1, then log n. This will give you big O of n log n. So we can go with big O of n log n. What about C? T of n is equal to 3t n by 3 plus n. Here we have A is equal to 3, B is equal to 3, then n power 1 is equal to n, so D is equal to 1. So again B power D is equal to 3 power 1, which is equal to 3. A is equal to B power D. Here also we are ending with big O of n log n. So this is big O of n log n. So B can be followed by C and C can be followed by B. Regarding D, it is 2t n by 2 plus square root can be written as n to the power of 1 by 2. So A is equal to 2, B is equal to 2. And here we know D is equal to 1 by 2. It is actually 0.5 we can say. So definitely we know A is greater than 2 power 1 by 2. So root 2 will give a value that is less than 2. So this time we are going with A greater than B power D. So here it is big O of n log A to the base B. So what is log A here? Log 2 to the base 2. We know log 2 to the base 2 will be equal to 1. So this is big O of n power 1, which is equal to big O of n. So this is big O of n. What about E? T of n is equal to T of n minus 1 plus 1. So this is not in the form of Master's theorem. We have to take it in other way. Now how will you find T of n minus 1? T of n minus 1 can be taken as T of n minus 2 plus 1. Now we will substitute this t of n minus 1 here. So we have t of n minus 2 plus 1 and this plus 1 will be following here. So instead of n minus 1, I am just substituting the previous term. Similarly, what about t of n minus 2? We will have t of n minus 3 plus 1. So we will go with t of n minus 3 plus 1 for t of n minus 2. Then this plus 1 is from here and this plus 1 is from here. This is how we will be taking, and ultimately you will come to a place where t of 2 is equal to t of 1 plus 1 and t of 1 is equal to t of 0 plus 1. You are going for n number of terms. So in this case we can take this as big O of n. So you are not multiplying anything, you are just working with n number of terms. You can simply say t of n can be obtained by t of 1 plus n minus 1 terms. So here t of 1 we know the value is 1. So this is 1 plus n minus 1. You can just cancel them and then get n here. I am plainly taking it as n minus 1 terms. And we are bringing this to t of n is equal to n here. So this is just a working that they have given in order to justify how it is big O of n. We know b and c will be occurring together and d and e will be occurring together. What is the order of complexity actually? Log n will be less than n and it will be less than n log n. This is the actual order. So what is log n here? It is a. So we will have a first. What about n? We have d and e. So it can either be d or e. What about the n log n part? It is either b or c. So anything that ends in bc can be considered. We will rule out the other two. It should start with a. So the only option that ends with BC and starts with A is option 2. We go with option 2 as the right answer. So we have the order of E and D here. Now how are we arranging the order of ED and BC? A small explanation to that. We have seen one recurrence relation in this format. So whenever you have f of n is equal to big O of g of n, this will be like less than or equal to c into g of n. You will bring it to a form of constant into a particular function. Hope you remember this part. This c, when it is computed for b, the c value will be c into n by 2 plus n into log n by log 2. When you compute it for c, this will be c into n by 3 plus n into log n by log 3. When you divide a problem into 2 and you divide a problem into 3, based on this part, we are concluding that b is less than c. Similarly, when you take d, c into n by 2 plus root 2 into root 2 minus n divided by root 2 minus 2, and for E, C plus n. So from this we can say C plus n is less than, that is E is less than D. So how they have interpreted E is, when you want to take T of 1, it is T of 0 plus 1. This part is actually equated to a constant plus 1. If you take T of 2, it is actually T of 1 plus 1. So here it is C plus 1 plus 1, which is equal to C plus 2. So if you take T of 3, it will be C plus 3. If you take T of n, it will be C plus n. So this is how they are bringing E to the format of C plus n here. Next question. Select the sorting algorithms that are stable. What is a stable sorting algorithm? There will be a set of elements. If two elements are equal, their order will be preserved in the sorted output as it was in the input. What are the stable algorithms here? We have bubble sort, insertion sort, merge sort and counting sort. From this we will be able to mark B, insertion C and merge D. So B, C, D will be the right answer. Since no option is providing this answer, they have dropped this question in the official answer key. B and C can be right. But along with that, we also have merge sort as the answer. So that's why the question is dropped. What are the unstable algorithms? Quick sort, heap sort and shell sort can be treated as unstable algorithms. In quicksort, what do is we actually split the array into two parts. One array will be greater than a particular pivot element and the other array will be lesser than the pivot element. Usually the leftmost element will be considered as the pivot element. The two sub-arrays are sorted by recursive calls to quicksort. In merge sort, the selection splits a list into two lists. Merging joins two files to make one file. In quicksort, it starts with the largest subfile and finishes with the small ones, and as a result, it needs a stack. This algorithm is not stable is what they try to say. When you take merge sort explanation, it starts with the small subfiles and finishes with the large one. So it does not need any stack. This algorithm is stable. Next question. Match list 1 with list 2. List 1 has recurrence relations and list 2 has complexity. B, A, D are from the question that is already solved. So let's take the difference between big O and theta now. Big O only gives an upper bound, which means it can describe the worst case. What about theta? It gives both an upper and lower bound, making it a tight bound. That is what we call as average case. Now let's take the Master's theorem that we saw previously, and along with that we have a Master's theorem. Here you can find the upper bound, lower bound and the average case. Now I am equating this f of n value based on this particular theorem. So f of n is equal to big O of g of n when a is less than or equal to b. When a is greater than or equal to b, we can mark it with omega. When a is equal to b, we can take it to be theta. So this is how I am mapping f of n's time complexity along with this particular Master's theorem based on the condition a greater than b or a less than b or a equal to b. Now let's take the first option. T of n is equal to 2t n by 2 plus n is actually n log n. We have found this already in the previous problem. This n log n can be taken as omega of n log n or theta of n log n with respect to this particular relation they have given floor of. So this particular recurrence relation can be equated to any of the complexity. So we are mapping A to 1 directly. A1 is available in two options, so we are ruling out 2 and 4. What about B? T of n by 2 is given in seal notation. It means it can be taken to a higher level. Since seal is provided here, they have equated it to theta of n as exact solution. So B will be mapping to 3 here. Actually B's value will be big O of log n because you have T of n by 2. There is no doubt in that. But how they are equating it to option 3 in list 2 is what I am trying to tell you. So this is given in seal form and this is given in floor form. You need to note that. Floor of some value will give the small value here and seal of some value will give the large value here. So based on that they have done the working there. What about C? We have 2 into t n by 2 plus 1. From this we can take a is equal to 2, b is equal to 2, then n power 0 is equal to 1. So d is equal to 0. So 2 power 0 is 1. From this we can conclude a is greater than b power d. This part is coming. We have a greater than or equal to b. So we are using here omega symbol. It is big O of n log a is 2, b is 2. So log 2 to the base 2 will give you 1. This will be equal to big O of n power 1, which is equal to big O of n. So C is directly mapping to big O of n, which is in option 4 in list 2. So C4 is here and this is B3. So 3 of the options are matching. We can even rule out 1. What about D? Actually we know T of n is equal to T of n minus 1 plus 1 will give a complexity of big O of n only. But how are they mapping it to 2 here? Actually the question expression is wrong here. The actual recurrence relation should be T of n is equal to T of n minus 1 plus n. So instead of 1 it should be n. If that is the case, we can map D to 2 clearly. T of n minus 1 plus n will give a value of big O of n square. If you take T of n is equal to T of n minus 1 plus 1, this is definitely big O of n. But since it is plus n, it is big O of n square. Actually, it's a printing mistake, but the answer is right. So, except for D, if you take, the options are right with A1, B3 and C4. So, they have not dropped this question. Option number 3 will be the right answer. So, since we have already worked out A and B, I just took the answer as it is. C was new to this particular question. So, I worked it out again using this particular f of n. Next question, match list 1 with list 2. So, let's start with the list 2. Find the shortest path between all pairs of vertices in a graph with positive or negative edge weights. We know Floyd-Warshall algorithm is known as all pair shortest path algorithm. Keeping this as the clue, we can map B to 1. B1 is available in 2 options, so we can rule 3 and 4. What about the second one? Find the shortest path in a weighted graph with non-negative edge weights. This is purely for Dijkstra's algorithm. It works with positive edge weights. So we can map A to 2. So A to B1 is available in both the options. What about strongest connected component? If we can reach every vertex of a component from every other vertex in that component, then it is called a strongly connected component, where you can equate this. One vertex is there as a source. It can be connected to any other vertex. So this is actually bringing in the Bellman-Ford algorithm concept. Single source shortest path algorithm. So from a particular source, you can measure the shortest path to any other vertex is what they say. So in that way, C will be mapping to 4. But I am not mapping it as of now. Let's get on to the Prim's algorithm. Prim's algorithm starts with a single node and explores all the adjacent nodes with all the connecting edges at every step. Just look at the statement here. Sorts elements by repeatedly moving them post neighboring elements that are smaller. Though the statement is not directly reflecting, it is almost taking up the same meaning. So here we can map D to 3. Prim's algorithm will be taking the explanation in 3 here. So D3 is available here. So we can also rule out option 1. Now there are arguments stating that strongest connected components is an application of depth first search algorithm and not Bellman-Ford algorithm. Yes, it is true. Depth first search has 2 applications. One is topological sorting of a directed acyclic graph and decomposing a directed graph into its strongly connected components. So this is where we use DFS. When you take topological sorting, it is actually connected to Bellman-Ford algorithm. We can use topological sort on directed acyclic graph. This is what we are inferring from here. There is a variation of Bellman-Ford algorithm that can be applied to directed acyclic graph. The vertices are first topologically sorted and then the edges are relaxed in the order of the topologically sorted vertices. This is the mechanism that is happening within directed acyclic graphs when you use a variation of Bellman-Ford algorithm. So just go with the reverse connect. You have DAG here. In DAG, you go for topological sorting. Using DAG, we are having an application of Bellman-Ford algorithm, and this DAG is an application of DFS for what? For topological sorting of DAG as well as decomposing a directed graph into strongly connected components. So somewhere this is depending on strongly connected components, and that's why they are trying to map C to 4 as C's answer. Either they could have thought only one option is wrong, the other 3 are right, they might have not dropped this answer. This is one case. Or using the connect between these 2 information, they could have concluded Bellman-Ford algorithm will be able to determine the strongest connected components in a directed graph based on topological sorting. That is an application of DFS. Overall, we go with option number 2 as the right answer. With this discussion, we are completing Unit 7 solutions. Let's solve Unit 8 Theory of Computation and Compilers questions. Consider the grammar. If I0 is equal to closure of S derives A with a dot operation, then how many items be in the set for goto? This question is taken from Syntax Analysis chapter, LR parser topic. So here we have something called closure and goto. So let's first understand what they are. For any set of items I, closure is formed in the following way. Initially, closure is equal to I if A is equal to alpha dot B beta is in closure of I and B derives gamma is a production. Then add B dot gamma to the closure and repeat. This is just a dot that is getting applied when parsing occurs. This is to say when there is a non-terminal and a dot occurs before the non-terminal, you have to take the non-terminal into consideration. So basically they will find the augmented grammar for this grammar. Augmented grammar is nothing but we'll just start with S dash derives S. And from S we will just go on. If we have S dash derived S, they will start with the dot operation here. It means you have to pass this particular S. Then this dot will be transferred to A. So for every non-terminal that gets a dot, that particular non-terminal's derivation should also have that dot operation applied there. So let's take I0 is equal to S derives dot A. This is what they have given here. When they have specified it as dot A, what does it include? What is in A? We have $B as one derivation for A and the other derivation is A derives ID. So this dot will be applied to both this production as well as this production. It will be applied to this dollar as well as to this ID. So whenever a dot is placed in front of a non-terminal, the production of that particular non-terminal will have the dot operation applied. So this is the process how LR parsing takes place. Goto is nothing but we are performing a move. It means the parser will have two kinds of moves here. Either it can go to $B from A or it can go to ID from A. They are asking go to of dollar move. It means what happens when it moves this way. This is the question that is asked. If I is an item set and X is a grammar symbol, go to of I comma X is the closure of the set of items A derives alpha X dot beta, where A derives alpha dot X beta is in I. It means when I has A derives alpha dot X beta, what happens when you find go to of I comma X? This becomes A derives alpha. This dot will be shifting to the next symbol. So this will become X dot beta. So this is how we have to perform goto operation. Now they have told the goto operation has to be performed on this particular dollar symbol. Since they performed on X, the dot before the X moved to dot after the X. Here they have given goto is this particular production. So this is the value of I they have mentioned. Now we have to find the dollar part in goto. So where is the dollar here? It is here. In A it is present. Now we have to apply the dot. We will take the A production. We will just move the dot to the right side. So this will become $B dollar. So basically we had A derives $B dollar. Now since we use go to of this particular dollar symbol from I naught, what we do is we are just moving it to the right side. This makes it as A derives $B dollar. Just a movement of the dot operation. And what is the rule of the closure? Whenever the dot operation occurs to the non-terminal, the non-terminal's production should be added to the list. Basically, they gave only this particular production with the dot operation. Once we found that A is a non-terminal, what did we do? we included the production of A to this list. Similarly, the dot is now present in B. So what we should do is we should include the production of B. What is the production of B? The first production of B is B, comma A. The second production of B is A. We are just splitting it into two productions for easy applicability. The first statement will be B derives B, comma A, and we are placing the dot in front of B here. The next will be B derives dot A. So both these productions are applied. We have something called dot A here. A is again a non-terminal, which means we have to add $B and ID to the list again because a dot is placed in front of the non-terminal. So we are adding $B after the dot and we are adding ID here. Now the question is, how many items be in the set for goto? When we perform goto of I0, comma $, we end up with 5 items here. So this is the count of items they are asking here. It is 1, 2, 3, 4 and 5. Option number 3, 5 will be the right answer. Basically, we had only dot A. That's why we are bringing in the productions of A to this list. After bringing the production only, we are able to make this particular go to I0, comma $, move. When we apply this to the $, we are just moving it to the right of the dollar symbol. Since capital B is also a non-terminal, we are bringing in the productions of B first. When we place the dot before A, we are bringing the A productions next. This is why the order is like that. So initially we are applying it here. This part is converting to this first production here. For this part only we are applying the productions of B. For this part only we are applying the productions of A. Next question. Consider the grammar. Here X, Y, Z are terminals and capital T, capital Q, capital R, capital S are non-terminals. What will be the follow set of the non-terminal R? This question is from the topic syntax analysis again, but this time it is from top-down parsing in general. You have something called first set and follow set here. We'll just see what are they. First and follow allows us to choose which production to apply based on the next input symbol. First is a function that gives the set of terminals that begin the strings derived from the production rule. So when you have a production rule, you have to give the first set of terminals that come in the production. Follow of non-terminal is defined as the collection of terminal symbols that occur directly to the right of A. Right side means if there is a symbol A here, this will be the right side. This is called the right of A. Now we will try to find the first and follow of all the non-terminals. From that we will pick up the answer for follow set of non-terminal R alone. Let's take the non-terminals T, Q, R, S. Now let's take the first set. When we say T derives QX, the first symbol is a non-terminal. What should we do? We have to go and see in the non-terminal production, which is Q derives RS. From here there is a possibility of getting two values. One will be the terminal Y and another will be epsilon. So Q can have the first value Y as the terminal and epsilon as the value. What happens if Y is chosen? Y will be the first value. What happens if epsilon is chosen? If epsilon is chosen, this will be taken as epsilon S. It means you should not consider this epsilon, but you have to go and check S. What is there in S? There are two values, two symbols here. We have the terminal Z and epsilon again. So this part will also contain Z when R becomes epsilon. In case if T is given as T derives X, then this will be the first of T because it is the set of terminals that begin the strings derived from the production rule. But since there is a non-terminal given here, we are following these steps. So we are probing into Q, from Q we are probing into R, When R becomes epsilon, that case we are probing into S. So what are the possible terminals that we got? We got Y, we got Z, and we even got epsilon. So there are possibilities where R can be epsilon and S can be epsilon. But after that, do you have any other symbol here? We don't have any other symbol. Why are we not considering X? We have to consider the terminals that begin the strings. So in that case, we are stopping with Q alone. So the first of T will be Y, Z, epsilon. What about the first of Q? Whatever happened to T, the same thing will happen to Q, because you are starting with R and S. When R becomes epsilon, S will take its place. So we have the same set of terminals for Q also. What about R? What is the first set of terminals that R can have? It can either have Y or epsilon. So we have placed them as it is. What about S? It can have Z or epsilon. We have placed as it is. Now how should we find the follow of a particular non-terminal? Place dollar in follow of S, where S is the start symbol. If there is a production, A derives alpha, B beta, then everything in first of beta except epsilon is in follow of B. They have said it's a collection of terminal symbols that will occur directly to the right of A. This is with respect to follow of A. Now just apply follow of B with respect to alpha, B, beta. When it is follow of B, you have to take the terminal symbols that occur directly to the right of B. What is there in the right of B? It is beta. How should you take the set of terminals from beta? You have to take everything in first of beta. So when we have follow of R, we have to include whatever is in first of S. And this should be except the epsilon. So we are just giving minus epsilon. If there is a production A derives alpha B, or a production A derives alpha B beta, where first of B contains epsilon, then everything in follow of A is in follow of B. You can consider this particular production as Q derives RS. This is going to be Q and this is going to be R. Now excluding the epsilon, we are including the first value of S, which is Z. So first of S is having Z and epsilon. Since epsilon is present, we are not including it in the follow set here. But since epsilon is present here, we are including everything in follow of A in follow of B. So what is follow of A here? You have to find the follow of Q. What is follow of Q? You have to go to the right side of the production. We have a production called T derives QX. For now, follow of A is this one and this will be the right of A. So here follow of Q means to the right of Q, what do you have? You have X. So this will be included here. If there is a production and the first of beta contains epsilon, so this case is true, then everything in follow of A, that is everything in follow of Q, is in follow of R. So already we had Z here. Along with that, we are adding this X terminal also to the follow set of R. So this is how we will be finding the follow of a non-terminal. So for R, I have explained you in a detailed way because that is directly asked in the question. So which option is matching to this? Option number 3, Z, X will be the right answer. Now we will just find the follow of all the non-terminals for your learning purpose. Let's take T. T doesn't occur here. There is nothing right side to T. Initially they will place dollar. So this is dollar here. What about follow of Q? Next to Q you have something called X. And X is a terminal. So we are directly placing X. What about R? So the first step is we have to take the first of S minus epsilon. And since epsilon is present, you have to go with follow of Q. So first will have Z and follow of Q will have X. So this is ZX. What about S here? S doesn't have anything in the right side. They have given two options here. If there is a production of this form or a production of this form, then include the follow of A in follow of B. It means include the follow of Q in follow of S. So this can be equated to A derives alpha B. Now whatever is in follow of A should be there in follow of B. So whatever is in follow of Q should be in follow of S. So follow of S will have only X here. So this is how we have to find the first and follow of the non-terminals. Next question. If L1 and L2 are context-free languages, which of the following is true about L1 intersection L2? Regular languages is a subset of context-free. They are a subset of context-sensitive. They are in turn a subset of recursively enumerable languages. When you are going to have intersection of two CFL, they can never result in regular. So this is false. CFL is closed under union, concatenation and clean closure, but not closed under complementation and intersection, which states that intersection of CFL and CFL will never be a context-free language. So option 1 is also ruled out. Now the question is between whether it is recursively enumerable or context sensitive. Definitely when there is intersection that is not closed, we will go to the immediate previous level, context sensitive. But the option is included as recursively enumerable also. Recursively enumerable set includes all languages for which there exists a Turing machine that will halt and accept any string in the language. The intersection of two CFLs falls into this category because a Turing machine can be constructed to enumerate all strings in both context-free languages and accept those that are in the intersection. When you are going to implement regular language, finite automata comes into existence. For CFL, we have PDA, DPDA. Similarly, for context sensitive, we have something called linear bounded automata. For recursively enumerable, we have something called Turing machine. This Turing machine has the capability of implementing all the other three languages because they are subsets. That's why they say when there is intersection of two CFLs, they ultimately fall into the category of recursively enumerable because Turing machine can be constructed for this purpose. What about context sensitive? It is actually more restrictive than recursively enumerable languages. While some intersections of CFLs might be context sensitive, it is not guaranteed for all cases. There are cases where intersection of CFL may be context sensitive, but it is not true for all the cases. It is not guaranteed in the sense it is definitely a part of recursively enumerable languages, but it is always not a part of context sensitive language. This is why we are ruling out even option number 4. We are going with option number 3. L1 intersection L2 is recursively enumerable as the right answer. The intersection of two CFLs is always recursively enumerable, but not necessarily context sensitive is the main point that you have to consider. Next question. Arrange the following stages of a Turing machine operation in the correct order as they occur during computation. The Turing machine starts with an infinite tape divided into cells. Infinite means you don't have any end to the tape. The machine reads the symbol in the current cell under the head. So the first process is reading the symbol. We can mark C to be the first process. So all the options start with C. Based on the current state and the symbol read, the machine refers to its transition function to determine the next actions. This is C, and this line can be equated to transitioning to a new state based on the current state and symbol read. So this part comes next, and this will be point D. So what are the next set of actions? Writing a symbol in the current cell, which may be the same or different from the one that is read. So this point is available in A, moving the head one cell to the left or right. So this is moving the tape head left to right. and here it is B. Changing to a new state will be another set of action. The machine stops its operation when it reaches a predefined halting state. The contents of the tape at this point represent the output of the computation. The remaining one is halting and accepting or rejecting the input. So it will halt, but it will either accept or reject the input is the overall scenario here, which will be the final step. So this can be equated to E here. Option number 3 will be the right answer. So they have given C and E as the initial and the final steps for all the options. All you need to work out is with A, B and D. Next question. Arrange the following stages of parsing in the correct order as they typically occur in the compilation process. We are starting with lexical analysis. This will be A. Then we have syntax analysis, that is C. Then we have semantic analysis, which is B. Then we have intermediate code generation, it is D. And we have code optimization, which is E. So the order is A, C, B, D, E. Option number 2 will be the right answer. Next question. Arrange the following language classes in ascending order according to their expressive power as defined by Chomsky hierarchy. We are starting with type 3 regular grammar, then type 2 context free grammar, type 1 context sensitive grammar, type 0 as unrestricted grammar. So when we say unrestricted grammar, it will have the highest power there. So the option should end with D. Only 2 options are ending with D. So we will rule out the other 2. So this will be D, unrestricted grammar. Then we have context sensitive languages or grammar. This will be B. Then we have context free grammar, which is A. Then we have regular grammar, which is C. Which has the least expressive power here? Of course it is regular grammar. Here we have something called unrestricted grammar, which will have large amount of expressive power. So we have to start with C. Only one option out of these 2 is starting with C. So we can rule out even 3. We'll go with option number 1 in this order since they are asking in ascending order. Next question. Which of the following are context-free language? When we want to find whether a particular language is CFL or not, we will always go with the pumping lemma rule. But here we are not getting into the pumping lemma part. We have W power I, X power J, Y power K, Z power L in all the 5 options. So let's take A first. We have a condition called I plus K is equal to J plus L. Wi, X, J, Y power K and Z power L. I plus K means the number of W's and Y's together will be equal to the number of X and Z's together. We usually use push down automata to count whether number of A's are equal to number of B's. In this PDA stack allows comparison of only 2 variables at a time. We have to see whether we are able to use only 2 variables to check all these conditions. So first let's start with the first condition, I plus K is equal to J plus L. What does this actually mean? We can say I is greater than or equal to J or I is less than J. Now we will take an example. We will go with I is equal to 2, K is equal to 3. Then we will go with J is equal to 4, L is equal to 1. So ultimately I plus K equal to J plus L will give you 5. So let's take the string actually. W power 2 will give 2W. Then J, X power J is X power 4. So we have 4 number of X. Then we have 3 number of Y because it is Y power 3. Then L is only 1. So Z is only 1. Let's understand how this can be done using a PDA. Whenever you read W, you just push into a stack. So let's take a stack like this. So the first symbol is red now. And we have another W. So we are also pushing it to the stack. Read X. If W is in top of the stack, pop W. If the stack is empty, push X. When we read the first X, we are checking whether W is there on the top of the stack. Yes, W is there. So what we should do? We have to pop W. So we will pop it out for the first x. Now we will again read x. Is there a w in the stack? Yes, when this w goes on, this w becomes the top of the stack. We are also taking the second w. So which is available in the top of the stack, we are removing that also. Now we still have x here. If stack is empty, they are asking to push x. So we will go for a fresh stack again. Now we are pushing x. So the first x is pushed here. The second x is pushed here. Now what is in the top of the stack? This x is in the top of the stack. Now we are reading y. If x is in the top of stack, pop x. Else you have to push y. So for first y, we are popping out x. For the second y, we are popping out the other x. Now when there is no x, what you should do? You have to push y. So this time we are just pushing y. What about the next read? It is for z. If w or y is in top of stack, pop it. For one z, we are just popping out this y alone. Is the stack empty now? Yes, it is empty. Yes means this particular string is accepted. No means the string is rejected. So here the stack is empty finally. So this string is accepted here. It means I plus k is equal to j plus l is true here. That's why the string is accepted. Here we have checked this for I that is less than j. Now we have to check for I is greater than or equal to j. We will have I is equal to 3, k is equal to 2, j is equal to 1 and l is equal to 4. We are swapping the values of I and k and j and l. Now just check I and j. 3 is greater than 1. We will even check for this condition whether this particular mechanism is working. We are taking the stack here. We will once again have the input symbol here. W, W, W. It's for 3 i's. Then we have only 1 j, that is for x. Then we have 2 y's and 4 number of z. For w's, we have to push it to the stack. For 3 w's, we will push 3 w's onto the stack. Now we are actually reading x. So for 1x, we are popping out 1w. Now we will get on to y. If x is in top of stack, you have to pop x. Otherwise, you have to push y. You have 2 w's here. You don't have any x here. If there is no x, what you should do? You have to push y. So we are pushing both the y's here. Now for reading z, what is the condition? You should check if w or y is in top of stack and then pop them out. So for the first z, this y will go. For the second z, this y will go. For the third z, this w will go. For the fourth z, this w will go. So this is the same stack only. Above these 2 w, I am adding 2 y's. Is the stack empty now? Yes, it is empty. It means this string is also accepted. I plus k is equal to 5. J plus l is also equal to 5. Which of the following are context free? Since PDA is accepting this particular string, we can say A is a CFL. When you find A is a CFL, you can rule out the other 3 options and mark option 1 A comma B as the right answer. From this, what do we understand is B is definitely a CFL. C, D and E are not CFL. Now we will get into B. What is the condition for B? I is equal to J and K is equal to L. It means the number of W should be equal to X and number of Y should be equal to Z. Whenever you have W, you have to push it. When you find X, you have to pop W. Similarly, whenever you have Y, push Y to the stack. When there is Z, pop Y out of the stack. So here we have checked for 2 strings. We'll just place those 2 strings here. Let's get into I is equal to J and K is equal to L. So whenever we read W, we push W to the stack. When we read X, we pop W. When we read Y, we push Y. When we read Z, we pop Y. So let's take an example. I is equal to J is equal to 2 and K is equal to L is equal to 3. So we'll have W, W, X, X. Then we'll have Y, 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 Z, Z, Z. So this is the sample string we are going to take. So I is equal to J is equal to 2 and k is equal to L is equal to 3. So this will be WWXX YYY ZZZ. So just go with the stack. When we have W, we have to push it. So we have pushed 2 W's. When there are 2X, it will be popped. Again, when we go for Y, we have 3 Y's for every Y here. Then for every Z, we are popping out all the 3 Y's. We are checking whether the stack is empty at the end of input. Yes, it is empty. It means the string is accepted, and this is also a CFL. So B is quite easy to prove, but once you find B is right, you have to check either A or C. So in this case, if you understand A, it will be easy for you. B is definitely a CFL. So the answer that we marked is also right. Now how do we prove that C, D and E are not CFL? Here we have something called I is equal to J is equal to K and K is not equal to L. When I say I is equal to 2, J is equal to 2, K is equal to 2 and L is equal to 3, L is not equal to I as well as J. This is somewhere similar to A power n, B power n, C power n and D power m. You can check A power n, B power n in PDA. But when you want to check 3 variables, whether they are equal or not, because this first condition is to check whether these 3 variables are equal. If that is the case, one PDA will not be enough. So we can conclude here itself that it is not context free. So here we can say W, X, Y and we'll have 2 Z. How do we prove that W is equal to X is equal to Y? So when you want to combine all these 4 variables together, this is quite not possible. So in that case, we are actually going with not CFL with respect to C. What about D? I is equal to J is equal to K plus L. Here we can have I is equal to 2, J is equal to 2, K plus L is also equal to 2. W, X, X, then Y, Z. You can compare up to 2 variables here using PDA. But when you want to take account of 3rd and 4th variable and equate it to this particular variable, that cannot be done using a single push down automata. Maybe we need 2 stack. It doesn't come under the category of context free languages. So this can also be taken as not CFL. What about E? This is also similar to C condition. 3 variables are equal here. So W will be equal to X and it will be equal to Z. But they are not equal to the count of Y. So here also we can conclude they are not CFL. If you go with finding the pumping lemma of all languages, you may not always arrive at the right answer because it is about the selection of this VXY. If you don't select it appropriately, even the right one will give you the wrong answer and even the wrong answer will become right for you. Next question. Which of the following languages are recognized by non-deterministic finite automata NFA but cannot be recognized by deterministic finite automata DFA? This question is actually a wrong question, we can say, and that's why they have dropped this question. We'll first understand what is wrong. A language is recognized by a deterministic finite automata if and only if there is a non-deterministic finite automata. In other words, we can say for every DFA there is an NFA and for every NFA there is DFA possible. When we have some kind of regular expression or regular grammar, we will try to find the non-finite automata implementation first and from there we will try to convert it to DFA. So every DFA will have an equivalent NFA and every NFA will have equivalent DFA. So there is no difference in the power of NFAs and DFAs. When every NFA recognized language can be expressed by a DFA, this question becomes meaningless. Now let's check whether we are able to solve it using NFA or DFA. L1 is actually the length of W is even. You have to find whether the string is of even length or not. For even, how we can check is, it can start with 0 or 1. It can end with 0 or 1. Whatever comes in between should be a combination of 2 characters. So we can keep it as 0 0 or 0 1 or 1 0 or 1 1 with clean closure. Just pick 0 here, 0 here. 0 0 is even length? Yes. Just pick 1 here and 1 here. 1 1 is even? Yes. When you try to pick 0 0 in between and add to the first two zeros, this becomes 4 number of zeros, it is again even. So definitely A can be expressed in the form of regular language. So it can be implemented by NFA as well as DFA. Now what about B? The length of the string is odd, they have given. So how do we check for odd? We will do the same thing. We will go with 0 or 1 in the starting, and then we will also go with the 2 character string here, and we will stop here. We start with 0 and we don't have any number from this particular expression. This is odd length. We start with 0. Then we have 2 zeros from here. So this becomes a count of 3. It is again odd length. So this is also expressed in regular expression format. So B can also be implemented using DFA and NFA. Let's take C. All zeros come before all ones. If that is the case, we will first have zeros and then we will have 1. This is how we will be expressing it. And what about E? All ones must come before all zeros. So first we will have 1 and then we will have 0. If it is star, 0 occurrence is fine. When it is plus, at least 1 occurrence should be there. Only when 1 occurrence is there, we can confirm that zeros can come before 1. So that's why we have made it as plus symbol. So even C and E are expressed using DFA and NFA. What about D? W contains an equal number of zeros and ones. This cannot be implemented in a regular language. It is not possible to generate a regular expression for the language. Equal number of zeros and ones can be checked using pushdown automata, and this is a context-free language. So whenever you have 0, you push it. Whenever you have 1, you pop the 0. This is how we will be doing. This 0 power n, 1 power n is similar to a power n, b power n, which can be proved using a PDA. So this is definitely a CFL. Now we have understood about this question. We know why the question is meaningless, and we know 4 of the options can be implemented using NFA as well as DFA. So A, B, C, E, all the 4 can be implemented using NFA and DFA. Why is D not possible? Because you need to count the number. You have to know the number of zeros in order to check it with the number of ones to tell whether they are in equal count or not. So that's why we are not putting it under regular language category. Now, what should have been the actual question? There is a possibility of changing this question. There are CFLs that are recognized by NPDAs that cannot be recognized by DPDAs. There are certain context-free languages that can be recognized by non-deterministic pushdown automata, but that cannot be recognized by deterministic pushdown automata. If we can change this question as which languages can be recognized by NPDA and cannot be recognized by DPDA will make sense. This applies to pushdown automata but not to finite automata. This question is possible. NPDAs are more powerful than DPDAs. Now the next work is, we will try to apply all the 5 options and check whether we will be able to implement it using NPDA or DPDA. Let's take A and B. It is about the even length and odd length. The language of strings over 0, 1 with an odd or even length is a regular language. When it is a regular language, it can be recognized by DPDA itself. So if you take the finite automata, that can be recognized by DPDA. When DPDA cannot recognize something, it requires some additional work, then it goes to NPDA. When something is recognizable by NFA or DFA, it can be recognized by DPDA itself. We need not go to NPDA because they say NPDAs are more powerful. So in this case, this can be recognized by DPDA. What about C and E? They say all zeros come before 1 and all ones come before 0. This can be recognized by DFA or NFA again. So a DPDA is more than enough to recognize this particular language. What about D. W contains an equal number of zeros and ones. This can be recognized by a NPDA but not by a DPDA because it cannot handle the non-determinism required to match the number of zeros and ones. If we change the question as which of the following language can be recognized by NPDA and not by DPDA, we can mark option D as the right answer. Only D needs NPDA and it cannot be done by DPDA. The rest of the options A, B, C, E can be recognized by DPDA because they are recognized by NFAs and DFAs. Next question. Which of the following properties correctly describe a regular grammar? Let's check the statements. All production rules are of the form A derives X B or A derives X, where A and B are non-terminal symbols and X is a terminal symbol. A grammar is said to be right linear if all productions are of the form A derives XB or A derives X. A grammar is said to be left linear if all the productions are of the form A derives BX or A derives X. So this is possible and this is also possible. So A is definitely true. 2 and 3 can be ruled out at this stage itself. So from this what we can understand is a regular grammar is one that is either right linear or left linear. That's why we are marking A to be right. Now let's get on to the B statement. Regular grammars are more powerful than context-free grammars and can express any type of language. Unrestricted grammar has the most expressive part. So when they say regular grammars are more powerful, that is actually wrong because regular grammar is a subset to context-free grammar. CFGs are more powerful than regular grammars, you can say, and they have given can express any type of language. This particular capability is given only by unrestricted grammar. Regular grammars are the least powerful here or least expressive here. So this statement is totally false. When we rule out B, option number 1 also gets ruled out. Option number 4 will be the right answer. There is a direct correspondence between regular grammar and finite automata. Yes, any regular language string or the string that are generated using the regular grammar will be accepted by finite automata. It can be non-deterministic finite automata or deterministic finite automata. So both NFA and DFA can be considered here. Regular grammar's implementation part is finite automata. It is absolutely true. That's why we are marking A and C as true here. What is wrong with D then? Regular grammars can generate languages that are not recognized by any type of automata. This is also false. Regular grammar is the most restricted grammar. That's why you cannot solve all the problems using regular language. In that case, this type 0 grammar will be able to solve any of its subsets. Next question. Which of the following tasks could be attained using syntax trees in compiler design? Actually, when you see the phases of compiler design, syntax tree comes after syntax analysis. For which phases we can use them? We can use for semantic analysis. The same syntax tree can be used for intermediate code generation, and it goes on. So after the generation of syntax trees, these phases are possible. Type checking is done in semantic analysis phase. Code generation is done in intermediate code generation phase. Code optimization can also be taken as the next step of intermediate representation here. Syntax tree can be used for the following tasks. So we can include type checking, code generation and code optimization as the tasks. Option number 1, A, B, C only will be the right answer. What about error handling? Error handling in compiler design occurs throughout multiple phases. Now we will see how they occur in different phases. In lexical analysis phase, they detect lexical errors such as invalid tokens or characters that do not match any pattern defined by the language grammar. So this is like identifying an illegal character in the source code. So whatever is given in the parenthesis is just an example of one such error. The syntax analysis phase throws errors like the sequence of tokens does not conform to the language grammar rules. Say for example, if there is some missing semicolon or unmatched parentheses in the code, they come under syntax analysis error. What about semantic analysis phase? This identifies semantic errors where the syntax is correct but the meaning is not valid. Using an undeclared variable or type mismatches come under this category. What about the next phase? This ensures that the intermediate code adheres to the language semantics. This is detecting error in the translation of high-level constructs to intermediate representation. What about the code optimization phase? Although less common, some errors related to optimization strategies can be detected here. What kind of error you can identify? Unreachable code or redundant operation can be detected here. What about code generation phase? This ensures that the final machine code is correctly generated. Detecting errors in the allocation of registers or incorrect instruction formats can be the errors detected during this phase. Each phase has its own strategies for error detection, reporting and recovery to help developers identify and fix issues efficiently. So far I have just told what kind of errors can be detected. So this is to tell you that error handling will occur at all phases. Linking and loading stage handles errors related to linking multiple object files and loading them into memory. So this is like missing external symbols or address resolution issues. Errors can occur even in linking and loading stage. With this, we are completing Unit 8 solutions. Let's solve Unit 9 Data Communication and Computer Networks questions. Consider the three-way handshaking process followed during TCP connection establishment between two hosts A and B. Let SNR be two random 32-bit starting sequence numbers chosen by A and B respectively. Suppose A sends a TCP segment having synchronization bit is equal to 1, sequence number is equal to S, and acknowledgement bit is equal to 0, and B accepts the connection request. Which one of the following choices represents the information present in the TCP segment header that is sent by B to A? The connection establishment in TCP is actually called as three-way handshaking process. So that is what they have mentioned in the very first line. They have given two hosts A and B. What is this SYN bit? This is actually to initiate connection establishment request. So when the bit is set, it means a request is initiated. Then we have acknowledgement number in the option here. This acknowledgement number is the sequence number of byte expected next. We also have another bit called FIN bit. This is actually to mention that the connection is terminating. So FIN bit is set while terminating the connection. Only at that time the bit value will be equal to 1. So from three of the bits here, SYN, ACK bit and FIN bit, what you can understand is all these three are Boolean values. It means they either have the value of 0 or 1. When they say this field is actually set, it means the value is equal to 1. Now they say A sends a segment having sync bit is equal to 1, sequence is equal to S and acknowledgement bit is equal to 0, and B accepts the connection request. So the scenario given in the question is what happens when A initiates a connection request to B. Now they have told B has accepted the request. What happens when B responds back to A? In this three-way handshaking process, we will see what will happen actually. The client sends the first segment. It has a SYN segment in which only the SYN flag is set. It means the value is equal to 1. This segment is for synchronization of sequence numbers. It consumes one sequence number. Here they have represented 32-bit sequence numbers as S and R. So A will have S and B will have R. When the data transfer starts, the sequence number is incremented by 1. You can find S plus 1 in 3 of the options. It means the sequence number is actually incrementing there. Now this is actually the scenario where A initiates some request to B. The next scenario is the server sends the second segment, a sync and acknowledgement segment with 2 flag bits set. The sync value is 1 and the acknowledgement value is also 1. Both the bits are set to 1. It is a SYN segment for communication in the other direction, that is from B to A, and serves as the acknowledgement for the SYN segment. So this is for communication in other direction, and this is the acknowledgement sent for the SYN segment that came from A. So this is SYN of A. For that purpose they are sending acknowledgement, and this also consumes one sequence number. What about the next part? The client sends the third segment. This is just an acknowledgement segment. It acknowledges the receipt of the second segment with the acknowledgement flag and acknowledgement number field. The sequence number is the same as the one in the SYN segment. The acknowledgement segment does not consume any sequence numbers. This is the next scenario. So in three-way handshaking, these three scenarios happen. So the first scenario is what is given in the question, as suppose A sends a TCP segment. And the second scenario is what they have asked us to find from the options. What will be present in the header when B communicates to A? Now we will just check. They say the SYN segment and ACK segment will be set to 1. So wherever you have both the values to be 1, those options can alone be kept now. SYN bit is equal to 1 and ACK bit is equal to 0. So we will rule out this. We have SYN bit as 0. So we will rule out this. We have SYN bit as 1 and ACK bit as 1. Here also SYN bit is 1 and ACK bit is 1. So we have to find from 3 and 4 only now. This is a SYN segment for communication in the other direction and serves as the acknowledgement for the SYN segment, where this consumes one sequence number. A sends with the sequence number S to B, and this particular acknowledgement will just consume one sequence number, means this S will become S plus 1 when B is responding back to A. This serves as the acknowledgement for the SYN segment that is actually sent from A. So we have to increment this part here for the acknowledgement number. So where do you find the value S plus 1 here? Only in option 3, since it says it consumes one sequence number. So what does consuming sequence number means? We can say the sequence number is incremented by 1. In that way we can take this to be S plus 1. And what about the sequence number of B? It is R. So this sequence number is actually present here. This is B's sequence number and this is A's sequence number that is incremented by 1. So we can even rule out option 4 because it is going to send acknowledgement number as S, the same as A, which is actually wrong. So in that case we can mark option 3 as the right answer. Now what about the FIN bit? It is set to 0. It means it is actually communicating. It is not terminating the connection. Then it has to terminate the connection. The bit will be set to 1. Only when you understand what happens in three-way handshaking process, you will be able to pick up the right choice here. Next question. Two computers A and B are configured as follows. A has IP address and a subnet mask. B has IP address and a subnet mask. What one of the following statement is true? So they are asking from the perspective of A and B what they assume, whether they are on the same network or whether they are on the different network. So how should the process be done? From the point of view for A, A's IP and A's subnet mask both should be taken for bitwise AND operation. Similarly, B's IP and A's subnet mask again has to be taken for bitwise AND operation. This is with respect to A. The subnet mask of A will be manipulated for bitwise AND with A's IP as well as B's IP. The similar case will happen in case of B. So we will take the B's subnet mask in both the cases, and here A's IP will be manipulated and here B's IP will be manipulated. So this is what we are going to do now. The value of IP address is in decimal dotted notation. So we will just go with 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6 and 2 power 7. When all the bits are set to 1, the value is actually 255. When all the bits are set to 0, the value is 0. So let's take the A's IP first. It is 203.197.2.53 and the subnet mask of A is 255.255.128.0. What will AND operation do? Whenever both the inputs are 1, the output will be 1. This is the case of AND operation. So when you do AND operation between 255 and 203, the result will be 203 again. 128 plus 64 is actually 192. 192 plus 8 is 200. 200 plus 3 is 203. So we will have 1, 1, 0, 0, 1, 0, 1, 1 in 203. So when you are going to do AND operation with 255, wherever you have 1 in 203, those places will again be 1 here, which will give you 203. So when you do AND operation with 255, the same number will be repeated. So in this case, we can retain 203 as it is. What about 197 and 255? So when you are going to do AND operation with 255, again 197 will be retained. And just check for the 0 here. We have zeros everywhere when the value is 0. 1, 2, 3, 4, 5, 6, 7, 8. How do you do for 53? 32 plus 16 is 48. 48 plus 5 is 53. So we will have 0, 0, 32 plus 16, 0 here and 101 here. This is going to be 53 and this is 0. When you do AND operation, what you will get? Irrespective of the ones in the 53 part, you will get zeros everywhere, because 0 with 0 or 1 will give you 0 only. That is AND operation. So in this case, when you manipulate anything with 0, the value will be staying as 0 only. We have to find only for 2 and 128. That we will do it now. So we will have dot 0 here. We have to write it for 2. So this bit is 1 and the rest of the bits will be 0. Actually this is for 2. And what about for 128? Only this bit will be 1. The remaining bits are 0 for 128. Now just do AND operation here. Everything will be 0 because 1 and 0 is going to give 0 here. 0 and 1 is going to give 0 here. The rest of the places are 0. When you get zeros everywhere, this is equal to 0. So the value of AND operation between A's IP and subnet mask will be 203.197.0. The final value is also 0 because when you do AND with 0, you will get 0 ultimately. Now we will check it with B's IP. The A's subnet mask will be staying the same. So when you do AND operation between 203 and 255, this will be retained. 255 and 197, this will be retained. Between 0 and 201, this will be retained. So I will even mark the places here so that you will know that. Now we have to find for 75 and 128. So what is 75? It is 64 plus 11. So 64, 72, 74 and 75. The remaining places will be 0 here. What about 128? Same thing, you have to have only 1 here. In this position, the remaining places will be 0. So why have I actually divided this into column is, in one of the previous question paper, I just wrote this in random and people were not able to see it properly. That's why this time I have just divided the columns for better clarity. Now we have to do AND operation between these two. 1 and 0 is 0, 1 and 0 is 0. This is also 0, 1 and 0 is 0. These two are 0, 1 and 0 is 0 and 1 and 0 is 0. So we are getting 0 everywhere. So the value will be 203, 197, 0 dot, the final value is also going to be 0. We got 203.197.0.0 in both the places. So this is from the perspective of A. Now we have to find from the perspective of B. So here we are taking the subnet mask of B. So this is the subnet mask of A. Now we have to manipulate it again. 255 and 203 will give you 203. 255 and 197 will give you 197. 0 and 53 will give you 0 only. Now we have to calculate for 2 and 92. So 2 in the sense only this bit will be 1. The remaining bits are marked as 0. What about 192? 128 and 64 together will make 192. So we are just making these two bits as 1. The remaining bits are 0. Now we have to perform AND operation here. No bits are actually same here. So this is 0, this is 0. This is also 0. So you have only 0 here. Now what will be the value? 203.197.0.0. Now let's do the same thing for B. B's IP with B's subnet mask. 255 and 203 will have 203. 255 and 197 will have 197. 0 and 201 will have 0. Now we will go for 75 and 192. 192 we know the first two bits are 1. The remaining bits are 0. What about 75, 64, 8, 2 and 1. The remaining places are 0. Now we have 0 and 1 as 0. We have one bit that is having 1 in both the places. This will give 1. This place has 0. This place has 0. This one is 0, 0, 0, 0. So what is this when you have 1 only here? It means it is 64. So AND operation between these two will give a value of 64. Now just write the value 203.197 dot, the third place will have 64 because we have one bit here in both the places and the fourth part is 0 as it is. Now we will just take according to A, the AND operation between A's IP and A's subnet mask gives a value of 203.197.0.0, and from A's subnet mask we are computing AND operation with B's IP, we get the same value. So from the point of view, A thinks that both are on the same network because they have the same value here. So this concludes they are on same network. What about B? For B, A is in 203.197.0.0, but when it computed with B's IP and its own subnet mask, it ended up with 203.197.64.0. So from the perspective of B, both are on different networks. This is B's viewpoint and this is A's viewpoint. Now just read the options. A and B both assume they are on the same network. No. B assumes A is on the same network. B actually assumes that they are on different networks. So this part is actually wrong. So we can take this to be wrong. And the second part, A assumes B is on different network, is also wrong. What about C? A assumes B is on the same network. That is right. But B assumes A is on a different network. This is also right. So 3 applies perfectly here. Option 3 will be the right answer. For A, B is on same network. But for B, A is on a different network because of the different values we have found out from the bitwise AND operation. The fourth option says that A and B both assume they are on different network. This is also wrong. So when you are sure about 255 and any number x, the value will be x. 0 and any number y, the value will be 0. These two things has to be in mind so that you can minimize the number of computations involved in finding the bitwise AND. So from the name we can take, we have to compute it bitwise. That's why we are finding the binary equivalent of the decimal dotted notation values that are given in the question. Next question. A class B network on the internet has a subnet mask of 255.255.248.0. What is the maximum number of hosts per subnet? We have solved such questions already in previous year question paper. The maximum number of hosts is given by the formula 2 power n minus 2. So let's take the decimal dotted notation and again we will go with finding the binary equivalent. So 255 means you will have 1 in every place. So you have 8 ones here. 1, 2, 3, 4, 5, 6, 7, 8. And for 248, 128 plus 64 is 192. 192 plus 32. It is 224. 24 plus 16. It is 240. 240 plus 8 is 248. And the remaining 3 places are 0 here. What about this 0? You will have 0 in all the 8 places. So this is the binary form of the decimal notation. Now what has to be taken as this power n? The number of zeros are to be counted for calculating total number of possible hosts per subnet. So when they say subnet mask has these many values, they will also use a notation called /21. It means 21 ones are present here. Just calculate. Here there are 8 ones, here there are 8 ones, and here there are 5 number of ones. Altogether 21 ones are present. It means how many zeros are present? 1, 2, 3. This is 1, 2, 3, 4, 5, 6, 7, 8. So there are 3 plus 8 which is equal to 11 zeros present. So here we can take the value of n is equal to 11. Let's find the maximum number of hosts. What is 2 power n? It is 2 power 11 minus 2. 2 power 11 can be written as 2 power 10 into 2 minus 2. 2 power 10 is 1024. This is 1024 into 2 minus 2. What is 1024 into 2? It is 2048 minus 2 which is equal to 2046. These many hosts will be there per subnet. Option number 3, 2046 will be the right answer. So they have given you the values of 1024 minus 1 and minus 2. Similarly 2048 minus 1 and minus 2. So always keep in mind while calculating the number of hosts we have to go with number of zeros. I hope you remember some learning already. The network ID will be actually 32 bits. If 21 bits are going to be for the subnet mask, if they are going to be 1, then definitely the remaining 11 bits will be equal to 0, which will give you the number of hosts per subnet. So when you add 21 and 11, it will give you 32 ultimately. Next question. In a token ring network, the transmission speed is 10 power 7 bits per second and the propagation speed is 200 meter per microsecond. The 1 bit delay in this network is equivalent to what? They are asking in terms of meter. So the delay in the network is equivalent to some distance or some length we can say. Token ring network is a LAN that uses a ring topology and token passing access method. So what about the given values? They have given the delay as 1 bit in the question and we have 2 other values, transmission speed and propagation speed. So what is this propagation speed? 200 meter per microsecond. In 1 microsecond, 200 meter distance can be covered. We will get into the calculation. This 1 bit delay can be taken as 1 bit into propagation speed divided by transmission speed. So 1 bit will stay as it is. Please have a follow of the units so that you should end up with meter at last. What is the propagation speed? It is actually 200 meter per microsecond divided by transmission speed is 10 to the power 7 bits per second. Now this 1 bit will stay as it is, into 200 meter also will stay as it is, and now this 10 power 7 can be written as 10 power 1 into 10 power 6 bits per second. Now we will bring this 10 power 6 to the numerator. This will be 1 bit into 200 meter per microsecond into 10 to the power minus 6 seconds. Then divided by 10 power 1, which is equal to 10. This bit is alone here. Per second has moved to the numerator along with 10 to the power 6. Only bits are there. This bit and this bit will get cancelled. So we have 200 meter per microsecond into, what is 10 to the power minus 6? It is 1 microsecond. So we will have microsecond here divided by 10. This microsecond will also get cancelled. Ultimately you will have 200 meter divided by 10. Cancel the 0. You will end up with the answer 20 meter. Option number 1 will be the right answer. Only when you keep the units meter per microsecond as it is, you can understand how that microsecond is getting cancelled from the denominator value. Next question. Consider a CSMA CD network that transmits data at the rate of 100 megabits per second over 1 kilometer cable with no repeater. If the minimum frame size required for this network is 1250 bytes, what is the signal speed? Kilometer per second is the unit in the cable. For collision to be detected, the frame size should be such that the transmission time of the frame should be greater than twice the propagation delay. Any possible collision will be discovered before the frame is completely sent. For that purpose, they are setting this particular condition. Transmission time is greater than twice the propagation delay. So I have included an equal to symbol here so that only by equating these two formula together we will be able to get the signal speed. So what are the formula for transmission time and propagation delay? Transmission time is equal to frame size divided by bandwidth. Propagation delay is equal to distance divided by speed. Now we will substitute these values in this particular place. Instead of transmission time, we are using frame size divided by bandwidth. Instead of propagation delay, we are using distance by speed. From this question, we will be able to get three values. The frame size is given as 1250 bytes. The bandwidth is actually given as 100 megabits per second. And the distance is mentioned as 1 kilometer. So we have to find only this speed. Now we have to substitute those values. Frame size is 1250 bytes divided by 100 megabits per second greater than or equal to 2 into distance is actually 1 kilometer. We can retain the kilometer as it is because this unit is also in kilometer only. Divided by speed. So instead of speed, I am just going to denote this by S. In the denominator we have megabits, but here it is bytes. So what we will do, 1250 into 8. I am just converting them to bits divided by 100 into mega will be 10 to the power 6. So we know 10 to the power 3 is K and 10 to the power 6 is M. This is bits per second greater than or equal to 2 into 1 is actually 2 kilometer divided by S. So here we can cancel bits and bits. So I can write 1250 into 8 divided by, instead of 10 to the power 6, I can just change this as 10 to the power 5 and I will add 110 here, making it to be 1000. So this is 100 into 10 to the power 1, which is actually 1000. So I am splitting 10 to the power 6 as 10 to the power 5 into 10 to the power 1 to make it to 1000. Greater than or equal to 2 kilometer by S. So what is 8 divided by 1000? This is 8 ones are and this is 125. So 125 into 8 will give you 1000. So this is 125 and this is 1250. It means here you can have 1 and this is actually 10. So we have 10 into 1 which is equal to 10 divided by this per second is actually here. So we will retain the per second as it is. So this is 10 to the power 5 per second. So let's equate this because we have to find S. This is 2 kilometer divided by S. Now I'll bring S to the other side. So this will be S into 10 divided by 10 to the power 5 per second, which is equal to 2 kilometer. So in order to find S, we have to bring this to this side. So this will become 2 kilometer into 10 to the power 5 per second divided by 10. 10 to the power 5 can be expressed as 10 to the power 4 into 10 to the power 1 divided by 10, and this is per second. This 10 and this 10 will get cancelled. So overall you will have 2 and 4 number of zeros. This kilometer per second will be retained as it is. So the value of S will be 20,000 kilometer per second. This will be the signal speed in the cable. Option number 4, 20,000 will be the right answer. So the kilometer per second unit is already given in the question. We have to just equate the value alone. Next question. Arrange the following steps in a proper sequence for the typical process of a DNS query. So just to solve this question, we will use a diagram now. So here we have the client or the web browser something, and first request is to a local DNS server. From there it is asking a root DNS server. From there it is asking a top level DNS server, and from there it is going to the authoritative DNS server, and from there you have replies marking 5, 6, 7 and back to the browser once again. So here you can find the local DNS server is having a DNS cache. So first it will check the cache and then it will go to the root for further querying. So let's start answering this. We have query authoritative DNS server, local DNS server check cache, root DNS server, and TLD DNS server. TLD is top level domain DNS server. So it has to start with the local DNS server. So the web browser or the client will be querying the local DNS server first. So what will happen when it queries the local DNS server? The DNS server will actually check the cache first. So B, C. After checking the cache, if it does not resolve or if it does not find what it is needed, it will query the root DNS server, which is D. This root will query the top level DNS server, that is E. And this top level domain DNS server will go to the authoritative DNS server. So here D, E and A. B, C, D, E, A. Option number 4 will be the right answer. This is with respect to the scenario that is given in the question. You will have a local DNS server. If it cannot find it out from the cache, it will query the root DNS server. So the order goes like this. But in general scenario, instead of this local DNS server, we have something called recursive DNS server. This will act as a DNS resolver, we can say. So to whomever it wants to ask, this particular server will ask and fetch you the answer. The DNS recursor is a server designed to receive queries from client machines through applications such as web browser. So here we can equate it to local DNS server. The root server is the first step in translating or resolving human readable host names into IP address. This particular part. The top level domain server is the next step in the search of a specific IP address, and it hosts the last portion of a host name. This particular server. Then the authoritative name server is the last stop in the name server query. This one. If the name server has access to the requested record, it will return the IP address for the requested host name back to the DNS recursor that made the initial request. So here you can find the communication is between the DNS server and the root server, the DNS server and the top level domain server, the DNS server and the authoritative DNS server. This is what latest articles actually say, but if you get into DNS querying, this is actually the exact procedure that is quite close to the question that is asked. Next question, they have given you 5 statements and they have asked choose the correct answer from the options given below. So we will check the statements. In IPv4 addressing, a block of addresses can be defined as x dot y dot z dot t slash n, in which x dot y dot z dot t defines one of the address and slash n defines the mask. It is perfectly right. The first address in the block can be found by setting the rightmost 32 n bits to 0. This is also right. Address of class C is used for multicast communication. Here I have listed the classes and their application. If you take A, B and C, all are unicast. This multicast is for class D addresses and class E is for reserved purpose. So option C is actually wrong. Just rule out the options that have C, and this says option 2 will be the right answer for this question. The next statement, there are 5 classes in IPv4 address A, B, C, D, E. Yes, it is right. Supernetting combined several networks into one large network is also right. Next question. Host A on TCP IPv4 networks send an IP datagram D to host B. So A is sending to B a datagram D. This is also on TCP IPv4 network. Assume that no error occurred during transmission of D when D reaches B. Which of the following header field may differ from that of original datagram D? This is actually A and this is actually B. If you are going to change the source and destination, the datagram will not know from where it started and where it has to go. So definitely D and E can never be different from the original datagram. So these two fields will stay as it is, because we have to know who sent the datagram and we have to know for whom is the datagram. So this will not change. Any options that involve D and E can be ruled out. Now the question is whether A and B are alone there or even C is there. So let's check the options individually. The time to live field is used to control the maximum number of hops visited by the datagram. When a source host sends the datagram, it stores a number in this field. This value is approximately twice the maximum number of routes between any two hosts. Each router that processes the datagram decrements this number by 1. So every time the value gets decreased during every hop, and when this number reaches 0, it understands that it need not be sent further. From this, what you can understand is TTL will change, because every router will decrement the number, means every time the number of hops will get reduced. So imagine there are 10 routers in between. When you reach the 7th or the 8th router, the number will be 1 or 2 only. So for every router, this value will be changing. So TTL is in. The header field may differ from the original datagram is the question. So TTL will definitely differ. And we know TTL is a part of the header now. When one field changes, automatically the checksum value will also change. The checksum in the packet covers only the header and not the data. When I say one of the value in the header is actually changing when we visit every router, it means the checksum has to be computed every time. It means checksum is also different from that of the original datagram. So this field is also changeable only. So A and B are definitely there. The only question that comes here is whether C is included or not. I'll just tell you a scenario here. The original datagram, we'll just imagine it has 4000 bytes. The numbers are from 0 to 3999. We know there are many routers in between A and B. Take for example, this is R1, this is R2. We know that every router will have certain capacity to send. If this datagram is going to be greater than the capacity of a particular router, automatically fragmentation will occur. As per this example given in the screen, the router has a capacity of only 1400 bytes, but the datagram is of 4000 bytes. So it has to send 1400, 1400. This is first fragment. This is second fragment, and the third fragment will be 4000 minus 2800 will give 1200. It will be split this way, 1400, 1400 and 1200. So if you add up all these, you will get 4000 totally. So the maximum capacity of a particular router is going to be 1400, means this 4000 packet will be fragmented into 3. So the first fragment carries bytes 0 to 1399. The second fragment carries bytes 1400 to 2799. And the third fragment, the final one, it carries 2800 to 3999. So for every fragment, see the offset calculation here. You have 0 here, you have 175 and you have 350. I am not getting into the calculation of offset, but here the story is, when the datagram size is going to be large than the router's capacity, the datagram can be fragmented. They have not mentioned anything about the don't fragment field and all. So if the don't fragment field is set to S, you have to not fragment it, you have to find another route. You have no other go. But if that field is not set, it means the datagram can be fragmented. If the datagram is fragmented, definitely this fragment offset will have different numbers. When the original datagram reaches B, this field may not be same when we take this into account. Keeping this case in mind, we can mark fragment offset also as the answer. So we can go with option number 2, A, B and C only. Next question, match list 1 with list 2. They have given IP address in list 1 and they have asked to match it with the respective class. We'll just have an idea. So A is from 0 to 127, B is from 128 to 191, C is from 192 to 223, D is from 224 to 239 and E is from 240 to 255. 10.20.30.40 is lying in the range of A. A will be mapping to 3, class A. A3 is available only in option number 4. Then we have 210.20. 210 means it is in the range of C. So B is mapping to 4, class C. What about 180.30? It is in the range of B. C will be mapping to 2. 252.5. This is in the range of E obviously. So D will be mapping to 1. Option number 4 will be the right answer. When they say it is 0 to 127, only this particular number is taken for range. So the from field will have 0.0.0 and the to field will have 255.255.255 definitely. Next question. Match list 1 with list 2. This is about the layers. So we'll just see a diagram here. We are seeing the physical layer, data link layer, network layer, transport layer and application layer. We have the involvement of bits in physical layer. So A representation of bits will be mapping to 2. A2 is available only in one option. Then they have given about segmentation and reassembly. So this part, segments, can be taken as a clue. So D will be mapping to 1, transport layer. What about the address? So when it is network layer, we go with logical address. When it deals with data link layer, we can term this as physical address. Old edition books will refer it as physical address and new edition book will refer it as link layer addresses. We can map D physical address to 4 data link layer and C logical address to 3 network layer. It is directly available. So if it is physical layer, it is bits. If it is data link layer, it is frame. If it is network layer, we can say it is a datagram or packet. When it is transport layer, we can again use the word datagram or even segment. So messages are involved in application layer. Do have an idea about the particular packet names of layers as well as the address terms used there. With this, we are completing Unit 9 solutions. Let's solve Unit 10 Artificial Intelligence questions. Arrange the following steps in a proper sequence for the process of training a neural network. We have seen about neural network in the previous year question papers. For this question. I'll just give you a diagram. We have an input layer first. This input layer will have weights for every neuron. So this part can be equated to weight initialization. So this will be A. Once weights are assigned to the neurons, so neurons in the sense, let's take this to be x1 neuron, x2 and x3. So once weights are initialized here, for further processing it has to move this way. This movement is called as forward propagation. This forward propagation can also be called as feed forward because you are moving forward. So this is actually B. So once you get onto the hidden layer, or from hidden layer after computation when you go to the output layer, you have to compare the actual output and the predicted output during training process. So actual output in the sense, whatever data you have given, you know this will be the output. So if actual output is going to be 100% of the output. Now this neural network might not initially predict it perfectly correct. So the predicted output, let's take for example, it is just giving 90% of the actual output. Now how much output does this miss? We know there is a 10% miss. This 10% error or 10% loss is what they mean as loss calculation in option D. So this loss has to be propagated in the backward direction. So the loss calculation will happen here, and once it has been propagated backward, the weights will be updated here near the input layer, and once again it will go for training process. So training is when you are repetitively working towards achieving 100% of the output. So every time the predicted output will be compared to the actual output, and based on the difference between the actual and predicted one, it keeps on training itself. Training in the sense you can take it as a learning. So here this loss function or loss score can be equated to D loss calculation, and once you calculate the amount of error or amount of loss, that value has to be taken to backward propagation. So here this will be C. Once this loss has been propagated backward, the weights can be automatically updated in the input part. So this will be E. So the order will be A, B, D, C, E. This is perfectly right in option number 1. When you find weight initialization as the first step, you can keep 1 and 3 as it is and rule out 2 and 4. Coming to option B and option C. Once weights are initialized, you have to move forward in the network. You cannot move backward because there is nothing backside of input layer. You have to move forward only. So based on B and C, we can always go with B as the next step. Taking B as consideration also, you can rule out 3. I am just telling you an alternate way of doing this problem when you are not sure about the subsequent steps. So once you initialize the weight, you just move forward, and based on some calculation, you just compare the actual output and predicted output. And when you find the predicted output does not match the actual output, we calculate some kind of error or bias, we can say. And that particular loss calculation will happen first, and if there is a loss, that will be propagated backwards. So that propagation will lead to weight updation. Next question. Arrange the following steps in proper sequence involved in a genetic algorithm. We have already seen about genetic algorithm phases in numerous previous year question paper. So let me show you the diagram again. The first step will be initial population. This can be equated to initialization because you are choosing an initial population for this process. After initial population, we are actually calculating the fitness value of those individuals. This fitness value calculation can be equated to evaluation. Evaluating the fitness value, we can say. This will be option E. So it has to start with B. Since only one option is starting with B, we can rule out the other 3. So if you don't have any other idea, just with the term initialization, you can answer this question. But this is all for exam sake, I am telling you. When you learn from question papers, try to understand or try to know the phases of genetic algorithm at least through these questions. Even if you are not able to study artificial intelligence separately, I think this is one of the best ways that you can prepare. So after calculating the fitness value, you have 3 steps: selection, crossover and mutation. These 3 steps should be in this order. You have to select only the individuals who are having high fitness value, and from those selection you are sending them to crossover and mutation process. So this selection is A, crossover is C and mutation is D. Even if you don't have any idea about evaluation, whether to insert it in the front or in the last, all you can do is check this order A, C and D. Can you find A, C, D anywhere together? Here you have A, B, here you have A, B, here you have A, C, D. This is actually in proper sequence. And this is A, C, so this is also not there. So only one of the option is having this set of operations in order. At least based on A, C, D options, you should be able to mark option number 3 as the right answer. So once all these 3 steps are over, it will go for termination criteria. It will check whether that particular criteria is satisfied. If it is satisfied, the algorithm will end. If it is not satisfied, again it goes back to fitness value calculation part. Evaluation is different from termination condition. Next question, match list 1 with list 2. This match is about perceptron. They have asked about activation function, learning method, areas of application and output. So we will pick up areas of application first. See, the rest of the statements in list 2 except one are having is as the starting statement. Even if you have no idea about perceptron, just based on areas of application, you can just map it to 4 because the rest of the options are actually a part of the second half of the statement. If you take is called delta rule, is one of the key component, is always boolean, everything is second half of the statement, but here they have directly asked areas of application. So we can map system identification and control, which is in 4, as the correct match to C. C4 is available only in one option, which makes it evident that other 3 are ruled out. Option number 3 will be the right answer. We will just equate it to the other right answers in the list. So let's take the perceptron input and output. So basically in perceptron you will only have one layer. So one layer will be the input layer. Once input layer weights are all multiplied by the neuron value x1, x2 and then summed up together, that value will be applied to the activation function. We have to send the sum of xw to the activation function and this will give a value. This value will be the output. So ultimately in a perceptron, the output will either yield a 0 or a 1, which means the value is exactly boolean. So boolean means you will have only 0 and 1. There are only 2 values possible. In that case, we can map D, the output of the perceptron, to 3 in list 2. The output is always boolean like a switch. Switch in the sense you can either on the switch or off the switch. So switch on is 1, switch off is 0. So here D is 3. So we are having D3 here. What about activation function and learning method? Learning method is what we say we are training the perceptron or training the neural network. When you take perceptron, you have single layer perceptrons, you have multi-layer perceptrons. Here since they have talked only about perceptron, we are considering only single layer. So this learning method is also called as the delta rule. Rule in the sense this is how you will be learning in the case of neural network. So in that aspect, if you take, even if you don't have any idea, you will be able to match that. So B will be mapping to 1. What about activation function? It is one of the key components of the perceptron as in the most common neural network architecture. Even if you take multi-layer neural network, after every layer, some kind of activation functions will be applied. Say for example, some hidden layers will have certain kinds of activation function. The output layer will have some kind of activation function. So it all depends upon what kind of training it is undergoing. But in general, this activation function is a key component of neural network. So we can map A to 2. A2 and B1 is also present here. So always start with the statement in list 1 or list 2, whichever is comfortable for you. Through that option you can start ruling out the other options so that you can easily find the right answer. Next question, match list 1 with list 2. List 1 has some areas of artificial intelligence or some topics from artificial intelligence. List 2 has descriptions about them. So we will go with list 2. From list 2 we will try to map it to list 1. The first one, a method of training algorithm by rewarding desired behavior and or punishing undesired one. So when a desired behavior is exhibited, we go for a reward. When an undesired behavior is exhibited, we punish. So this is actually giving some kind of feedback to the training. So this feedback is what we can term it as reinforcement learning. So only in reinforcement learning you will have rewards for acceptable behaviors and punishment for unacceptable behaviors. So we can map B to 1. B1 is available in only one option. Next we will go for the second one. System designed to emulate the decision making abilities of a human expert. Emulate in the sense you can take it to be simulation and more than that. From the term human expert you can get the right term. Expert system is the system designed to emulate the decision making abilities of human. Expert system D will be mapping to 2. So this is D2. The third statement, a branch of artificial intelligence focused on understanding and generating human language. This term will help you map it to ANLP. Natural language processing is a branch of AI that focuses on generating human language as well as understanding human language. This human expert hints expert system. This human language again hints NLP from list 1. So A3 is also right. What about the fourth one? A machine learning technique that finds the hyperplane that best separates different class in a feature space. So if you have learnt about support vector missions, you could have come across the term hyperplane. This hyperplane will actually divide the complete set of data into different classes. If you want to have an overall idea about SVM as well as other machine learning algorithms, I would like you to watch ML series that is available in the channel. This series is done in Tamil language, but the contents in the video are in English. Even if you don't understand Tamil, you will be able to understand what is present in the video. So support vector mission will be mapping to 4. C4. So we will go with option 3 as the right answer. Next question. We have given a comprehension and we are asked to answer the question. Let's read the passage. Artificial neural networks are computational models inspired by the human brain's neural networks. They consist of interconnected nodes or neurons organized into layers. An input layer, one or more hidden layers and an output layer. Each connection between neurons has a weight that adjusts as learning progresses, allowing the network to adopt and improve its performance. Artificial neural networks are particularly effective in recognizing patterns, making them valuable for tasks such as image and speech recognition, natural language processing, and predictive analytics. Learning in artificial neural networks typically involves training algorithms like backpropagation, which minimize the error by adjusting the weights. As a subset of machine learning, artificial neural networks have revolutionized the field of artificial intelligence by providing solutions to complex problems that traditional algorithms struggle with. So overall, the story is about ANN. So they say this particular ANN is inspired from human brain's neural network, our own nervous system, and it's all about the interconnected neurons. They are organized into different layers. So we have input layer, then we have one or more hidden layers, then we have the output layer. Here every neuron will be associated with a weight as learning progresses, allowing the network to adopt and improve the performance. So based on this weight adjustment only, this performance is going to improve. They have given applications of ANN as effective in recognizing patterns so that we can use it for image recognition, speech recognition. So what is image recognition? If you take an image, you should be able to recognize whether it's a cat or a dog or a human. So you need some pattern recognition technique in order to find what is present inside the image. Similarly, it goes with speech recognition, and same it goes with NLP and predictive analytics. So learning involves training algorithm like backpropagation. Just now we have seen in a question. So this minimizes the error by adjusting the weights, and it is done to improve the performance. So the predicted output and the actual output case that I was talking earlier is what they say. This is actually a subset of machine learning. If you watch machine learning series or deep learning series in my channel, there is a playlist. AI will be like this. Inside AI you will have machine learning, and inside machine learning this will be a subset. So neural network will be a subset of machine learning only. So they have actually revolutionized the field of AI by giving solutions to complex problems. So when we cannot solve certain problems by traditional algorithms, we seek the help of neural networks. So let's start answering the question. What is the role of backpropagation algorithm? To reduce error, to secure network, to control speed of data, to add different layers. The layers are already added. There is nothing to do with the speed of data, and nobody is going to secure this network. So the only option that is meaningful is to reduce error. Option number 1 will be the right answer. So here they have given training algorithms like backpropagation minimizes the error. How does it do? By adjusting the weights. So from this line you should be able to find the answer. Next question. Artificial neural networks are inspired by quantum mechanics, human brain's neural network, computer hardware architecture, genetic algorithm. Human brain's neural network is what they have given directly here. Option number 2 will be the right answer. Next question. Which of the following layers may be more than 1 in number? So generally when you take neural network, there will be definitely one input layer and one output layer. In between you can have one or more hidden layer. So which can be more than 1 in number? Option number 2, hidden layer, will be the right answer. Physical layer doesn't belong to artificial neural network. Next question. What is the role of weights in an artificial neural network? So I have already told, only by adjusting the weights we can improve the performance. So there will be an actual output and a predicted output. When we train the neural network again and again, this predicted output should match the actual output. So it has to minimize the error by updating the weight. Overall, by weight updation, what happens is it allows the neural network to improve the performance. So they say each connection between neurons has a weight that adjusts as learning progresses. So the role of weights will be to adjust and improve network performance. Option number 2 will be the right answer. It is not going to store data, it is not going to control the speed, and it has nothing to do with network security too. This network is neural network and not computer networks. Next question. Which of the following are the application areas of artificial neural network? So we have been given some areas here. ANNs are particularly effective in recognizing pattern, which makes them valuable for tasks such as image and speech recognition, natural language processing, and predictive analytics. So let's see the options. A, NLP is there. Image processing. In order to find what is inside the image, you have to process the image. So definitely B is there. Pattern recognition is what they have given. Only by pattern recognition they are able to apply it in image and speech recognition tasks. So this is also there. And speech recognition is also given as an application. Option number 4, A, B, C and D will be the right answer. So once again let me tell you, there are actually 2 playlists in my channel. One is machine learning series and another one is deep learning series. If you have no idea about all these neural networks or artificial intelligence, I would like you to watch them for a basic understanding. The series is available in Tamil, but everybody can understand irrespective of the language. With this, we are completing Unit 10 solutions.